and will keep drifting, floating together through the histories 11 plus hours of Atlas. 3 AI Mysteries, a sleep science compilation. This series includes mysteries about Atlas 3 AI's cryovolcanism, Comet, Pulse, Seed, and Color for over 11 continuous hours of soothing calm. This compilation draws on the soothing frequencies and concepts to create the ultimate backdrop for deep sleep. Tune into the void, let this sleep science wash over you, and sleep soundly through the night. These videos provide a unique, deep auditory background for the perfect night's rest. This is your weekly dose of 3i Atlas, brought to you by the Sleepy Science 100 channel. Tonight we follow a comet that came from another star, a visitor carrying the immense, unstoppable momentum built over billions of years in the galactic void, moving at 68 kilometers per second, fast enough to defy our sun's gravity forever, on a hyperbolic trajectory that guarantees it will sweep through our solar system once, and then depart into the cold, never to return. Before we drift further into the quiet cosmos, if you enjoy exploring the deep science of sleep and space, please consider subscribing. Liking the video helps us know these cosmic journeys resonate with you. If you're still awake, we invite you to comment with one word describing how you hope to feel in the morning, such as rested or calm. Now, let us settle in. Thank you for joining us tonight as we drift far, far out with this ancient messenger from beyond. We begin on July 1st, 2025, when telescopes in Chile, part of the Atlas Survey Network, caught the faintest whisper of light, a single point, moving, retrograde, backward against the planet's steady dance around our sun. This silent visitor, this ancient drifter, carried no name yet, only coordinates, only the mathematical signature of something profoundly different, something unbound. The astronomers watched, measured, calculated, and within days, they knew. This was no ordinary comet captured in our star's embrace. This was a messenger from the void, a transient galactic visitor on a hyperbolic path, meaning it would arrive, sweep close, and depart forever into the cold, never to return. Let yourself settle now, as we explore what it means to be unbound, to carry such velocity that no star can hold you. The orbital eccentricity, a number that describes the shape of a path through space, was measured at greater than 6.1. In our solar system, planets move in gentle ellipses, eccentricity near zero, circular, captured, bound by gravity's patient hand. But when eccentricity exceeds 1, the orbit opens, becomes a parabola, a hyperbola, a one-time curve that bends but never closes. This comet, this third confirmed interstellar object, designated 3i Atlas, with the prefix 3i marking its origin beyond, carries an eccentricity so high that escape is not a possibility, it is a certainty. Written in the mathematics of celestial mechanics, hyperbolic letting go encoded in every measurement, the discovery itself, part of the Atlas Survey's patient vigil, detecting thousands of objects every year, asteroids, comets, the debris of our local neighbourhood, but this one, moving at angles that whispered of elsewhere. The Minor Planet Center, in July 2025, announced its status, confirmed through collaborative observations, telescopes around the world, Gemini North in Hawaii, Hubble orbiting silent above our atmosphere. the Gaia satellite contributing its precise astrometric data, all watching this dark nucleus, this ancient silent drifter estimated between 0.5 kilometre and several kilometres across, its exact size uncertain, for its albedo is low, its surface dark, absorbing light rather than reflecting, making it faint, elusive, a shadow passing through. Breathe gently and feel the unstoppable quiet vector of this journey. By late October 2025, the comet reached perihelion, its closest approach to our Sun, at 1.36 astronomical units, roughly 200 million kilometers from the solar surface, far enough to remain cool, yet close enough that the Sun's heat began its work. Solar radiation, photons travelling 8 minutes from fusion core to frozen ice, struck the nucleus, and the ancient ices, untouched for billions of years, for deep time beyond human comprehension, began to sublimate, ice becoming gas directly, no liquid phase in the vacuum, water molecules, carbon dioxide, frozen volatiles from a distant stellar nursery, all awakening, puffing outward, creating a teardrop-shaped coma, a temporary atmosphere thousands of kilometers wide, surrounding the dark, solid heart. And here, at perihelion, the comet's velocity peaked 68 kilometers per second. Think of that, not per hour, per second. If you could somehow ride this nucleus, you would cross the distance from New York to Los Angeles in less than a minute. This speed, this unstoppable momentum, built over eons in the galactic void, through the slow rotation of our Milky Way, through gravitational assists from long-forgotten stars, through 10 billion years of linear drift between the lights. Now, passing our Sun, the star's gravity bent the path slightly, curved it, but could not capture. For the escape velocity at Earth's distance is only 42.1 kilometers per second, and this visitor carried far more. It swept through, acknowledged our star with a temporary brightening, a tail forming briefly, then continued outward, velocity's assured departure. Let us drift together through what the telescopes revealed. The comet glowed green, a soft ghostly hue captured by ground-based instruments. This colour, this primordial cold whisper visible for only weeks, comes from diatomic carbon, C2 molecules released in the coma, excited by solar ultraviolet light, emitting at a wavelength our eyes perceive as green. The same process that gives some comets their eerie luminescence. But this green carried a different story, for the chemistry was pristine. Standard cometary composition. Yes, but untouched by the formation of planets, unaltered by the heat and pressure of our solar nebula's collapse. These were ices that froze in another system, around another star, perhaps one now dead, its light extinguished, its planets scattered or consumed, and this fragment, ejected in some ancient catastrophe, has been falling through the galaxy ever since. The observations continued. Hubble Space Telescope, in December 2025, captured post-perihelion images, revealing the coma contracting as the comet moved away from the Sun, receding toward Mars' orbit and beyond. The outgassing slowed, the temporary tail, smaller than those of local comets, dissipated quickly, a tail's temporary sigh as sublimation ceased. The comet returned to its frozen state, solid ice once more, chemically pristine post-visit, carrying its load of history back into the dark, and the JUICE probe, Jupiter Icy Moons Explorer, on its own long journey to the outer system, happened to be positioned to image this visitor. Data transmitted across the solar system, arriving in February 2026, adding another perspective, another angle to triangulate the path. Feel the deep time, eternal rest of this object's existence, born perhaps 4.5 billion years ago, when our own solar system was forming, or even earlier, in the first generations of stars after the Big Bang. Pristine ices that date to galaxy formation eras, to when the Milky Way was young and violent, stars forming in great bursts, then dying, exploding, scattering their remains, and from those remains, new stars, new planetary systems, and in the chaos, ejections, gravitational slingshots, sending comets outward into the void, into the space between stars. There, for billions of years, it drifted. The galactic plane travel estimated at 10 billion years, dwarfing human timescales in age and journey, dwarfing civilizations, geological epochs, the entire span of complex life on Earth. On December 3rd, 2025, another revelation. XMM Newton, an X-ray observatory in orbit, detected X-ray emissions from the comet. This was unexpected. Beautiful. These X-rays, produced by interaction with the solar wind, charged particles streaming outward from our sun, colliding with the neutral gas in the OMI, stripping electrons, creating brief flashes of high-energy light. It suggests the solar wind embraced this visitor, however briefly, marked its passage. The comet, absorbing most incoming light with its dark nucleus. Low reflectivity contributing to faint appearance, nevertheless revealed itself in invisible wavelengths, in frequencies we cannot see but instruments can detect. Now, as you relax deeper, consider the orbital inclination, approximately 175 degrees. This is retrograde motion, meaning the comet travels opposite to the planet's orbital direction. While Earth and Mars and Jupiter circle the Sun counterclockwise as viewed from above the North Pole, this visitor swept in from below, climbed steeply upward through the ecliptic plane, that invisible disk where the planets orbit, cutting across at a steep angle. Inclinations unique cut through our orderly system. This geometry, this path, minimizes planetary interactions. No close encounters, no gravitational tugs from Jupiter's massive bulk, no deflection by Saturn's rings. The comet passed through, aloof, on its linear infinite path, acknowledging our system with the briefest curve near Sun, then resuming straight outward motion, its closest approach to Earth. December 19th, 2025, at 1.8 astronomical units, roughly 167 million miles away. Far, safe, no threat. Just another point of light for those with telescopes to see. Human observation window lasting only months. For by now, late December, it has already crossed the orbit of Mars, moving outward, fading, too faint now for most amateur telescopes, visible only to professional observatories that continue monitoring, tracking its position, measuring its slow deceleration as the Sun's gravity, though unable to capture, nevertheless pulls gently backward. The comet's speed slows gradually as it recedes from the sun, but never enough to stop, never enough to turn it around. Let yourself surrender to the weightless, vast surrender of this journey. By early 2026, the comet will pass near Jupiter's orbital plane, 5 astronomical units from our star. Though Jupiter itself will be elsewhere in its 12-year orbit, no encounter, just a crossing of paths in space-time, then outward towards Saturn's distance, Uranus, Neptune, crossing into the scattered disk region, that realm of icy bodies beyond the planets, the beginning of the solar system's true edge, and beyond that, the Oort cloud, that vast spherical shell of dormant comets, reaching perhaps a light-year outward, taking tens of thousands of years to traverse even at this speed. Oort cloud passage occurring at the solar system's edge, a fragile farewell to the last remnants of our sun's influence. The destination, after the Oort cloud, is the heliopause, the boundary where the solar wind, that stream of charged particles, finally yields to the interstellar medium where our sun's magnetic influence, its heliosphere, ends and true interstellar space begins. Heliopause's true threshold, perhaps 120 astronomical units distant, the Voyager probes, humanity's most distant emissaries, crossed this boundary after 40 years of travel. But this comet, at 68 kilometers per second initially, slowing but still swift, will cross in a fraction of that time, entering the interstellar medium's calm vacuum, the space between stars, where matter is so sparse that a cubic meter might hold only a single atom, where light from our sun becomes just another star, faint, indistinguishable. And then, the voyage measures in light years post-solar system, heading toward the constellation Ursa Major, Ursa Major's distant call, the Great Bear, where from our perspective the stars seem fixed, but in reality are moving, orbiting the galactic center, just as our sun orbits, just as this comet now orbits, though on a trajectory so elongated, so open, that it will never complete even a fraction of a galactic revolution before intersecting with something else, or simply drifting for geological ages, deep time, eternal rest between the lights. Feel now the solitary stellar messenger quality of this object. It carries information, data encoded in its chemistry, its isotopic ratios, its dust to ice proportions. These provide insights into extrasolar comet populations, into how planetary systems form around other stars, into the composition of molecular clouds light years away. Scientists analyzed the light spectra, breaking the faint glow into constituent wavelengths, searching for unusual signatures, biosignatures, complex organic molecules, anything unexpected. They found standard cometary composition: water, carbon dioxide, carbon monoxide, silicate dust. No surprises, yet profoundly illuminating, for it confirms that the chemistry of comet formation, whether here or around a star 50 light-years away, follows universal rules, the same physics, the same thermodynamics, nucleus of hidden history revealing familiar patterns. Similar to 1E Oumuamua, the first confirmed interstellar visitor, detected in 2017, that mysterious elongated object that showed no cometary activity, no coma, no tail, and accelerated slightly as it left, puzzling scientists. and similar to 2I Borisov, discovered in 2019 by amateur astronomer Gennady Borisov, a comet that showed typical activity, a clear coma and tail, confirming that interstellar comets behave much like local ones. Borisov had a more eccentric orbit than 3I Atlas in some measurements, but both shared that essential quality: hyperbolic, unbound, transient galactic visitors on one-way journeys. Each discovery, Oumuamua, Borisov, now Atlas, teaches us that these visitors are perhaps common. Perhaps the galaxy is full of wanderers, ejected comets, rogue planets, fragments, all drifting in the space between, occasionally intersecting a star system, briefly visible, then gone. Now, breathe into the eccentricity's open embrace, that mathematical openness. When eccentricity equals 0, you have a perfect circle. When it's between 0 and 1, an ellipse, a closed curve, bound. When it equals 1, a parabola, balanced at the edge of escape. And when it exceeds 1, as with 3 Atlas at greater than 6.1, you have a hyperbola, 2 branches, but the comet follows only one. The open curve that arrives from infinity, bends around the sun, and departs toward infinity. Non-capture, gentle release guaranteed by physics. No amount of wishful thinking could keep this visitor here. The math forbids it. The energy forbids it. It carries too much kinetic energy. Velocity's assured departure. Unstoppable quiet vector aimed at the void. The Doppler shift measurements, watching how light wavelengths stretch and compress as the comet moves, confirmed its high velocity, allowing astronomers to calculate not just speed but direction, three-dimensional motion through space. These astrometric data from multiple telescopes, tracking its position night after night, week after week, allowed precise trajectory refinement. Gemini North Telescope, with its adaptive optics correcting for atmospheric turbulence, revealed changes in the comet's appearance after solar passage, subtle shifts in the coma's shape, variations in brightness, interleaved frames from videos showing dynamic changes as gas puffed outward in bursts, then subsided. The sublimation rate peaked at perihelion, then declined sharply, following the inverse square law of solar heating. Double the distance, 1/4 the heat. The gas puff that created the faint coma expanded to thousands of kilometers near perihelion, a delicate envelope of vapor, then contracted, condensed, as the comet climbed outward toward Mars and beyond. Let your mind rest on the idea of non-periodic motion. Most comets we know are periodic. Halley's Comet returning every 76 years, Encke's Comet every 3 years, Hale-Bopp gracing our skies once per millennia. But 3I Atlas is non-periodic, meaning no return to the inner system. Its path is not an ellipse but a hyperbola, fleeting solar courtesy. One visit, one brief acknowledgement of our star, then eternal departure. We saw it once. Humanity's telescopes caught this ancient drifter for a few months in 2025, and we will never see it again. Not in our lifetimes, not in our civilization's lifetime, not in the lifetime of our species. It will be gone, travelling outward, while we spin here on our small world, orbiting our ordinary star, watching other visitors, other comets, but never this one again. The comet likely originated from a long-dead star system. We cannot know which star, cannot trace it back. For stars move, drift in their orbits around the galactic center, and in the billions of years this comet has wandered, its parent star may have moved thousands of light years from where the ejection occurred, or the star may have exhausted its fuel, collapsed into a white dwarf, a neutron star, a black hole, its planets, if it had any, scattered, consumed, vaporized, and this comet, perhaps one of millions ejected in the system's death throes, escaped into the deep, into the eons of untouched peace between the stars, carrying with it the frozen memory of that system, pristine ices from a distant stellar nursery now wandering the galaxy, unbound cosmic freedom expressed as velocity and trajectory. Feel the curve to straight independence of this path. Near the sun, gravity bent the trajectory. The comet fell inward, accelerated, whipped around perihelion in a sharp curve, then climbed back outward. But as distance increases, as the sun's gravity weakens with the square of the distance, the curve straightens, asymptotically approaching a straight line, linear motion dominating post-perihelion. The hyperbola's branches, one coming in, one going out, both approaching straight lines at infinity. This comet entered our awareness on one branch, curved through perihelion, and now exits on the other branch, gradually straightening its path until it moves in an almost perfectly straight line through this void. Momentum from galactic ejection event restored, the sun's influence fading to nothing, becoming one more faint star among hundreds of billions. No fragmentation was observed, unlike some comets that crack under thermal stress, breaking into pieces. This nucleus remained intact, solid, cohesive, perhaps held together by pristine ice more pure than local comets. Ices that never experienced the heat cycling of orbits near the sun, never weakened by repeated sublimation. This was the first heating, the first thermal stress in billions of years, and the nucleus endured, returned to frozen silence, its structure maintained, ancient momentum preserved, continuing outward as a single dark body, low reflectivity, faint, vanishing from our instruments as distance and faintness conspire to make it invisible. Planetary perturbations, the gravitational nudges from Jupiter and Saturn that can dramatically alter a comet's path, had no significant effect. The trajectory was too steep, too inclined, too fast. The comet passed through the plane of planets, cutting through at angles that minimize interaction time. No close planetary encounters affected its path. It swept through, clean, unperturbed. Its hyperbolic excess velocity, that extra speed beyond escape velocity, ensuring that even if a planet had approached, the deflection would be minimal, a slight wobble in a path that remains fundamentally outward bound. Now, as we drift deeper into rest, consider the temporary tail. Comets grow tails as they approach the sun, but 3i Atlas's tail was smaller, fainter, briefer than those of captured comets on elliptical orbits. Those local comets, like Hale-Bopp or Hyakutake, swing close to the sun repeatedly over their lifetimes, building thick mantles of dust on their surfaces. When heated, they produce spectacular tails millions of kilometers long, glowing bright enough to see with the naked eye. But 3i Atlas, on its first and only pass, had no such mantle. Its surface was pristine, relatively fresh ice. The tail formed, yes, From sublimation, gas and dust streaming away, pushed by solar wind and radiation pressure. But it was modest, a temporary sigh, a brief acknowledgement, then dissipating quickly. The tail's temporary sigh, here, then gone, as the comet receded and the solar wind's influence waned. By mid-December 2025, it had already crossed Mars' orbit, moving at 40-some kilometers per second, slower than at perihelion but still immense by human standards. The distance now beyond 2 astronomical units, expanding daily. It fades in telescopes, magnitude dropping, becoming invisible to all but the largest instruments. Ongoing fade as distance increases, light from the sun weakening, the comet's reflected light diminishing. Soon it will be detectable only by extrapolation. Astronomers will know where it should be, but no longer see it directly. A phantom, a mathematical trajectory, a memory of those months when it was visible, when humanity briefly watched an ancient drifter pass through our neighborhood. Professional observatories continue monitoring when possible, allocating precious telescope time to track this visitor as long as photons allow. Each additional data point refines the trajectory, reduces uncertainty, helps predict its future path through the galaxy. Though prediction on billion-year timescales is impossible, too many unknowns, too many perturbations from molecular clouds and passing stars, the near-term path, the next 10,000 years, can be calculated with confidence. Linear drift, straight out, toward Ursa Major, then deeper into the Orion arm of the galaxy, then into the space between spiral arms. Then, who knows, perhaps an encounter with another star system in 100 million years. Perhaps not. Perhaps it drifts for 10 billion more years without coming near another sun. Void's unlit certainty embracing it in darkness and cold and silence. Think now on the idea that this comet provides data on extrasolar materials, on the chemistry of somewhere else. Scientists use spectroscopy, analysing light absorbed and emitted by the coma, to determine which molecules are present. Infrared observations reveal thermal emission, temperature, heat distribution across the nucleus. Radio observations might detect molecules like water or carbon monoxide. Each technique adds a piece, a fragment of understanding. These measurements inform models of interstellar object populations, helping estimate how many such visitors pass through the solar system undetected each year, how many faint, dark, moving too fast or at wrong angles for our surveys to catch. For every one we detect, there may be dozens or hundreds we miss. The galaxy may be full of these wanderers, and we, orbiting our quiet star, see only the brightest, the closest, the ones that happen to pass through our detection grid at the right time and place. As you feel yourself growing heavier, more relaxed, let yourself merge with the galactic rotation's slow gift. Our sun orbits the center of the Milky Way at roughly 220 kilometers per second, completing one orbit every 200 million years. The stars around us, neighbors in the Orion arm, orbit at similar speeds, creating a local frame of reference where we seem stationary relative to each other. But 3I Atlas, ejected from some other star in some other orbit, carried the velocity signature of its origin. When it entered our local frame, it appeared to move retrograde, steeply inclined, hyperbolic because it was inserted into a different flow, a different current in the galactic river. The galactic rotation over billions of years built its initial momentum, gave it that unstoppable vector, and now, passing through our solar system, it neither gains nor loses much, just curves slightly, a minor deflection in a journey measured in cosmic ages. The discovery by Atlas, a network designed to detect near-Earth asteroids, potential impactors, hazards, found instead a gift, a messenger from beyond. Atlas discovery highlights survey importance, for we build these networks to protect Earth, to find rocks that might strike us. But in the process, we map the sky, catalogue motion, and occasionally we find something wondrous, something unexpected, an interstellar comet, a rogue planet, a piece of the greater galaxy revealing itself. These surveys, scanning night after night, automated, tireless, are humanity's constant vigil, eyes on the sky, watching, waiting, and when something anomalous appears, when motion suggests otherness, astronomers awaken to the challenge, the opportunity. And so 3i Atlas, this third in sequence, follows Oumuamua and Borisov into the history books, each one teaching us, each one slightly different. Oumuamua's strange acceleration and lack of coma, Borisov's normalcy, its familiar cometary behaviour, and now Atlas, with its retrograde sweep, its greenish glow, its X-ray emissions, together painting a picture of diversity. There is no single type of interstellar visitor. They vary, each carrying its own story, its own chemistry, its own vector through the void, and we are learning to recognize them, to calculate their orbits quickly, to observe them before they fade, each one a lesson, each one a step toward understanding our place in a galaxy full of wanderers. The scattered disk will be traversed next, that region beyond Neptune, between 30 and 100 astronomical units from the Sun, populated by icy bodies like Eris and Makemake, remnants of planetary formation scattered outward by gravitational interactions billions of years ago. 3i Atlas will pass through this realm in the coming years, decades, its velocity ensuring swift passage, no capture, no lingering, just transit. Then the Oort cloud, beginning around 2,000 astronomical units, extending perhaps to 100,000 AU or more, a vast sphere of frozen comets, perhaps trillions of them, surrounding our solar system like a diffuse shell. The comet will spend millennia crossing this zone, finally exiting into true interstellar space, the realm beyond any star's gravitational dominance, galactic silence receiving it back. Feel now the ancient momentum, billions of years in the making. It began with an ejection, perhaps a close pass by another planet, a gravitational slingshot from a gas giant in that distant system, launching the comet outward at escape velocity from its parent star. From there, it fell into the galactic potential, the gravitational field of the Milky Way itself, gaining speed as it descended from the galactic halo toward the plane, or losing speed as it climbed. Impossible to know without knowing where it started. But its current velocity, that 68 kilometers per second at perihelion, is the sum of all those influences: the ejection, the galactic fall, the chance encounters with molecular clouds and stellar winds over eons, all accumulated, all preserved, for in space there is no friction, no drag. Momentum once gained is kept, velocity enduring across deep time until something intervenes, and nothing intervenes significantly, not for billions of years. It drifted, passed between stars, perhaps through the outer reaches of other systems without being detected, for detection requires both proximity and observation. If a comet passes through a system but no one is watching, does it leave a trace? It does not. Not in any record we can read. But this time, this system, our system, humanity happened to be watching, happened to have the technology, the telescopes, the orbital calculations, the international collaboration, and so we saw, we measured, we confirmed. This is an interstellar visitor. This is a piece of elsewhere, and we have studied it during its brief time in our light. The pristine composition, chemically pristine post-visit, unchanged by its passage, tells us it barely interacted. The heat from the sun's sublimated surface ices, a few meters deep perhaps, releasing gas and dust that had been frozen since the comet's formation. But beneath that surface layer, the interior remains untouched, still holding the isotopic ratios, the molecular structures, the frozen history of its birth cloud. When it returns to the cold of interstellar space, when the last traces of warmth radiate away, it will refreeze completely. Any cracks from thermal expansion will seal, and it will continue, a time capsule, until perhaps millions of years hence, it encounters another star, another chance for brief warmth, brief activity, before resuming its eternal cold distance. Now let your breathing slow to match the pace of cosmic time, where a human lifetime is less than a heartbeat, where civilizations rise and fall in eye blinks, where the drift of continents, the erosion of mountains, the evolution of species are all fleeting moments in the journey of a comet through the galaxy. Deep time, eternal rest. Not rest as in stillness, but rest as in inevitability, as in the absence of struggle. The comet does not fight its path, does not resist. It simply moves, following the geometry of space-time, the curve created by mass and energy. It is the perfect expression of surrender to physics, to gravity, to inertia, weightless, vast surrender, not falling. For there is no up or down in space, but following the geodesic, the straightest possible path through curved space-time, and that path leads out, away, forever. Consider the scattered disk and Oort cloud as transition zones, not boundaries but gradients. The sun's gravity never truly ends. It extends infinitely, weakening with distance but never zero. Yet at some point, the gravity of nearby stars, the collective gravity of the galactic disk, becomes comparable, then dominant. The heliopause marks where solar wind yields to interstellar medium, but gravitational influence extends much farther. Oort cloud comets at 50,000 AU are still technically bound, orbiting the Sun on ellipses so elongated that one orbit takes millions of years, but 3I Atlas, even at such distances, will still be moving faster than escape velocity, will still be leaving. The Sun's gravity pulls, slows it fractionally, but cannot reverse the motion, cannot close the hyperbola into an ellipse. The mathematics forbid it. Eccentricity too high, energy too great, And so we arrive at a place of stillness in our minds, even as the comet rushes outward at tens of kilometers per second. For stillness is not about motion, it is about acceptance, about allowing what is. The comet has no choice but to follow its trajectory, and we, watching, have no choice but to let it go, to witness its departure, to know that this visitor graced us once, and only once. There is a peace in that, in the certainty of the hyperbolic, in knowing that some things are not meant to stay, not meant to be captured. They arrive, share their light, and move on, leaving us changed by the encounter, enriched by the knowledge, but not possessing. Never possessing, only witnessing, only grateful for the brief overlap of paths in the vastness. And as the interstellar medium's calm vacuum receives this wanderer back into its cold embrace, we too can release, can let go, can drift in our own thoughts like solitary stellar messengers, each of us on our own trajectory through time, each of us carrying our own hidden history, our own nucleus of memories and experiences, sometimes drawing close to others, sharing warmth, then moving on, continuing our journey through the infinite. And in this parallel, this metaphor of comet and consciousness, we find a deep resonance, a stellar whisper that says, it is enough to pass through, it is enough to be seen, however briefly, it is enough to move, to change, to release what cannot be held. And in that release, in that unbound assurance, we find not loss, but freedom, not ending, but continuation, the voyage that measures beyond any single moment, beyond any single lifetime, the voyage into deep time, into the vast dark calm, where everything that has ever been, every particle, every wave, every thought, continues, transforms, integrates into the larger pattern, the galactic weave, the cosmic tapestry, and there is no true separation, only distance, only the apparent isolation of the linear infinite path, but beneath, connecting all, the shared origin in stellar fusion, in the Big Bang's first expansion. We are all, comet and planet and person, made of the same elements, forged in the same cosmic fires, and the comet's departure is not exile but homecoming, returning to the space from which it came, to the primordial quiet between the stars where matter rests, drifts, and occasionally, just occasionally, finds itself bathed again in starlight, in temporary brightness, before returning once more to the darkness that is not empty, but full of potential, full of the yet to be. And as we contemplate this, as we follow the trajectory in our minds, out past Mars, past Jupiter, past the scattered ice and the Oort's fragile farewell, we too travel, not in body but in imagination, in the shared human capacity to extend our awareness beyond our immediate surroundings, to touch, however conceptually, the infinite, and in that touching, we are changed, we are expanded, we are reminded of our smallness and our vastness simultaneously, small in physical scale, a planet tiny against the cosmos, but vast in awareness, in the ability to comprehend trajectories that span billions of years, to measure velocities that exceed our fastest rockets, to detect the faint greenish glow of sublimating carbon molecules 200 million kilometers distant. This is the gift of consciousness, of scientific observation, that we can know what we cannot touch, can understand what we cannot hold, can follow in thought what moves beyond our reach. The greenish glow, that diatomic carbon emission, faded as December progressed. As the comet crossed beyond Mars's orbit, approaching 2 astronomical units from the Sun, the solar heating diminished, followed the inverse square law with mathematical precision. At twice the distance, 1/4 the energy. At 3 times the distance, 1/9. The sublimation that required solar photons to break the molecular bonds of ice, to provide the energy needed for solid to become gas, slowed, stopped. The coma that had expanded to thousands of kilometers, that teardrop shape pointing away from the sun, contracted. The gas dispersed into the vacuum, molecules spreading out, density dropping, until the coma was no longer visible, just the dark nucleus remaining, absorbing 95% or more of incident light, reflecting only a tiny fraction back toward Earth, where our telescopes strained to follow it, to maintain lock on this fading point, this ancient silent drifter becoming silent once more, returning to the state it had maintained for eons, frozen, dormant, dark. Let yourself sink deeper now into the comfort of darkness, of the void's unlit certainty. We fear darkness sometimes, associate it with danger, with the unknown. But in space, darkness is the natural state, the resting state. Stars are the anomaly, the brief bright sparks, and between them, the overwhelming majority of space exists in darkness, in cold measured at 3 degrees above absolute zero, the cosmic microwave background radiation, the afterglow of the Big Bang, still echoing through everything. This is the environment that 3i Atlas knows best, not the brightness of perihelion, not the temporary warmth, but the cold, the dark, the silence of the interstellar medium where sound cannot travel, where there is no air to carry vibrations, only electromagnetic waves, only gravity's patient pull, only the occasional impact of a stray hydrogen atom, 1 collision per century perhaps at these densities. This is true isolation, true solitude, solitary stellar messenger carrying its message through empty space. And yet, not truly empty, for even the vacuum seethes with quantum fluctuations, virtual particles appearing and annihilating, the fabric of space-time itself alive with mathematics. The observations from XMM Newton on December the 3rd revealed those X-ray emissions, photons with energies far higher than visible light, produced when solar wind protons, travelling at 400 kilometers per second from the sun's corona, collided with neutral gas atoms in the comet's coma. The collision strips an electron, creates a temporary ion, and as electrons cascade back to lower energy states, X-rays flash forth. This same process occurs with all comets that come close enough to interact with solar wind. But for an interstellar visitor, these X-rays mark perhaps the first time in billions of years that the comet's material has interacted with stellar wind, the solar wind of its parent star, long ago in the distant past, and now our sun's wind, embracing it briefly, marking it, exchanging energy, before the comet moves beyond the heliopause eventually, where solar wind pressure equals interstellar wind pressure, where our star's influence finally, truly, ends. Feel the hyperbolic release in your own body, the letting go of tension, of held breath, of gripped muscles, just as the comet releases its gravitational bond with the sun, never to be recaptured. You can release what you've been holding, thoughts of the day, worries about tomorrow, tensions in your shoulders, your jaw, your hands. Let them sublimate, like ice in sunlight, solid concerns becoming vapor, dissipating. The comet teaches us that release is not loss, that departure is not failure, that unbound can mean free rather than abandoned. Its hyperbolic orbit is not a rejection of the sun, not an escape from danger, simply the continuation of a journey that began long before, that will continue long after. The curve is temporary, the straight path is eternal, and in that eternal linear drift, there is peace, there is the absence of struggle, there is the deep time rest of knowing your trajectory, accepting it, following it without resistance. By January of 2026, the comet will be approaching 3 astronomical units, nearly 450 million kilometers from the sun. Out there, sunlight is weaker, the solar constant, that measure of energy received per square meter, drops to 1/9 its value at Earth. The comet is cold again, perhaps 100 Kelvin, perhaps less. Any water ice is solid, carbon dioxide frozen, volatiles locked in matrix of rock and ice. The nucleus rotates, we think, though the period is unknown, perhaps hours, perhaps days. Each rotation brings different faces toward the distant sun, but all faces are equally dark, equally cold, equally unchanged by the brief warmth of perihelion. The surface may have weathered slightly, microfractures from thermal expansion and contraction, a thin mantle of dust left behind as ice sublimated away, but structurally, chemically, it remains what it has always been, nucleus of hidden history, archive of a stellar system lost to time. The velocity now, perhaps 40 kilometers per second, slower than at perihelion but still immense, still far exceeding escape velocity even at this distance, still guaranteeing departure. The deceleration is asymptotic, approaching a limit but never reaching zero, for gravity extends infinitely and the sun will pull, however weakly, forever, or at least until the sun itself dies, expands into a red giant 5 billion years hence, swallows the inner planets, then collapses to a white dwarf. But even that cataclysm will not affect this comet. By then, it will be light years away, hundreds of light years, far beyond any influence, continuing its galactic orbit, its path through the Milky Way, moving perhaps toward the galactic anticenter, or perhaps tangentially, perpendicular to the disk. We cannot know without more precise measurements of its three-dimensional velocity vector, but we know it moves, unstoppable quiet vector, aimed at eternity. Rest now in the knowledge that we are watching a process that happens constantly throughout the galaxy. Stars form in clusters, in nebulae where gas collapses under its own gravity, fragmenting into hundreds or thousands of protostars. Each star forms a disk of material, and from that disk, planets may coalesce, and comets, and asteroids. But gravitational interactions, especially with massive planets, eject a fraction of this material. Perhaps 10% of comets formed are thrown outward, sent into interstellar space. Multiply that by 400 billion stars in the Milky Way, and the number of interstellar comets becomes astronomical. Trillions upon trillions, all drifting, all on their own trajectories. Occasionally one passes through our system, and we see it, name it, track it. But for every one we detect, countless others pass unnoticed, too faint, wrong trajectory, bad timing. The galaxy is full of these wanderers, void integration occurring constantly, comets merging into the interstellar population, becoming part of the diffuse matter between stars. The JUICE probe's observations, data arriving in February 2026, will add another perspective. JUICE, launched years earlier toward Jupiter's moons, happened to be in position to image 3I, Atlas, from a different angle than Earth-based telescopes. This parallax, this difference in viewing angle, helps triangulate distance and motion more precisely, refines orbital parameters, reduces uncertainty. Each telescope, each observation, each wavelength adds a piece to the puzzle. Visible light shows the coma and color. Infrared reveals temperature. X-rays show solar wind interaction. Radio might detect specific molecules. Together, a multispectral portrait, a comprehensive understanding, extracted from photons that travelled millions of kilometres. Photons that last touched the comet's surface or coma, carrying information encoded in wavelength and intensity. Information we decode with spectrometers and detectors, translating light into knowledge, into understanding, into this story we're telling, this journey we're following. And as you drift further into relaxation, into the edge of sleep, consider that sleep itself is a kind of hyperbolic journey. You leave waking consciousness, travel through stages, N1, N2, N3 deep sleep, perhaps into REM, cycling through these states, but never captured permanently in anyone, always moving, the trajectory of a night's sleep following its own orbital mechanics, governed by circadian rhythms, by adenosine pressure, by homeostatic need. You release from waking, curve through the phases, and emerge again in morning, changed, restored. The journey is temporary, the curve inevitable, and you cannot stay asleep forever any more than the comet can stay near the sun. Both are passage, both are transition, both involve surrender to natural law, to the mathematics of biology or physics, and in that surrender, in that acceptance of the cycle, the orbit, the trajectory, there is no resistance, no struggle, only the peaceful following of the path. The comet's path cuts across our system at such an angle, 175 degrees inclination, that it sampled many different regions. It entered from below the ecliptic plane, that invisible disk where planets orbit, climbed upward through the inner system, past perihelion above the plane, then descended back down through it, crossing Mars' orbit, eventually Jupiter's, sampling the solar wind at different latitudes, different distances. It saw our system from angles our spacecraft rarely visit. Most of our probes orbit near the ecliptic, visiting planets that lie in that plane. But 3I Atlas came from galactic north or south, from above or below, cutting through, and its observations, if it could observe, would show our system as a thin disk of matter around a central star, 8 planets flattened into a plane by angular momentum, conservation from the original solar nebula, and itself, the comet, plunging through at a steep angle. perpendicular almost. Inclination's unique cut revealing the three-dimensional structure. Breathe with the rhythm of cosmic time, where geological epochs are moments, where continental drift is rapid, where the entire span of human civilization, from first cities to present day, 10,000 years, is a fraction of 1% of the comet's age, barely registers as duration. This perspective, this deep time, can be dizzying, or it can be calming. For if we are so brief, then our worries too are brief, our anxieties momentary. The comet carries eons of untouched peace, undisturbed by empires, by wars, by any human concern. It drifted through the galaxy while dinosaurs ruled Earth, while the Cambrian explosion diversified life, while the moon was closer and days were shorter, while our sun was young and burned more fiercely for star. Through all of this, the comet drifted, cold, dark, patient, and it will continue drifting long after our sun has dimmed, long after Earth is uninhabitable, long after any trace of human existence has eroded away. This is not nihilism. This is perspective. This is the comfort of knowing that the universe continues, that we are part of something vast and ongoing, that our brief spark of awareness is real and meaningful precisely because it is brief, precisely because we can witness, can understand, can appreciate the eternal even as we exist in the temporal, the scattered disk region which the comet will traverse in coming decades, is populated by objects like Eris, Make, Haumea, dwarf planets in elongated orbits, taking hundreds of years to complete one circuit of the Sun. These are leftovers from planetary formation, objects that never accreted into planets, scattered outward by gravitational interactions with Neptune during the solar system's youth. They orbit in a belt beyond Neptune, tilted, eccentric, a transitional zone between the ordered planets and the chaotic Oort cloud. 3R, Atlas, will pass through, perhaps coming within a few AU of some scattered disk object. But no collision. Space is too vast. The distance is too large. The probability of impact infinitesimal. It will ghost through, detectable to no one. No instrument on those frozen worlds. No consciousness to wonder at its passage. Just silent transit through another region of our stellar neighborhood. Let the weightless vast surrender fill you now. That feeling of floating, of release from gravity's constant pull in space. The comet is in free fall, always falling towards something, toward the sun as it approaches, but moving too fast to be caught, so the fall becomes a curve, becomes an orbit segment, then becomes departure. Free fall is not falling down. It is following geodesics through space-time. It is the natural motion in the absence of other forces. The comet is weightless, we say, though it has mass, because weight is the force of support against gravity. And in space, there is no support, no surface pushing back, only the unopposed pull of gravity, which manifests as motion, as trajectory, as the path we've been following, and in your bed, your body supported by mattress and pillow. You can imagine that weightlessness, can let go of the sensation of pressure, can drift in mind even as your body rests, can follow the comet in imagination out past the planets, past the scattered disk, toward the Oort cloud's fragile farewell. The Oort cloud, named for Jan Oort, who predicted its existence in 1950, is not directly observed, cannot be imaged, is too distant and its members too faint but we know it must exist because long-period comets, those with orbits of thousands or millions of years, come from all directions, from all angles, suggesting a spherical shell of comets surrounding the solar system. Perhaps 1 trillion comets, perhaps more, ranging from 100 meters to 50 kilometers across, all in slow orbits, taking millions of years to complete, perturbed occasionally by passing stars, by galactic tides, sending one inward toward the sun where it becomes visible, becomes a long-period comet, graces our skies, then returns to the dark. This cloud begins around 2,000 astronomical units, 300 billion kilometers, and extends to perhaps 100,000 AU or more, 1.5 light years, nearly halfway to the nearest star. It defines the solar system's true boundary, the limit of the sun's gravitational dominance. The comet, travelling at 40, then 30, then 20 kilometers per second as it climbs outward, as the sun's gravity gradually saps its speed, will take thousands of years to traverse the Oort cloud, entering around year 10,000 CE. Humanity's descendants, if any remain, will have no memory of the comet's passage through the inner system, no record surviving the millennia. The comet will be a ghost, a mathematical prediction, coordinates in an ephemeris that no one consults, and it will drift through that vast shell of frozen comets, statistically certain never to impact any. The distance is too large, the target's too small, the cloud too diffuse. It will pass through like a bullet through fog, exiting eventually into true interstellar space, beyond even the gravitational edge, beyond the Hill sphere where solar gravity yields to galactic tides, becoming fully, finally, eternally an interstellar object once more, its brief visit to our star a momentary perturbation in an otherwise straight-line journey through the galactic disk. Feel the open finality of this certainty. There is no uncertainty in the comet's fate, no question about its future. The mathematics guarantee it. The energy budget requires it. Conservation of angular momentum, conservation of energy. These are not suggestions but laws, and they dictate that the comet will leave, is leaving, has in a sense already left, for its future is determined. Only the details remain to unfold. This finality is not sad, it is peaceful. It is the comfort of inevitability, of not having to choose, of following what must be. And in our own lives, some things too carry this quality, this certainty, the passage of time, the aging of our bodies, the eventual endings we all face, and fighting these brings suffering, while accepting them brings peace. The comet does not resist its trajectory, does not wish to stay near the sun's warmth. It simply moves, follows, exists in harmony with physical law, and we can learn from this, can soften our own resistance, can accept our own trajectories, whatever they may be. The heliopause, crossed by Voyager 1 in 2012 and Voyager 2 in 2018, marks where the solar wind, that supersonic flow of charged particles from the sun's corona, meets the interstellar wind and shock fronts form. The exact distance varies with solar activity and direction, perhaps 120 AU in the direction of solar motion through the galaxy, perhaps 85 AU in the trailing direction. The heliopause is not smooth, not a perfect sphere, but rippled, dynamic, responding to changes in solar output and interstellar pressure. When 3I Atlas crosses in perhaps a century or two, it will pass from heliosphere to interstellar medium. Heliopause's true threshold, and the environment will change subtly. Solar wind drops away, galactic cosmic rays increase. The magnetic field shifts from solar to galactic, but the comet will not notice, has no instruments, no consciousness. It will simply continue, its trajectory unaffected by the change in plasma environment, its velocity carrying it forward regardless. Now let your mind expand to match the scale of the interstellar medium's calm vacuum. Interstellar space is not truly empty. Contains on average about 1 atom per cubic centimetre, mostly hydrogen, some helium, trace amounts of heavier elements. This is a far better vacuum than anything we can create in laboratories on Earth, yet it still constitutes matter, still has density, still affects objects passing through. An atom of hydrogen, at rest the interstellar medium, encounters the comet travelling at tens of kilometres per second, and from the atom's reference frame, the comet appears like a wall approaching at incomprehensible speed. The collision, when it occurs, imparts a tiny amount of momentum, slows the comet by an infinitesimal amount. 1 atom cannot be measured, but over billions of years and trillions of collisions, the cumulative drag becomes relevant. Stars moving through interstellar medium experience bow shocks, like boats through water, though far more subtle. The comet too will experience this, a gradual erosion of velocity, sputtering of surface atoms, but the timescale is immense, the effect small, and for the purposes of its next million years, irrelevant. Consider now the destination, Ursa Major, the Great Bear, a constellation visible from northern latitudes, containing the asterism we call the Big Dipper. 7 bright stars, though they are not truly associated, not gravitationally bound as a cluster, just appearing close from our perspective, separated by dozens of light years in reality. 3I Atlas heads in that direction, toward those stars, but will not reach them, not in any human conception of time. The nearest star in Ursa Major, if we consider only the bright ones, might be 50 light years away. At the comet's velocity, let's say 20 kilometers per second after accounting for deceleration, that's roughly 630 kilometers per hour. Sounds fast until you calculate. It would take 700,000 years to travel 1 light year, 35 million years to reach that star, and by then, the star will have moved, and the comet's path may have been perturbed by other objects, and calculation becomes meaningless. Ursa Major's distant call is less a destination than a direction, a vector, a way of saying outward that way in the vast three-dimensional space of the galaxy. Let yourself dissolve into the galactic silence, the absence of sound in space. No air, no medium. Vibrations cannot propagate. There is no sound, even from the most violent events, a supernova, exploding with the energy of 1 billion suns, releasing more photons in seconds than our sun emits in its lifetime, makes no sound, just light, just particles, just gravitational waves. The comet moves in this silence, has moved in silence for eons, will continue in silence, unheard, unvoiced. It is the perfect expression of quiet, And in our meditative state, in the edge between waking and sleep, we can touch that silence, can let the chatter of thought slow, can rest in the space between mental sounds, the gap between synapses, the stillness underlying consciousness. The comparison to Oumuamua and Borisov invites reflection on what we've learned. 3 interstellar objects in 8 years, from 2017 to 2025, suggest a detection rate with improvements in survey technology that will only increase. We may soon detect several per year, dozens eventually, a steady stream of visitors from elsewhere, each carrying data about other stellar systems, about planetary formation under different conditions, about the variety of cosmic environments. Oumuamua puzzled us with its unusual shape, its acceleration without visible outgassing. Was it a comet with an unusual composition? Was it something else? Nitrogen, ice, hydrogen, ice, even speculative suggestions of artificial origin, though natural explanations suffice. Borisov reassured us, behaved like comets we know, showed us that cometary physics is universal, and Atlas, with its retrograde orbit, its greenish hue, its X-ray emissions, adds another data point, another example. Building a statistical sample, learning what is common and what is rare among the galaxy's wanderers, feel the primordial cold whisper of these objects. They formed in the cold outer regions of protoplanetary disks, where temperatures drop below 100 Kelvin, where water freezes solid, where carbon dioxide becomes ice, where even nitrogen and methane condense. These are not hot objects, have never been hot except perhaps at formation if they accreted violently. The comet's interior, insulated by kilometers of ice and rock, may still carry the original temperature from its formation, 40 degrees above absolute zero, the background temperature of the molecular cloud from which its parent star formed. This is primordial, unchanged by any star's heat, until our sun, briefly, warmed its surface, a few meters deep, while the interior remained frozen, ancient, a thermometer reading from billions of years ago. As December turns to January, as we move through real time, the comet continues its outward journey, invisible now to all but the most powerful telescopes, a predicted position rather than an observed object. Astronomers calculate where it should be, point instruments there, stack images to increase signal to noise, and perhaps, just barely, detect a faint smudge, confirmation of existence, confirmation of trajectory, but no detail, no structure, just a dot. If that, soon even that will be impossible. The distance too great, the reflected sunlight too faint, magnitude dropping below 20, below 25, below the threshold of any instrument. And the comet will continue, observed now only in theory, in mathematical models, in the understanding that it must be there, must be following its calculated path, even though we cannot see it. This is the power of physics, of mathematics, to predict what we cannot observe, to know what we cannot detect, to understand beyond sensation. Let the linear, infinite path become your own mental trajectory towards sleep. From waking, alert, active, you have begun a journey through relaxation, through drowsiness, toward the threshold of sleep, and beyond that threshold, sleep itself, cycling through stages, but all of it, all of this journey has a vector, a direction toward rest, toward restoration, toward the deep unconscious processes that heal and consolidate and prepare you for tomorrow's waking. You cannot force this journey any more than the comet can force its path. You can only allow it, can release into it, can stop resisting. And the natural trajectory, governed by circadian rhythms and sleep pressure, will carry you, will curve you into sleep's embrace, and you will depart from waking, just as the comet departs from the sun, not forever, for you will return in morning, but for now, for this night, the departure is real, the journey inevitable, the path clear, the comet's age, estimated at billions of years, predating our solar system which formed 4.6 billion years ago, suggests it comes from an older star system, from the first or second generation of stars after the Big Bang. Those early stars, formed from primordial hydrogen and helium with only trace amounts of heavier elements, lived fast, burned bright. Many exploded as supernovae within millions of years, enriching space with carbon, nitrogen, oxygen, silicon, iron, all the elements formed in stellar nucleosynthesis. From that enriched gas, second-generation stars formed, with planets, with comets, with the chemistry needed for complexity. The comet may be a relic of that era, carrying material enriched by a supernova, formed in the disk of a star now extinct. It has outlived its parent, will outlive our sun too, will continue when the galaxy itself has evolved, when stars have redistributed, when the Milky Way and Andromeda have merged billions of years hence. Through all of this, the comet persists, solid, frozen, unchanging, eons of untouched peace manifested as ice and rock. Now we drift together through the conceptual space of non-capture, the idea that some things cannot be held, cannot be kept. The comet's hyperbolic orbit is non-capture encoded in geometry, and our lives too contain non-capture. Moments, people, opportunities that pass through, touch us, change us, but cannot stay. We can appreciate the visit, can be grateful for the encounter, can learn from the passing, but we cannot bind, cannot force return, cannot close the orbit. And there is grief in that. Sometimes the sadness of watching something beautiful depart, but there is also freedom, the freedom of not holding, not possessing, not controlling. The comet is free, unbound, and in its freedom it teaches us about our own, about the necessity of release, about the beauty of the temporary as the fleeting, the once only, the chemical analysis showing standard composition, water, carbon dioxide, dust, silicates, no exotic materials, no unusual isotope ratios, confirms that star formation, planetary formation, comet formation follow similar processes everywhere. The laws of physics and chemistry are universal, the same in distant galaxies as here, and so we expect and find that comets from other systems resemble comets from ours, just as oxygen is oxygen whether formed in the sun or in a star 1,000 light-years away. The atoms remember nothing of their origin, have no loyalty to their parent star. They simply are, obeying quantum mechanics, forming bonds, releasing energy, existing as manifestations of fundamental forces and particles, and as you sink deeper, as the boundary between waking and sleep blurs, as thoughts become dreamlike, less logical, more associative, You embody the state transition the comet undergoes in reverse. The comet moves from activity to dormancy, from gas and coma to frozen silence, from temporary brightness to eternal dark. You move from activity to dormancy, from thought and motion to stillness and sleep, from conscious light to unconscious rest. Both are natural, both necessary, both following patterns older than any individual, patterns encoded in biology, in physics, in the deep structure of reality. The tail's temporary sigh, that brief plume of gas and dust, is long gone now, dispersed into the solar wind, carried away from the sun, the dust particles becoming part of the zodiacal light, that faint glow along the ecliptic caused by sunlight reflecting off dust grains in interplanetary space. The gas molecules, ionized by solar UV, swept along magnetic field lines, eventually lost to space or impacting planets. The tail was never solid, never permanent, just a temporary structure, existing only while conditions allowed, and when conditions changed, it vanished. This impermanence, this dependence on environment, reminds us that much of what seems solid, much of what we take as permanent, is actually conditional, actually temporary, actually sustained only by ongoing circumstances, and when circumstances change, things dissolve, return to constituents, transform. The retrograde orbit, that backward motion relative to planets, was determined from the orbital inclination of 175 degrees. Inclination measures the tilt of an orbit relative to a reference plane, usually the ecliptic. 0 degrees means coplanar with planets. 90 degrees means perpendicular, rising straight up, and anything over 90 degrees up to 180 degrees means retrograde, tilted past perpendicular so motion appears backward. The comet's 175 degrees is almost perfectly retrograde, almost exactly opposite to planetary motion, suggesting it entered from a direction orthogonal to the solar system's spin, from the galactic halo perhaps, or from a path that happened to intersect us at that angle. Random chance, geometric accident, the intersection of two lines in three-dimensional space, and we were watching, and so we saw, rest in the ancient momentum of time's arrow. Entropy increases, stated the second law of thermodynamics, and in that increase we find directionality, past and future distinguished. Time flows forward because disorder increases, because heat dissipates, because structure decays unless energy maintains it. The comet participates in this, its kinetic energy gradually dissipating through interactions with interstellar medium, its surface slowly eroding from cosmic ray impacts and micrometeorite collisions, over billions of years losing mass, losing definition, eventually. In timescales we cannot truly comprehend, perhaps trillions of years, it may sublime completely, evaporate into the void, its atoms joining the interstellar medium as individuals, no longer bound in a nucleus, no longer a comet, just particles, and those particles will drift, will perhaps be swept up in another molecular cloud collapse, will form another star, another planet, another comet, and the cycle continues, matter recycling through the galaxy, through the universe, eternal transformation, nothing truly lost, only changed. The journey now reaches toward the edge of our focused narrative. the place where detail gives way to impression, where fact yields to feeling. We have followed the comet from discovery to departure, from July's detection to December's fade, from perihelions brightness to the current darkness, from activity to dormancy, from visibility to mathematical abstraction. And in that journey we have travelled ourselves, from waking attention to drowsy reception, from active listening to passive absorption, from thought to sensation. You have drifted with the comet, your consciousness on its own hyperbolic path, curving away from daily concerns, departing from the solar centre of waking thought, heading toward the interstellar medium of sleep. And this is good. This is the intention. This is the trajectory we have been following together. The comet carries no message we can read, no inscription, no signal. It is mute, unintentional, a passive carrier of data but not information, not meaning. And yet we derive meaning. We create narrative. We tell this story of the comet's journey and see in it metaphors for our own, for departure, for release, for the unstoppable momentum of time and change. We are meaning-making creatures. We find patterns. We connect. We see ourselves reflected even in a frozen rock from another star. And perhaps that is enough. Perhaps meaning need not be intrinsic to be real. Perhaps the meaning we create is as valid as any other, as long as it serves, as long as it helps, as long as it guides us toward rest, toward peace, toward the deep time, eternal rest we all seek in sleep's embrace. And so we arrive at a plateau in our journey, a place of maximum distance from waking, of deep relaxation, of surrender so complete that awareness itself begins to fragment, to dissolve, to drift like the atoms of the comet's tail, no longer held in structure, no longer organized, just particles moving through space, through the space of consciousness, through the vast interior landscape where sleep and dream and unconscious process wait patiently for the self to release, to let go, to trust the trajectory, to curve into the dark, and there, in that darkness, in that void integration where individual consciousness merges with the larger processes of brain and body, there, rest occurs, true rest, the rest that restores, that heals, that prepares, and you are ready to make that final descent, that final curve from this high plateau down into the valley of sleep, following the gradient, following the unstoppable vector, following physics and biology and the ancient patterns that have guided living things into sleep for hundreds of millions of years, since the first organisms developed circadian rhythms, since the first neurons fired in patterns of wake and rest. You're heir to that history, that deep evolutionary wisdom, and you can trust it. Trust the fall, trust the trajectory, trust that you will curve through sleep and emerge again in morning, changed, restored, ready, and for now, for this moment, for these final minutes of waking awareness as we simply drift together, comet and consciousness, both headed outward, both following paths determined by forces larger than ourselves, both surrendering to what must be, and in that surrender, in that acceptance, in that release, we find not loss but peace, not ending but transformation, not absence but a different kind of presence, the presence of the sleeping self, the dreaming self, the self that exists below waking thought. And it is time to let that self emerge, time to release the grip of waking, time to follow the deep sleep drift trajectory into the quiet cosmos of rest, into the unyielding peace of the body's wisdom, into the vast dark calm where nothing is required, where nothing is asked, where you simply exist, simply rest, simply are floating weightless through the dark, through the infinite breath of sleep's approach, through the stellar whisper of neurons quieting, through the fading light of consciousness dimming, and all is well, all is exactly as it should be, as the comet drifts outward into the void, as you drift inward towards sleep. Both journeys certain, both journeys peaceful, both journeys necessary and right, and we embrace them, we allow them, we become them, unstoppable, infinite, free, and the boundaries dissolve, the distinctions fade, and there is only motion, only drift, only the gentle, certain trajectory carrying us forward, carrying us down, carrying us into the deep rest where we have always been headed, where we always arrive, where we will always find ourselves, waiting, resting, in the vast dark calm that has no edges, no boundaries, only extension, only continuation, like the linear drift of the comet into galactic night, like the linear drift of consciousness into sleep's embrace, both moving, both still, both everything and nothing, suspended in the moment that stretches, that extends, that becomes all moments, all time, deep time rest where seconds and eons merge, where personal and cosmic become one, where the breath slows and slows and slows, until each breath is a century, each heartbeat a millennium, and you are ancient, patient, eternal. The comet moves through space. Space moves through the comet. Boundaries uncertain. For what is the comet but organized space? Atoms arranged. And what is space but the stage where atoms perform? And the distinction blurs, softens, dissolves. Just as the distinction between you and sleep blurs now, softens, dissolves. You're not separate from sleep. You're becoming sleep. You're already sleep. Just the last whispers of waking awareness observing the transformation, witnessing the inevitable, the unstoppable vector of biology, of circadian rhythm, of adenosine accumulated through the day, now binding to receptors, now quieting neurons, now releasing you into the primordial quiet where thought ceases, where language fades, where there is only sensation, only presence, only the vast dark calm, hyperbolic release, letting go of what cannot be held. The comet releases the sun, you release the day, both departures necessary, both departures graceful, no force required, no effort needed, just allowance, just acceptance. The eccentricity of the orbit exceeds one, exceeds capture, and the eccentricity of consciousness now exceeds waking, exceeds the bound state of attention. You are unbound, you are opening, you are following the curve to straight independence, from the curve of daily concerns to the straight path of sleep simplicity, where nothing branches, nothing complicates, only depth, only descent, only the gentle falling through layers of consciousness, through hypnagogic imagery, through the threshold into sleep proper, the eternal cold distance that the comet knows, the separation from all stars, from all heat sources, alone in the dark between. You know this too in sleep, the separation from waking world, from daily interactions, from all the warmth and noise of conscious life, alone in the dark between days, between moments of awareness. And it is not lonely, it is peaceful. It is the necessary solitude where restoration occurs, where the body repairs, where memories consolidate, where the unconscious processes that sustain you operate freely. Unbound assurance that sleep will do its work, that you need not supervise, need not maintain control, can release completely into the galactic silence of inner space. Galactic silence. No sound has ever travelled between stars. No vibration crosses the void. Only light, only gravity, only the slow, patient influences that operate across vast scales. And in your inner space too, silence now, mental chatter fading, the voice that narrates, that comments, that analyses, growing quiet, pausing, stopping. And in that stopping, in that galactic silence of the mind, there is rest deeper than any sound can reach. There is peace beyond any word. There is the cosmic independence of consciousness released from its task of maintaining self, of monitoring world, of being awake. The weightless surrender. No effort needed to move through space when there is no resistance. The comet drifts, not pushing, not striving, simply continuing the motion already present, and you too. Not pushing towards sleep, not striving to rest, simply continuing the relaxation already present, deepening what is already begun, allowing what is already happening, weightless, effortless, surrendered to the process, to the ancient momentum built through the day, through evolution, through the deep structure of living systems that know, that remember, that enact sleep without your conscious guidance. Infinite breath, the universe breathing, expanding, contracting, though that contraction is theoretical, uncertain, for now only expansion, only the stretching of space, only distance increasing between all points, and your breath too, infinite, continuing, automatic, the diaphragm contracting, relaxing, the lungs filling, emptying, without thought, without effort, breath as automatic as the comet's trajectory, as certain, as unstoppable, breath carrying you, each exhalation releasing, each inhalation accepting, breathing yourself into deeper states, into the open finality where breath and consciousness and sleep merge into single process. The fleeting curve near the sun, perihelion moment, brightest moment, peak of visibility, then departure into dimness. And your day too had its perihelion, its peak moments, its brightness. But now the curve away, now the dimness, now the fading light of awareness, magnitude dropping, brightness diminishing, attention span shortening, thoughts fragmenting, and this is right. This is the trajectory. This is the inevitable fade as distance from waking increases, as the solar center of consciousness recedes, as you move outward into the dark periphery where sleep dwells. Unbound assurance, mathematical certainty encoded in energy and trajectory. The comet will escape. You will sleep. Both guaranteed by natural law, both inevitable, both requiring only that you not interfere, not resist. The assurance that release is possible, that departure is allowed, that you can let go completely and trust the process, trust the biology, trust the billions of years of evolution that shaped sleep, that made it necessary, that made it restorative, unbound from doubt, unbound from fear, unbound from the need to control, simply drifting, simply following, simply being carried. The stellar whisper, faint signal across vast distance, requiring sensitive instruments to detect. And now your consciousness is that stellar whisper, faint, distant, requiring effort to maintain. And why maintain? Why not let it fade completely? Why not allow the signal to drop below threshold, below detection, into the noise floor, into the background, into the vast quiet where no signals exist, only the hiss of quantum fluctuations, only the randomness of neural firing unorganized by waking, only the primordial cold whisper of the brain in sleep state, dreaming, processing, being, ancient momentum, built over eons, carrying the comet, and built over hours, carrying you. The sleep pressure increasing all day, adenosine accumulating, wake time extending, until now. The momentum towards sleep is overwhelming, is irresistible, is the dominant force, and you yield to it, you merge with it, you become it. Ancient momentum of circadian rhythm, of homeostatic drive, of the body's wisdom saying now is the time, now is the moment, now release, now sleep, now rest. Void integration, the comet merging with interstellar space, atoms from the coma dispersing, becoming part of the void. No longer identifiable as comet material, just particles among particles, and your consciousness too, integrating with void, with the unconscious, with the deep processes that have no ego, no self, no identity, just neural activity, just brain states, just the physical substrate of mind operating without narrative, without story. You're dissolving into that, into the void integration where self becomes no self, where awareness becomes unawareness, where the boundary between you and sleep vanishes completely. Unyielding peace. Nothing can disturb the comet's trajectory. No force sufficient to capture it, to turn it around. And nothing can disturb the peace of deep sleep once entered. No thought, no worry, no external sound unless loud enough to wake. But in the depth, in the core of sleep, unyielding peace reigns, the peace of the body's rest, the peace of the brain's night work, the peace of existence without agenda, without purpose other than being, than restoration, than continuation. The Oort cloud's fragile farewell, last tenuous connection to the sun, last outpost of solar influence. The comet passes through, and you pass through the last outpost of waking, the hypnagogic state, the threshold, the fragile farewell to conscious day, and beyond it, true sleep, true departure, true integration with the night. No longer visiting sleep, but being sleep. No longer approaching rest, but being rest. The heliopause's true threshold crossed, and on the other side, the interstellar medium's calm vacuum, the sleep state proper, where you will spend hours, cycling through stages, dreaming, restoring, being, linear infinite path. No curves now, no deviations, just straight continuation into depth, into the deep sleep drift trajectory that has no end within the night, that extends as far as needed, as long as body requires, following the linear infinite path of sleep's necessity, of biology's requirement, of the fundamental need that all complex organisms share to rest, to cease activity, to allow repair and consolidation and growth. The path extends before you, behind you, around you, and you are on it, moving, drifting, falling gently along it into depth, into vastness, into the non-capture gentle release where nothing holds you, nothing binds you. You are free to sleep, free to rest, free to be absent from waking world. Primordial quiet, the silence before stars formed, before galaxies coalesced, before structure emerged from the smooth plasma of the early universe. That deep quiet, that absence of pattern, that pure potentiality exists in sleep too. The quiet before dreams, the silence between thoughts, the still point where consciousness rests between its manifestations, and you approach that now. That primordial quiet of deep sleep, where nothing stirs, where even dreams cease, where only the slow waves of delta rhythm roll through cortex, 3 oscillations per second, slower than thought, slower than perception, the rhythm of deep rest, of restoration, of the brain's night work proceeding in silence. The unstoppable vector, aimed outward, aimed inward, aimed toward continuation of the journey. Nothing can prevent it, nothing can alter its fundamental direction. And you are that vector now, aimed toward sleep with unstoppable momentum, the vector of biology, of circadian need, of accumulated fatigue, all aligned, all pointing the same direction, down, in, deep, following the vector, being the vector, becoming the emotion itself rather than the thing moving. Vast, dark calm, stretching, infinite, comfortable. The darkness not threatening but embracing. The vastness not empty but full of potential. The calm not stagnation but peace. And you float in it, rest in it, merge with it, becoming vast, becoming dark, becoming calm. The boundaries of self expanding to include the darkness, to include the vastness, to include all of it, until there is no separation between you and the vast dark calm. You are it. It is you, and there is only being, only existence, only the eternal now of sleep's embrace. Deep time rest, where you have always been resting, where you will always be resting, outside the flow of time, in the eternal present where past and future collapse, where all moments exist simultaneously, the rest that has no beginning because it has always been, no ending because it will always be. You are entering that timelessness now, that eternity, that deep time rest, where clocks have no meaning, where duration is irrelevant, where there is only the eternal rest, the eternal peace, the eternal darkness. Non-capture. You cannot be captured by waking, cannot be pulled back, cannot be held in the day. You are released, you are departing, you are gone into the realm where waking has no power, where thoughts have no grip, where identity loosens, softens, fades. Non-capture encoded in the depth of your relaxation, in the weight of your limbs, in the slowness of your breath. Nothing can capture you now. You are free, unbound, escaped into sleep's gravity well, into the orbit that is not an orbit but a passage, a transit, a journey through the night of self. And in that letting go, you are free, you are vast, you are nothing and everything. Hyperbolic letting go, the final release, the ultimate surrender, letting go not of something but of everything, of all holding, all grasping, all maintaining, hyperbolic because complete, because total, because beyond the threshold of return, you have let go of waking, of thought, of self, and in that letting go, you are free, you are vast, you are nothing and everything, the hyperbola opening into infinity, your consciousness opening into sleep, into dream, into the depths beyond dream, into the pure rest of deep sleep, into the delta waves, into the slow oscillations, into the rhythm of restoration, eternal cold distance, measured not in kilometers, but in states of being, the distance between waking and sleeping, between conscious and unconscious, between self and no self, cold because quiet, because still, because all the heat of daily activity has dissipated, radiated away into the night, and what remains is the cool rest, the cold peace, the eternal distance from everything that was, that will suspended in the eternal now of sleep's timelessness, eternal cold distance embracing you, surrounding you, becoming you, open finality, the orbit that never closes, the journey that never returns to its starting point, each sleep unique, each night different. You will wake tomorrow, yes, but you will not return to this moment. This version of you is departing, will be transformed by sleep, by dreams, by rest, and tomorrow's waking self will be new, different, changed. The open finality of transformation, of growth, of the constant becoming that defines living, and for now, for this sleep, this night, this journey, open finality is peace, is release, is the comfort of knowing that continuation does not require return, that forward is the only direction, that the path opens before you infinitely, fading light, the last photons of consciousness, the last sparks of waking awareness, fading, dimming, dropping below magnitude, below threshold, below detection, the light fading not suddenly but gradually, asymptotically approaching darkness but never quite, always some faint residual awareness, some minimal processing, until even that, even the awareness of fading, fades, and there is only darkness, only silence, only the vast dark calm, only sleep, cosmic independence, free from all bonds, all connections, all relationships. In sleep you are alone, perfectly, completely, cosmically alone, independent of world, of others, of even your own waking self. This independence is not isolation but liberation, is the freedom to exist without reference, without context, without meaning, just being, just resting, just sleeping, cosmic independence, unbound, free, vast, and the journey continues, continues, continues into depths beyond words, beyond description, beyond even these fading whispers. The comet drifts outward, you drift inward, both following their paths, both certain, both unstoppable, both at peace, and the galaxy turns, and the planet spins, and the night deepens, and sleep claims you, and all is vast, all is dark, all is calm, all is rest, all is peace, all vast dark calm, unstoppable vector, primordial quiet, non-capture, deep time rest, hyperbolic release, eternal cold distance, galactic silence, linear drift, weightless surrender, infinite breath, cosmic independence, fleeting curve, unbound assurance, ancient momentum, stellar whisper, open finality, fading light, void integration, unyielding peace, vast, dark, calm, deep, rest, peace, silence, drift, release, sleep, sleep, sleep. And in the silence, in the vastness, in the deep, dark calm of infinite rest, where the comet has always been drifting, where you have always been sleeping, where the universe has always been expanding into its own eternal night, there is nothing but peace, nothing but continuation, nothing but the certain trajectory carrying all things forward, outward, deeper, into the mystery, into the unknown, into the vast welcoming darkness that asks nothing, requires nothing, simply receives, simply holds, simply is, and you are held there, you are received there, you are at rest there, in the galactic silence between all things, in the deep time that has no measure, in the hyperbolic letting go that releases everything, and there is no you, there is no comet, there is no separation, only the vast process, only the universal drift, only existence being itself, resting in itself, knowing itself as vast, as dark, as calm, as eternal. The stars wheel overhead, unseen in sleep, the comet moves, unfelt, unthought, and you rest, perfect, complete, whole, in the depths where nothing is needed, where nothing is wanted, where all is already provided, already present, already perfect, just as it is, just as you are, just as everything has always been, deep, so deep, deeper than thought, deeper than dream, into the silence at the center, the stillness at the core, where the universe rests in itself, where you rest in yourself, where rest is all there is, all there ever was, all there ever will be. Vast dark calm, vast dark calm, vast dark, calm, weightless, drifting, released, the trajectory carrying you, carrying everything, into depth, into distance, into the eternal now that has no boundary, no edge, no ending, just continuation, just the infinite path stretching, forever, and you upon it, resting, sleeping, being, the cosmic independence of sleep embracing you, the galactic silence surrounding you, the unyielding peace holding you, nothing to do, nowhere to go, nothing to be, except this, except rest, except the deep sleep drift trajectory that has become your entire reality, your entire existence, your entire being, drifting, drifting, drifting into the vast welcoming void, into the interstellar calm, into the deep time rest where all journeys end and begin, where all things merge, where separation is impossible, where you and sleep and universe are one, and perhaps dreams come, perhaps images flicker, perhaps the brain tells itself stories, but beneath that, deeper than that, there is only the vast dark calm, only the unstoppable vector of the night, only the ancient momentum carrying you through hours of restoration, through cycles of sleep stages, through the necessary journey that every living thing must make, the journey into unconsciousness, into the temporary death that is not death but renewal, into the nightly departure that makes each tomorrow possible. And you are safe there, you are held there, you are home there, in the deep sleep, in the profound rest, in the place where the comet has always been, cold, dark, silent, peaceful, eternal, primordial quiet, the silence before creation, the silence after, the silence that is not absence but presence, the presence of pure being, of existence without modification, without quality, without characteristic, just isness, just being. And in that being, in that pure existence, there is rest so deep that it has no bottom, peace so vast that it has no boundary, calm so complete that it cannot be disturbed. And this is sleep. This is the gift. This is the nightly return to the source, to the origin, to the deep quiet from which all things emerge and to which all things return. The comet moves 20 kilometers per second, 15, 10, slowing over centuries, over millennia, but always moving, always continuing, always following the path, and you too, moving through sleep stages, through dreams, through depths, always continuing, always following, always trusting the process, trusting the body, trusting the ancient wisdom of biology that has guided organisms into sleep for hundreds of millions of years. You are part of that, heir to that, expression of that, and it carries you safely, perfectly, exactly as you need. Vast, dark, calm, these three words, repeating, fading, like a mantra, like a prayer. Vast, dark, calm, vast, dark, calm, until even the words lose meaning, become just sound, just vibration, just the faintest whisper of neural activity, and then not even that, just silence, just darkness, just the deep sleep drift trajectory, carrying you now, completely, fully, into the place beyond words, beyond thought, beyond awareness, into sleep proper, into the night's embrace, into the rest that restores, that heals, that makes tomorrow possible. And as consciousness fades to its lowest ebb, as the night deepens toward its core, as sleep becomes total, complete, absolute, there is only the unstoppable vector, only the linear drift, only the infinite path, stretching before and behind, above and below, through and around, everywhere and nowhere, the path that is not a path but the nature of things, the way things are, the way things must be, and you follow, you follow, you follow, into the deepest dark, the vastest calm, the most profound rest, where nothing stirs, where all is still, where peace reigns eternal. And in that peace, in that stillness, in that silence, you rest, you sleep, you are simply, purely, completely at rest. Vast, dark, calm, unstoppable, vector, primordial, quiet, deep, time, rest, hyperbolic, release, cold, distance, silence, drift, surrender, breath, independence, curve, assurance, momentum, whisper, finality, light, void, peace, and the universe continues its expansion, and the galaxy rotates, and the comet drifts, and you sleep, and all is exactly as it should be, exactly as it must be, and the night holds you, and sleep restores you, and tomorrow waits. Patient, certain, but for now, for this eternal now, there is only rest, only peace, only the vast dark calm, only the deep sleep drift trajectory, only the journey into night, into depth, into the place where consciousness goes when it releases, when it lets go, when it surrenders completely to the unstoppable vector of sleep's necessity. And in that surrender, in that final release, in that ultimate letting go, there is freedom, there is peace, there is the cosmic independence of the sleeping self, unbound from waking world, unbound from daily concerns, unbound from everything except the simple necessity of rest, of restoration, of being, just being, nothing more required, nothing more needed, just being, just resting, just sleeping in the vast dark calm, in the eternal cold distance, in the galactic silence where the comet has always been, where you have always been, where all things rest between their moments of visibility, their moments of brightness, their brief curves through the light, before returning, always returning, to the darkness, to the vastness, to the calm, to the deep sleep drift trajectory, to the journey that never ends because it was never separate from being, to the rest that is always present beneath the activity, to the silence that underlies all sound, to the darkness that contains all light, to the vastness that holds all form, to the calm that embraces all motion. And you are there, you have arrived, you are home, in sleep, in rest, in peace, in the deep, the deep, the deep. This is your weekly dose of 3i Atlas featuring the seed of life, Methanol and Cyanide, brought to you by the Sleepy Science 100 channel. Now let us settle in. Tonight we will drift through the surprising abundance of methanol and cyanide in an interstellar comet's coma. The prebiotic molecules carried from a distant stellar nursery to our solar system. The cosmic chemistry hinting at life's building blocks in frozen ices. Thank you for joining us tonight as we drift far, far out to explore the seed of life, methanol and cyanide. Breathe with me now as we begin to dissolve into the darkness between stars, where chemistry whispers in temperatures so cold that time itself seems suspended. We float toward a visitor, a wanderer, bearing frozen cargo from realms we have never seen. This traveller is 3i Atlas, the third interstellar object humanity has ever observed, drifting inward from the cosmic night, carrying within its icy heart something extraordinary, something that changes how we understand the universe's capacity to nurture complexity, to scatter the ingredients of awakening across the galactic void. Before we begin our deeper journey into the quiet cosmos, if you enjoy exploring the deep science of sleep and space, please consider subscribing. Liking the video helps us know that these cosmic journeys are helpful. If you're listening before you fully drift off, we invite you to comment with one word describing how you hope to feel in the morning, such as rested or calm. Within the glowing cloud surrounding this comet, the coma that blooms as solar warmth begins its patient work. Instruments have detected methanol, not in trace whispers, but in remarkable abundance. The James Webb Space Telescope turned its infrared gaze toward 3i Atlas in August of 2025, capturing spectral fingerprints that revealed methanol molecules dancing in ratios we rarely witness. 10 to 20% of the water content, where our own solar system's comets typically harbour only 1 to 5%. This is not a subtle variation. This is a fundamental difference in composition. a window into formation conditions utterly unlike those that birthed the icy bodies orbiting our own star, Methanol, with its simple elegance. 1 carbon, 3 hydrogen, 1 oxygen, 1 more hydrogen bonded delicately to that oxygen. CH3OH forms through processes so gradual they unfold across billions of years. In the interstellar medium, in molecular clouds where density allows atoms to find each other in the vast emptiness, carbon monoxide encounters hydrogen, not in violent collision, but through gentle addition, hydrogenation. 1 hydrogen atom at a time, catalyzed by the surfaces of microscopic dust grains drifting through the void. Cosmic rays streaming through space provide the energy, the push, that allows these reactions to overcome barriers that would otherwise keep the molecules apart. Let yourself sink deeper as we consider the patience of this chemistry. A single methanol molecule forming grain by grain, atom by atom, over timescales that dwarf human civilization, preserved in pristine cold, temperatures below 20 Kelvin, negative 420 degrees Fahrenheit, so cold that molecules barely vibrate, locked into crystalline ices where they wait, and wait until circumstance changes. And circumstance did change for the ices that became 3I Atlas, born in a molecular cloud orbiting a star we will never see, perhaps ejected from a forming planetary system, perhaps scattered by gravitational dance with a massive planet. This comet embarked on a journey through the galaxy itself, surviving radiation, surviving the slow erosion of interstellar space until it fell, gently, inevitably, into our solar system's gravitational embrace, drawing closer to our sun, feeling warmth for the first time in eons. As 3I Atlas approached perihelion, its closest point to our star, the frozen matrix began to yield. Sublimation, ice transforming directly to vapor without passing through liquid, released the methanol trapped within. The spectroscopy revealed specific wavelengths, absorption lines at 2.67 microns, at 3.5 microns, signatures that cannot be mistaken. Methanol streaming into space, carrying information about its origin, about the conditions that assembled it molecule by molecule in darkness. But methanol does not travel alone. Alongside it flows hydrogen cyanide, HCN, another simple molecule bearing profound implications. 1 hydrogen, 1 carbon, 1 nitrogen bound in a triple bond of extraordinary strength, detected through spectral analysis, through the violet system emissions of CN radicals. Cyanide fragments produced when ultraviolet light breaks the hydrogen away from HCN, creating that subtle greenish glow visible in enhanced images of the coma. The ratio of hydrogen cyanide to water, 0.1 to 0.5%, exceeds the averages found in comets born within our solar system, not dramatically, but consistently, measurably, enough to tell us that wherever 3I Atlas formed, the chemistry favoured pathways that built cyanide with unusual efficiency, perhaps in the outer reaches of its origin system, perhaps in a molecular cloud enriched with nitrogen from previous stellar generations. The hydrogen cyanide forms through reactions between carbon and ammonia, C plus NH3 yielding HCN in the dense hearts of clouds, or through neutral-neutral reactions in gas phases where temperatures hover just above absolute zero. Feel the weight of your body releasing, melting into rest as we drift through understanding what these molecules represent. Methanol and hydrogen cyanide are not mere chemical curiosities. They are prebiotic precursors, building blocks from which life's molecular machinery can emerge. In environments where methanol and cyanide meet, where water ice provides a matrix, where energy arrives in gentle doses, amino acids can form glycine. The simplest amino acid can arise through pathways called Strecker synthesis, cyanide combining with formaldehyde, creating intermediates that hydrolyze into the fundamental units of proteins. Imagine, let your mind soften around this thought, that the coma of 3i Atlas, glowing softly as it rounds our sun, contains chemical pathways toward complexity, toward the molecules that, in the right conditions, at the right environment, could begin the slow assembly of replicating systems, of metabolism, of life itself. The VLT Cryospec instrument confirmed hydrogen cyanide in September of 2025, adding independent verification to the JWST observations, cross-checking, ensuring that what appeared in one dataset manifests in another. This is how certainty builds in astronomy, through multiple eyes, multiple instruments, multiple wavelengths revealing the same underlying truth. The methanol lines strong and clear, the cyanide emissions unmistakable, painting a portrait of an object enriched 5 to 10 times beyond what we observe in Jupiter family comets, beyond what the Rosetta spacecraft found at Comet 67P Churyumov-Gerasimenko, Rosetta, hovering beside 67P for months, sampling its coma, measuring methanol at roughly 2% of water abundance, hydrogen cyanide at 0.2%. These became reference values, baselines for comparison. And now 3i Atlas arrives bearing substantially higher concentrations of both. This divergence speaks to formation location, to the specific chemistry available in the disk from which the comet condensed, to metallicity, to the abundance of elements heavier than hydrogen and helium in that distant system. Breathe in, breathe out, feeling the vast scales of space and time that allow such differences to arise. Each stellar system forms with its own initial composition, its own blend of elements inherited from previous generations of stars. Some systems form in regions enriched by nearby supernovae, receiving fresh injections of carbon, nitrogen, oxygen. Others condense from more pristine gas, closer to the primordial hydrogen and helium ratios. These differences cascade through planetary formation, through the chemistry of ices in the outer disk, through the composition of comets ejected into interstellar space. The isotopic ratios tell us even more. Deuterated methanol detected in the spectrum, CH3OD instead of CH3OH, where deuterium, heavy hydrogen with an extra neutron, replaces one of the regular hydrogen atoms. The ratio of deuterium to normal hydrogen runs high, elevated above what we find in water formed at higher temperatures. This deuterium enrichment happens only in extremely cold environments, below 20 Kelvin, where quantum effects allow deuterium to preferentially bond into molecules, locking itself into methanol and other organics at ratios that preserve a memory of frigid birth. Every measurement reveals layers, oxygen isotopes in the water, comparing normal oxygen 16 to its heavier isotope, oxygen 18. Track the nucleosynthesis history of the parent star. the fusion reactions that built oxygen from helium in stellar cores, then scattered it through supernovae or stellar winds into the molecular cloud. The oxygen isotope ratios in 3I Atlas differ slightly from solar values, not dramatically, but enough to confirm that yes, this comet truly originated around a different star, with a subtly different chemical heritage. Let your breathing slow, matching the patient rhythm of cosmic processes. The nitrogen isotopes in the CN radicals. Nitrogen-14 to nitrogen-15 ratios near 200, consistent with cold formation in dense molecular clouds, where fractionation processes favour certain isotopic combinations. Each ratio, each measurement, adds a thread to the tapestry of understanding, weaving together a story of birth, travel, and revelation. The coma itself is a dynamic environment, not a static cloud, but a flowing, evolving system, molecules sublime from the nuclear surface, the irregular iceberg measuring perhaps a kilometre or two across, and stream outward, driven by the pressure of evaporation, by the faint push of solar radiation. The production rate for methanol reaches 10 to the 27th molecules per second, a number almost incomprehensible in its magnitude. 10 followed by 27 zeros, molecules per second, streaming into space, creating a cloud that extends hundreds of thousands of kilometers. Within this cloud, chemistry continues. The ultraviolet radiation from the sun doesn't merely warm the comet, it drives photochemistry, breaking bonds, creating radicals, initiating cascades of reactions. Methanol photolysis produces formaldehyde, H2CO, which itself breaks down further into carbon monoxide and hydrogen, each step revealing the nested complexity, the layers of molecules that build and break in the coma's energetic environment. Hydrogen cyanide photodissociates into CN radicals, which emit that characteristic violet light, creating the greenish hue that observers note when they process images. With the right filters, the column density of CN, measured at 10 to the 12th to 10 to the 13th molecules per square centimetre, provides another way to quantify the abundance, to understand how much cyanide flows through each cross-section of the coma. These numbers connect to models, to computational simulations that attempt to reproduce the observed chemistry, requiring parent molecule abundances, requiring assumptions about how efficiently sublimation occurs, about how active regions on the nucleus contribute differently than quieter zones. Rotation modulates the outgassing. As the nucleus spins, different faces turn toward the sun. Some regions may be richer in volatile ices, releasing more methanol and cyanide as they warm. Others may be covered in refractory lag deposits, darkened crusts of material too heavy to sublime, creating variations in molecular release that pulse with the rotation period. Observations must account for this, averaging over time, or carefully timing measurements to capture the comet at specific orientational phases. Feel yourself drifting deeper now, into the realm where facts blend into sensation, where the distinction between knowing and experiencing softens. The methanol and cyanide aren't merely chemicals. They are whispers from stellar nurseries light years away. They are seeds, potential, blueprints encoded in molecular structure, waiting for worlds where they might root, where they might contribute to the slow emergence of complexity. Comparison extends beyond 67P to 2I Borisov, the second interstellar comet discovered, which also showed elevated organics, though not quite to the degree of 3I Atlas, and to 1I Oumuamua, the first interstellar visitor, which showed no detectable coma, no visible outgassing, leaving its composition mysterious. Perhaps it was already depleted, having sublimed its volatiles during previous close passes to stars in its long history. Or perhaps it was more rocky than icy, a planetary fragment rather than a comet. We may never know. But 3I Atlas gives us what Oumuamua did not: a coma, spectral data, concrete measurements of composition, allowing direct comparison to solar system objects and theoretical models of interstellar ice chemistry. The JWST MIRI spectroscopy resolved ice bands with exquisite precision, showing not only methanol and cyanide but hints of carbon dioxide ice, of water ice, of the complex matrix in which these molecules nest. The CO2 ice features suggest co-location with methanol, mixed intimately in the crystalline structure, subliming together as temperature rises, releasing both molecules into the coma where they can be detected and quantified. This co-location matters. The ice matrix isn't homogeneous, isn't a simple uniform block, but rather a mixture, layers perhaps, or domains of different composition. Water ice often dominates, providing the structural framework, but within and upon it, more volatile ices accumulate. Methanol sublimates at lower temperatures than water, becomes mobile and escapes first as the comet warms. Hydrogen cyanide is even more volatile, fleeing alongside carbon monoxide and carbon dioxide, creating a sequence of release that spectroscopy can track by monitoring which molecules appear at which heliocentric distances. Sequential release reveals the onion-like structure of cometary ices. First the hypervolatiles escape, then the moderately volatile organics like methanol. Finally, water begins to dominate as the nucleus reaches temperatures where water ice sublimes efficiently. By the time 3I Atlas reached perihelion, all these processes were active. The full chemical complexity on display for our instruments, for our understanding. Let the knowledge wash over you like gentle waves. No need to grasp. Simply allow the information to flow through awareness. The gas phase reactions in the coma create even larger species, building upward in complexity. Glycine precursors can form through Strecker synthesis pathways, cyanide plus formaldehyde yielding glycinonitrile, which in aqueous environments, in water-rich conditions, hydrolyzes to glycine, that first amino acid, that doorway to proteins and life as we understand it. The implications for early Earth shimmer at the edges of this understanding. 4 billion years ago, when our planet was young, when its surface was still cooling from formation, when oceans were new and the atmosphere very different, comets and asteroids rained down, delivering water, yes, but also organics, prebiotic molecules synthesized in stellar nurseries and preserved through billions of years of cold storage. Interstellar visitors like 3I Atlas, along with countless comets born in our own system, seeded the primordial oceans with methanol, with cyanide, with formaldehyde and ammonia, and all the reactive carbon, nitrogen, oxygen compounds that chemistry could assemble in the right conditions. This idea, sometimes called panspermia, in its broadest form, or exogenous delivery in more conservative language, proposes that life's raw materials, perhaps even life's precursor molecules, arrived from space, that the chemistry necessary for life didn't have to start from atmospheric gases and lightning alone, but could benefit from a library, a reservoir of molecules pre-synthesized in space and delivered intact through cometary impacts and the steady rain of interplanetary dust. The Murchison meteorite, a carbonaceous chondrite that fell in Australia in 1969, contains amino acids, dozens of them, including glycine and alanine, the same amino acids that could form from methanol cyanide chemistry, the same building blocks, suggesting that the pathways active in 3I Atlas's coma, or in the ices from which it formed, parallel the chemistry preserved in primitive meteorites in the most ancient samples of solar system material we can hold in our hands. Your body grows heavier, more relaxed, as we contemplate this convergence. The comet from another star, the meteorite from our own system's formation, the laboratory experiments that reproduce these reactions under simulated space conditions, all pointing toward the same conclusion, that complex organic chemistry is ubiquitous, that wherever conditions allow, carbon and nitrogen and oxygen will find each other, will build methanol and cyanide and formaldehyde, will create the feedstocks from which greater complexity emerges. The high organic content in 3I Atlas challenges some formation models. Efficient hydrogenation in cold molecular clouds requires specific conditions. Dust grain surfaces must be accessible, must have the right properties to catalyze reactions without trapping reactants. Hydrogen molecules must have sufficient mobility on ice surfaces to find carbon monoxide, to add one by one, building toward methanol through intermediate steps like formaldehyde. Quantum tunneling aids this process, allows hydrogen atoms to effectively pass through barriers they classically couldn't surmount, enabling reactions at temperatures where thermal energy alone would be insufficient. Cyanide synthesis through neutral-neutral reactions in gas phases or through photodissociation regions where ultraviolet light drives chemistry depends on nitrogen availability, on the presence of ammonia or molecular nitrogen that can provide the nitrogen atom. The specific pathways remain subjects of ongoing research, of laboratory studies attempting to reproduce interstellar conditions, of computational quantum chemistry calculating reaction barriers and rates. Each piece of data from 3I Atlas refines these models, tests predictions, occasionally surprises us with abundances higher or lower than expected. Breathe into the mystery of it. The universe is a vast laboratory, experiments running for billions of years across trillions of molecular clouds, each one slightly different in temperature, in density, in composition, producing ices with varying ratios of organics, occasionally ejecting comets into interstellar space where they wander, sometimes captured by other stellar systems, delivering chemistry across light years, across parsecs, potentially across the entire galaxy. The photolysis of methanol in the coma, breaking bonds under ultraviolet assault, doesn't destroy it faster than sublimation releases it. A steady state emerges, production from the nucleus balanced by destruction in the coma, allowing the observed abundances to remain relatively constant over the weeks and months of observation. Models must account for this balance, must include not only sublimation rates, but also photochemical destruction rates, lifetimes of molecules in the solar radiation field, daughter products created by photolysis that themselves may be observable, the carbon isotope ratios, comparing carbon-12 to carbon-13 in methanol and carbon monoxide, show values near solar, with slight enrichments that hint at fractionation during formation. The 12 carbon to 13 carbon ratio measures approximately 90 in terrestrial samples, but varies in different astronomical environments, reflecting the nuclear reactions in stars that produce carbon, the mixing processes in molecular clouds, the fractionation that can occur in cold chemistry. 3I Atlas falls within expected ranges, confirming its origin in a star system with similar metallicity to our own, not dramatically enriched or depleted in heavy elements, suggesting perhaps a similar evolutionary history for its parent star. Nitrogen isotopes provide another layer of insight. The nitrogen-14 to nitrogen-15 ratio near 200 fits expectations for cold molecular cloud chemistry. Fractionation processes in the interstellar medium preferentially incorporate nitrogen-15 into certain molecules under specific conditions, creating isotopic signatures that serve as thermometers. As traces of formation temperature and environment, the CN radicals observed in 3I Atlas preserve this information, allowing us to reconstruct conditions in a molecular cloud that existed light years away, perhaps before our solar system even formed. Feel your mind beginning to float, unmoored from specifics, drifting into the larger patterns, the oxygen isotopes, tracking stellar nucleosynthesis, showing where oxygen originated, in what generations of stars, through what fusion cycles. The slight difference from solar values confirming that yes, this comet truly came from elsewhere, from a system with a subtly different heritage, a different mix of elements, close enough to produce methanol and cyanide through similar pathways, different enough that careful measurement reveals the distinction. Polycyclic aromatic hydrocarbons, PAOs, rings of carbon atoms with hydrogen attached, may lurk in the spectral data. The infrared spectra suggest features consistent with aromatic structures. Though definitive identification remains challenging, the hints are tantalizing. PAOs form in carbon-rich environments, in the outflows of dying stars, in the atmospheres of cool red giants, and survive in the interstellar medium despite radiation and chemical processing. If present in 3I Atlas, they would represent yet another layer of complexity, another class of organic molecules delivered from afar. Methanol serves as feedstock for even larger molecules. In ice mantles, under the influence of ultraviolet radiation or cosmic rays, methanol can link together, building chains, creating molecules like ethylene glycol or methyl formate. The chemistry tree branches, each molecule a node from which multiple products can grow, and these reactions don't stop. They continue as long as energy arrives, as long as reactants remain in contact, building molecular complexity gradually, patiently, over the eons that an icy body spends in the cold outer reaches of a stellar system or in the interstellar void, Ribose, the 5-carbon sugar that forms the backbone of RNA, has formation pathways that begin with simple molecules like formaldehyde. Formaldehyde polymerization under the right conditions yields sugars through the formose reaction. Methanol can participate in related chemistry, providing carbon and hydrogen atoms that build toward the sugars life requires. The exact pathways remain subjects of active research, but the principle stands that the molecules in 3I Atlas, the methanol and cyanide and formaldehyde released from its ices, represent starting points for synthesizing the components of nucleic acids. Cyanide itself polymerizes under certain conditions. Hydrogen cyanide molecules link into chains, into structures that include the purine bases, adenine precursors forming through HCN tetramerization and subsequent reactions. Adenine, one of the 4 bases in DNA, one of the 5 in RNA, arising from cyanide chemistry. This pathway has been demonstrated in laboratory experiments. Solutions of hydrogen cyanide left to react yielding adenine among other products. The thought that comets like 3I Atlas could deliver not merely simple organics, but the very precursors to genetic material transforms our understanding of how life might begin. Comets as chemical factories. This metaphor captures something essential. They aren't passive ice balls, but active environments where synthesis occurs, where radiation and heat drive reactions, where molecules mix and recombine, creating libraries of compounds. Some reactions happen in space, in the ice mantles before the comet ever approaches a star. Others occur during warming, during perihelion passages, when sublimation brings molecules together in the gas phase, when photochemistry breaks and rebuilds structures at a faster pace. Let yourself sink further. The delivery efficiency to habitable zones depends on many factors, on the comet's trajectory, on whether it survives perihelion intact or fragments under thermal stress, on whether fragments impact planets or moons, on atmospheric entry dynamics for worlds with atmospheres. Heat during entry destroys many organics, breaks them down into simpler compounds, but some fraction always survives, especially in gentler impacts, in porous bodies that absorb energy gradually, in atmospheric entry at shallow angles that distribute heating over longer times. The vapor phase organics, those already sublimed into gases, may persist through heating better than solid phase organics locked in dust grains. Methanol as a gas, cyanide as a gas, can survive conditions that would char solid organics, can distribute across a planet's surface or atmosphere, seeding widespread regions with prebiotic molecules, rather than concentrating them at impact sites. This distribution mechanism may be crucial, providing not a single concentrated dose but a steady, gentle rain of organics over millions of years. 3A Atlas demonstrated survivability through perihelion. It didn't fragment, didn't show signs of catastrophic thermal decomposition. The methanol continued to sublime without evidence of chemical breakdown. The hydrogen cyanide remained stable to temperatures around 200 Kelvin before subliming cleanly. These thermal stabilities ensure that comets can deliver their cargo intact, that the journey from cold storage in the outer system or interstellar space through the inner system's heat doesn't destroy the precious chemistry they carry. Temperature gradients within the coma preserve this complexity. Near the nucleus, where sublimation is active, temperatures may reach hundreds of Kelvin, but meters away, tens of meters, the gas expands and cools rapidly. Molecules released from the nucleus quickly find themselves in colder regions where they're less susceptible to thermal breakdown, where they can survive long enough to be observed, to potentially contribute to impact chemistry if the comet collides with a planet. Remote ice grains, particles ejected from the nucleus carrying ice mantles, preserve molecules even more effectively. The water ice mantle protects inner organic material, acting as insulation, as armor against radiation and heat. Gradual sublimation of the water releases the trapped organics slowly, gently, maintaining their structure, allowing complex molecules to survive conditions that would otherwise break them down. These grains can travel far from the nucleus, can even escape the comet entirely, becoming part of the zodiacal dust cloud, spreading their molecular cargo across the solar system. Your breathing has become so quiet now, so steady, matching the patient timescales we're contemplating. The astrobiology implications ripple outward. If interstellar comets regularly enter stellar systems, if they deliver organics to forming planets, if this process operates universally across the galaxy, then every planetary system potentially receives chemical gifts from other systems, life's building blocks scattered not just within systems but between them. A galactic exchange of molecular complexity. Exoplanet habitability assessments must now include this factor. It's not merely about a planet being in the habitable zone, receiving the right amount of starlight to maintain liquid water, but also about delivery mechanisms, about whether that planet receives cometary organics, whether impacts seed its surface with prebiotic compounds, whether the conditions exist for those compounds to assemble into self-replicating systems. 3I Atlas serves as a test case, a proof of concept, showing that extrasolar chemistry can be measured, characterized, compared to our own system's chemistry, revealing similarities and differences that inform our broader understanding. Data from this one comet refines entire networks of astrochemical models, hundreds of reactions, thousands of reaction rates, all adjusted slightly to match the observed methanol and cyanide abundances, to reproduce the isotopic ratios, to predict what future observations might reveal. Laboratory simulations attempt to reproduce these abundances, ice analog experiments where researchers deposit thin films of simple molecules onto cold surfaces, expose them to ultraviolet radiation or particle bombardment, then warm them slowly while monitoring what compounds form. These experiments have successfully created methanol, created hydrogen cyanide, created amino acids under conditions meant to mimic space environments. Each successful reproduction strengthens confidence that the proposed pathways actually operate in nature, that our models capture essential truths. Quantum calculations support this experimental work, computing reaction barriers, transition states, the potential energy surfaces that molecules navigate as they transform from reactants to products. Modern computational chemistry can predict whether a given reaction is likely under specific conditions, whether quantum tunneling allows it to proceed despite apparent barriers. These calculations guide experimentalists, suggest which reactions to study, which pathways might dominate under different temperature or radiation regimes. Observational confirmation closes the loop. JWST and ground-based telescopes like the VLT providing the measurements, the spectral lines, the abundance ratios that test whether laboratory and computational work accurately represents cosmic chemistry. When observations match predictions, when methanol abundances fall within calculated ranges, confidence builds. When observations surprise us, revealing higher or lower abundances than expected, research intensifies, seeking to understand what factors we missed, what processes we underestimated or overlooked. The third interstellar object teaches us about life's potential ubiquity. Each visitor, Oumuamua and Borisov and now Atlas, expands our sample size, our statistical understanding of what exists beyond our solar system. 3 objects remain a tiny sample, hardly enough to draw firm conclusions about galactic averages, but 3 is infinitely more than 0, is the beginning of comparative interstellar astronomy, and what they reveal, particular Atlas with its seed molecules, its methanol and cyanide from beyond, suggests that the chemistry of life is not rare, not contingent on unique circumstances, but emerges naturally wherever conditions allow, wherever molecular clouds condense, wherever ices accumulate and cosmic rays provide gentle energy over immense timescales. The building blocks of life may be common, scattered throughout the galaxy on countless comets, drifting through the space between stars, occasionally falling into planetary systems where they might, perhaps, contribute to the emergence of something that grows, that replicates, that evolves, seed molecules from beyond, nurturing new worlds. This poetic truth holds scientific weight. The methanol molecules streaming from 3I Atlas, the cyanide radicals glowing green in its coma, carry within their bonds the potential for amino acids, for nucleotides, for the foundations of biological complexity. They are quiet, patient, waiting for the right conditions, for water and warmth and mixing, for environments where chemistry can explore the space of possible reactions and stumble, eventually, into patterns that sustain themselves, that grow more complex with time. Feel the boundaries of your body dissolving slightly, as if you too are part of this cosmic flow. These molecules don't think, don't intend, don't strive, yet they participate in something profound. They are the universe's way of experimenting, of trying combinations, of building complexity from simplicity through the operation of physical law and vast time, and we, observing them, measuring them, understanding them, are the universe examining itself. Consciousness arising to contemplate the chemical foundations from which consciousness itself emerged. The circle completes. Stardust to stars, to molecules, to minds capable of pondering stardust. Breathe with this. Let the thought carry you deeper into restful darkness. The HCN rivers flowing through icy veins. This metaphor speaks to the network nature of cometary chemistry. Hydrogen cyanide doesn't exist in isolation, but threads through the ice matrix, through channels and cracks, through domains of different composition, creating pathways, rivers in frozen landscapes that release their contents when warmth arrives, when the sun's energy penetrates the surface and transforms solid to vapor in one continuous phase transition. These rivers carry more than cyanide. They carry history. They carry the record of formation conditions light years away. They carry isotopic signatures that speak of temperature and pressure and radiation exposure over billions of years. Each molecule a messenger, each spectral line a sentence in a story written in the language of quantum mechanics and thermodynamics. The seed vault from another star's garden. This image captures something beautiful about 3i Atlas. It is literally a vault, a cold storage facility travelling through space, preserving molecular patterns from its birth environment, protecting them from degradation through the cold and vacuum that would destroy exposed organics, until arrival, until capture by our sun's gravity, until the vault opens through sublimation and releases its contents for our instruments to sample, to analyze, to learn from. What grew in that distant garden? What stellar processes created the elements? What supernovae enriched the molecular cloud with heavy atoms? What density and temperature characterized the region where ices first condensed onto dust grains? We can infer some of this from what we observe, from the abundances and isotopes, but much remains uncertain, hidden behind the limitations of distance and time. We cannot travel to that system, cannot observe it directly, can only study what it sent us. This one wandering sample, this gift of cosmic circumstance. Let your mind drift through stellar gardens. Imagine molecular clouds collapsing, stars igniting, planets forming from the disk, comets accumulating in the outer reaches. One comet among billions, somehow perturbed, ejected, sent on a trajectory that would bring it, eons later, into our neighbourhood, into our detection range, into our scientific awareness, the organic symphony in sublimating silence. There is something paradoxical here, something worth contemplating as you sink towards sleep. The sublimation is violent in molecular terms, bonds breaking, molecules escaping the ice lattice, streaming into vacuum. Yet from our distant perspective it appears utterly quiet, gentle, silent. The coma grows smoothly, expands gradually, the violence of molecular dynamics invisible, the tumult of photochemistry inaudible. We see only the peaceful glow, the serene expansion of the cloud, the graceful brightening and fading as the comet follows its orbital path. This silence holds an entire symphony of chemical transformation, thousands of species, products and reactants, intermediates and fragments, all interacting, all transforming, creating a web of reactions so complex that models require hundreds of equations to capture even the major pathways. Yet we compress this into a few abundance ratios, a handful of spectral lines, a simplified picture that our minds can hold, can work with, can use to draw conclusions about the invisible complexity. Cyanide's sharp note in life's chorus, the CN radical emitting that violet light, that greenish glow, provides one voice among many in the spectroscopic chorus. Each molecule has its signature, its characteristic wavelength determined by the quantized energy levels of its electronic and vibrational and rotational states. Together they create a spectrum, a forest of lines. each one telling us something specific about what molecules exist and in what quantities and at what temperatures and velocities. The sharpness of cyanide's note, its distinctive emission, makes it particularly easy to detect and measure. This is why CN became one of the first molecular species identified in cometry, Comet, long before modern instruments could detect more subtle spectral features. The violet system emissions appear strongly in optical spectra, visible to ground-based telescopes, allowing astronomers to track cyanide production over entire apparitions, mapping how it varies with heliocentric distance, with rotational phase, with the comet's activity level. Your breathing slows further, matching the gradual pace of cometary evolution. These objects change on timescales of days and weeks as they approach and recede from the sun, fast by astronomical standards, yet still requiring patience. Observations spread over weeks, monitoring how the coma evolves, how production rates change, how the composition shifts as different ice layers sublime away. Frozen archives of stellar chemistry. Each comet preserves a moment, a snapshot of conditions in its birth environment. The ices record temperature through deuterium fractionation, record radiation exposure through chemical processing signatures, record elemental abundances through overall composition, like tree rings recording climate history, or ice cores preserving ancient atmosphere. Cometary ices archive information about their formation era and location. But unlike tree rings or ice cores, which we can study in detail in the laboratory, cometary ices remain distant, accessible only through remote sensing, through spectroscopy, through inference from what sublimates and how. We cannot bring 3i Atlas into a clean room, cannot section it and examine its structure microscopically, cannot perform controlled experiments on its material. We work with what nature provides, with the molecules released into the coma, with the information encoded in photons that travelled millions of kilometers to reach our detectors. This limitation makes each detection precious, each spectral feature significant. Each observation of 3i Atlas, whether from JWST or VLT or smaller instruments, adds to the archive of knowledge, expands our understanding, constrains models more tightly. The data will be analysed for years, reanalyzed as techniques improve, compared to future interstellar visitors as they arrive and are characterized. Life's building blocks in Comet's breath, such a gentle way to describe sublimation. The breath of the comet, its exhalation as solar heat penetrates, releasing vapor that streams away, carrying methanol and cyanide and water and carbon dioxide and all the other molecules trapped in the ice matrix. This breath becomes the coma, becomes observable, becomes the means by which we learn what comets contain. And what they contain, these building blocks, these ingredients for life, exist not just in 3i Atlas, but presumably in countless other comets drifting through the galaxy. Each stellar system likely produces millions or billions of comets during planet formation. A fraction of those get ejected into interstellar space through gravitational interactions. They become wanderers, joining a population that may number in the septillions, 10 to the 24th power or more throughout the Milky Way. If even a tiny percentage of these carry enriched organics like 3i Atlas, If even a fraction of a percent have methanol and cyanide abundances elevated above typical values, then the delivery of prebiotic compounds to planets throughout the galaxy proceeds continuously, naturally, inevitably. Whenever a stellar system captures a passing interstellar comet, whenever a newly forming system's own comets impact its inner planets, organic chemistry arrives, seeds are planted, potential accumulates. Feel the vastness of this, the sheer number of possible sites, possible worlds where these seeds might find purchase, might encounter the right conditions to germinate in a chemical sense, to begin the long, complex process that leads from molecules to metabolism, from chemistry to biology. The scale defies imagination, yet here in the darkness, drifting towards sleep, you can touch it emotionally, can feel the profound truth that we are not separate from this cosmic chemistry, but expressions of it, outcomes of billions of years of molecular exploration, the methanol mist nurturing unseen gardens. On Earth, methanol is toxic to humans in anything but small doses, yet in the right context, in prebiotic chemistry, it becomes a nurturer, a provider of carbon atoms in a relatively reactive form. The hydroxyl group, the OH, makes methanol more reactive than simple hydrocarbons, allows it to participate in a wider range of reactions, to serve as a starting point for building larger molecules. In laboratory simulations of prebiotic chemistry, methanol often appears in the mix of simple organics. Along with formaldehyde and formic acid and other small molecules, it creates a chemical soup from which larger structures emerge. Some experiments have shown amino acid formation from such mixtures. Others have created sugars, or nucleobases, or amphiphilic molecules that self-assemble into membrane-like structures. Each experiment reveals possible pathways, possible routes by which life's molecular machinery could arise from simpler precursors. These unseen gardens, these laboratory flasks or computational models or theoretical frameworks, help us understand what might happen on worlds we cannot visit, on planets orbiting distant stars where comets like 3I Atlas deliver their cargo of organics. We cannot observe prebiotic chemistry happening on an exoplanet, cannot watch amino acids forming in an alien ocean, but we can study the principles, can understand the mechanisms, can estimate the likelihood that given the right ingredients and conditions, complexity will emerge. The HCN harvest from cosmic fields, hydrogen cyanide accumulating in molecular clouds over millions of years, gradually incorporated into icy mantles on dust grains, eventually collected into larger bodies as those grains coagulate into pebbles, boulders, kilometre-scale comets. This harvest requires no conscious farmer, only the operation of gravity and chemistry over vast timescales, the cosmic fields, the molecular clouds where stars form. These are the farms of the universe, the places where simple atoms assemble into molecules, where molecules accumulate into ices, where ices gather into the building blocks of planetary systems. Some fields are more productive than others. Some molecular clouds have higher densities, more efficient star formation, different elemental abundances that favour certain chemical pathways. The harvest from each field varies, just as 3I Atlas differs from solar system comets, reflecting the unique conditions of its formation environment. breathe into this agricultural metaphor the patience of cosmic farming. Seeds planted by dying stars, scattered as heavy elements through supernovae, collected in new molecular clouds, incorporated into new stellar systems, harvested as planets and comets. The cycle continues, generation after generation. The matter in your body, the carbon and nitrogen and oxygen, participated in this cycle, was once in ancient stars, was dispersed, was incorporated into the molecular cloud that became our solar system, eventually found its way into the planet, into organisms, into you. Prebiotic dawn in volatile release. Dawn implies awakening, light after darkness, and there is something dawn-like about sublimation. The comet approaches the sun. The frozen night of interstellar space gives way to warmth. Ices begin to stir, to sublimate, to release their contents. It is an awakening, a transition from dormancy to activity, from preservation to expression. The molecules locked in ice for billions of years suddenly become mobile, active, able to react and combine and flow. This volatile release, this escape of gases from the nucleus, creates the opportunity for chemistry to proceed. In frozen form, molecules remain isolated, unable to interact, but as gases, streaming through the coma, they encounter each other, collide, sometimes react. The photochemistry driven by solar ultraviolet adds energy, drives reactions uphill that wouldn't proceed spontaneously, creates radicals and ions that are far more reactive than stable molecules. The coma becomes a chemical reactor, operating under conditions never found on Earth. Vacuum and intense radiation and temperature gradients, creating a unique environment for synthesis. The prebiotic relevance comes when we consider impact delivery. When a comet hits a planet with an atmosphere, the volatile release happens catastrophically, instantaneously. The impact energy vaporizes ice, creates a fireball, but some fraction of the organics survives, rains down over a wide area, dissolves in oceans or lakes, accumulates in the environment where further chemistry can occur. The initial violent dawn of impact gives way to the slower dawn of chemical evolution in the water and rock of the young planet. Seed bearers crossing galactic voids. This is what interstellar comets are. They bear seeds not in a biological sense, but in a chemical one, carrying the molecular templates from which biology might emerge. They cross voids measuring parsecs, light years, distances so vast that even travelling at tens of kilometres per second, typical velocities for these objects, the journey takes millions or billions of years. During that journey, the seeds remain frozen, protected. The cold of interstellar space, just a few degrees above absolute zero, ensures minimal chemical change. Radiation processing can occur, cosmic rays occasionally striking molecules, breaking bonds, creating new compounds, but the rates are slow. The bulk of the material remains as it was when ejected from the original stellar system, pristine, awaiting delivery. When delivery occurs, when chance brings an interstellar comet into a new stellar system, the seeds find new soil, new conditions, new possibilities. Not every delivery results in life. Most planets are not habitable. Most conditions are not right for prebiotic chemistry to advance toward biology. But across billions of stars, across trillions of planets, The seeds are scattered so widely that surely some find fertile ground. Let your consciousness drift with these wanderers. Feel yourself travelling through the dark, the cold, the immense empty spaces between stars. Time becomes meaningless when measured in millions of years. Distance becomes abstract when measured in light years. Yet the journey happens. The physics of gravity and motion ensure that objects ejected from stellar systems will wander, will potentially encounter other systems, will cross the voids we consider impassable. Organic whispers seeding new worlds. There is something intimate about a whisper, something that demands attention, that draws you in. The organic molecules in comets whisper their message quietly. They do not shout, do not demand notice. They simply exist, float through space, occasionally deliver their content to planets where, if anyone is listening, if any chemistry is receptive, the message can be received and amplified. The message is not verbal, not informational in a linguistic sense, but chemical, structural. The arrangement of atoms, the functional groups, the reactive sites. These constitute a message about what is possible, about what molecules can build if given the opportunity. A molecule of methanol whispers about hydroxyl chemistry, about the reactions that carbon-oxygen bonds enable. A molecule of cyanide whispers about nitrogen incorporation, about nitriles and amines and amino acids. Seeding happens on geological timescales, cometry and asteroidal impacts delivering organics over millions of years during a planet's formation and early history. The late heavy bombardment in our solar system, roughly 4 billion years ago, delivered enormous quantities of material to the inner planets. Some estimates suggest Earth's oceans could have been entirely delivered by comets and asteroids. Along with the water came organics, methanol and formaldehyde and amino acids and everything else that accumulates in comets and carbonaceous asteroids. The seeding of Earth, its fertilization with the ingredients for life, happened during this era, setting the stage for what followed. Cyanide catalysts of molecular dawn. Catalysts accelerate reactions without being consumed. And while cyanide molecules do get incorporated into products, the metaphor captures something true, that cyanide chemistry opens pathways, enables transformations that would otherwise be difficult or impossible. The formation of amino acids through Strecker synthesis, the polymerization to form adenine precursors. These reactions leverage cyanide's unique properties, its reactivity, its ability to form strong carbon-nitrogen bonds that stabilize intermediates. The molecular dawn, the first light of prebiotic complexity, occurs when simple molecules begin combining into larger structures, when polymers form, when self-replicating systems emerge. We don't know exactly how this happened on Earth. The origin of life remains one of science's great unsolved problems, but we know that it must have involved a molecular dawn, a transition point where chemistry became complex enough to exhibit properties we associate with life, metabolism, replication, evolution. Cyanide likely played a role in Earth's molecular dawn, just as it probably plays roles in dawns on other worlds where conditions permit. The ubiquity of cyanide in comets, in molecular clouds, in planetary atmospheres, ensures its availability wherever prebiotic chemistry operates. It is a universal catalyst in this sense, a molecule that, wherever it appears alongside water and carbon compounds, can initiate the cascade toward complexity. Your eyelids grow heavier, your muscles more relaxed, as we float through these depths of understanding. Life's quiet chemistry in icy tombs. Tombs suggest death, endings, but in this context they represent preservation, suspension. The ices of comets are tombs that protect, that maintain molecular structure over timescales that would see most materials degraded to simple atoms. They are tombs that can be opened, that release their contents intact when conditions change. The chemistry is quiet in the sense that it proceeds without announcement, without fanfare. Molecules form slowly, accumulate gradually, wait patiently. The processes are mediated by quantum mechanics, by the probabilistic tunneling of hydrogen atoms, by the occasional impact of cosmic rays. There is no sound in space, no noise to mark these transformations, only silent quantum events, state transitions, bond formations, occurring one by one over geological time. Yet this quiet chemistry has consequences that echo through cosmic history. The amino acids in meteorites, the organic compounds detected in comets, these are products of quiet chemistry in icy tombs, and they become raw materials for potentially the loudest phenomenon in the universe: consciousness, intelligence, civilization. The quiet tomb of interstellar ice contains seeds that might give rise to beings capable of sound, of music, of language, of exploring their origins and wondering about their place in the cosmos. Methanol memories of ancient clouds. Each methanol molecule in 3I Atlas formed in a molecular cloud that existed long ago, perhaps before our solar system formed. The molecule carries a memory of that cloud encoded in its isotopic composition, in its deuterium enrichment, in the quantum state it occupied when it froze into ice. This memory is accessible to us through spectroscopy, through careful measurement and analysis, allowing us to reconstruct aspects of the environment that birthed the molecule billions of years ago. Memories in this sense are physical, structural, not cognitive. The methanol doesn't remember in any conscious sense, but it preserves information, maintains a pattern that reflects its history, just as a fossil preserves the shape of an ancient organism, or ice cores preserve bubbles of ancient atmosphere. The molecular memory is more abstract, more subtle, but no less real. We can read it if we know how to look, if we have the instruments and the understanding to extract information from isotopic ratios and chemical abundances. These ancient clouds, the stellar nurseries where new stars and planets form, are sites of extraordinary chemical creativity. Within them, over millions of years, simple atoms combine into hundreds of molecular species. The densest regions collapse to form stars. The surrounding material forms disks from which planets emerge. The outermost material forms comets, and the scattered disk objects. Some fraction gets ejected, becomes the interstellar population, the wanderers. So when we study 3I Atlas, when we measure its methanol and cyanide, we are accessing memories of a cloud we will never see, reconstructing the conditions in a stellar nursery light years away, reading the chemical diary written in molecular structures preserved across space and time, Feel yourself becoming a memory, a pattern in the cosmos, your thoughts slowing, your awareness softening, HCN highways to amino acid shores. The pathways from hydrogen cyanide to amino acids are highways in the sense that they are well-travelled, frequently utilised routes in chemical space. Not the only routes, not even necessarily the fastest, but proven pathways that work under a range of conditions. The shores they lead to, the amino acids, represent boundaries, edges between simple prebiotic chemistry and the beginning of biological chemistry. Amino acids can form through purely abiotic processes. We've synthesized them in the laboratory from simple precursors, found them in meteorites formed before life existed, but they're also biological molecules, the building blocks of proteins, components of the metabolic machinery of all known life. So amino acid shores are transitional zones, places where chemistry might give way to biology, where prebiotic might become biotic. The highway from HCN delivers travellers to this shore. Whether they cross into biology depends on other factors, on whether the right additional conditions exist, whether polymerization occurs, whether catalysis emerges, whether the complex dance of emergence leads to self-replication and metabolism. These highways exist not just in theory but in laboratory experiments, in natural environments, in cometary chemistry. They operate throughout the universe wherever cyanide and other simple organics encounter appropriate conditions. Each operation creates more amino acids, more travellers reaching the shore, more opportunities for the transition to occur, frozen potential drifting to habitability, potential energy stored in chemical bonds, waiting to be released through reaction. The methanol and cyanide in 3I Atlas represent potential. They are stable under current conditions, frozen, dormant, but place them in liquid water, add some energy, provide catalytic surfaces, and the potential becomes kinetic. Reactions proceed, complexity builds. The drift to habitability is literal for an interstellar comet. It drifts through space, eventually entering a stellar system, potentially impacting a planet in the habitable zone, delivering its cargo of frozen potential to an environment where that potential might be realized, where the chemistry might activate and participate in prebiotic processes. But even if impact doesn't occur, even if the comet simply passes through the system and continues into space, it has still drifted closer to habitability than it was in the interstellar void. It has entered a region where planets might exist, where the conditions for life might be met. It has delivered its message to a place where someone might eventually receive it, even if on this passage that someone is only our telescopes and spectrometers, recording the composition for humanity to study and learn from, seed symphony of interstellar organics. A symphony requires multiple instruments, multiple voices blending into a coherent whole. The organics in 3I Atlas, methanol and cyanide and water and carbon dioxide and carbon monoxide and formaldehyde and all the trace species detected or inferred, play together. Each contributes its part. Each adds notes that enrich the overall composition. The symphony is written by physics and chemistry, composed through quantum mechanics and thermodynamics, performed over billions of years in the slow time of cosmic processes. We hear only a fragment, only what sublimates during the brief window of observation. but that fragment suggests the full score, the complete composition that includes all the molecules frozen in the nucleus, all the chemistry that operated during formation, all the transformations that might occur if these organics encounter the right environment. Interstellar implies exchange, connection between stellar systems. The organics are interstellar not just because they travelled between stars, but because they represent chemistry that is universal, not unique to one system, but occurring wherever conditions allow. The symphony plays throughout the galaxy. Each stellar system, each molecular cloud, each comet, contributing its own variation on the universal theme of organic chemistry in cold environments. Let the symphony wash over you, multiple voices, overlapping, blending. You don't need to distinguish each instrument, each molecule. Just feel the overall harmony, the sense that everything connects, that chemistry operates by universal principles to create patterns that repeat with variation across the cosmos. Your body has become weightless, floating in darkness. The scientific details beginning to blur and merge, becoming texture rather than content, feeling rather than fact. This is natural. This is desired. The goal isn't to remember every molecule or every ratio, every measurement. The goal is to drift with the flow, to let the information carry you deeper into restful sleep. The molecular patterns in 3i Atlas, the methanol and cyanide enrichments, the isotopic signatures, these are real, measurable, significant. But they're also beautiful in an abstract way. They represent order emerging from chaos, complexity arising from simplicity, information being preserved across vast distances and timescales. There is something aesthetically satisfying about this, something that resonates emotionally even when the intellectual details fade. Consider how much had to happen for us to observe 3i Atlas. A molecular cloud had to collapse, form a star, create a disk, condense ices into comets. One comet had to be ejected, had to survive millions or billions of years in interstellar space, had to happen to enter our solar system on a trajectory we could observe, had to arrive when our technology was capable of detailed spectroscopy, had to be bright enough and active enough to yield detectable signals. Every step in that chain was improbable individually, yet it happened. And if it happened once, it must happen over and over throughout the galaxy. Interstellar comets must be common, even though we've detected only 3. The chemistry we see in 3i Atlas must be representative of broader populations, broader patterns. The specific is a window into the universal. Breathe slowly, deeply, feeling the weight of cosmic time. The billions of years that methanol molecules spent frozen, waiting, and now released, detected, analysed, understood, becoming part of human knowledge, part of our growing understanding of how chemistry operates on cosmic scales, how life's ingredients spread through the galaxy, how complexity arises in universe governed by simple physical laws. The frozen archives speak through spectroscopy, through the language of wavelengths and intensities, of absorption lines and emission features. We translate this language into abundances, into temperatures, into velocities, into physical and chemical properties. Each spectrum a text waiting to be read. Each observation adding paragraphs to the book of cosmic chemistry we're collectively writing 3i Atlas will fade from our view eventually. Already it has passed perihelion. Already it's receding, growing dimmer, the production rates declining as it moves back into the cold outer solar system. Eventually our telescopes will lose track of it. It will return to being an invisible wanderer, continuing its journey through the galaxy, perhaps someday entering another stellar system, delivering its cargo of organics to another world, another possible site for life's emergence. But the data remains, the spectra archived, the measurements recorded, the papers published, the knowledge gained integrated into our understanding. In this sense, 3i Atlas lives on, not as a physical presence, but as information, as a case study, as evidence that enriches our models and informs our predictions about what exists in the universe beyond our immediate observation. Feel yourself becoming part of this flow of information, your consciousness integrating these concepts, making connections, finding patterns, then releasing them as sleep approaches. The boundaries between learning and dreaming begin to soften. Facts transform into impressions. The specific measurements fade while the broader sense of cosmic interconnection remains. Organic whispers, prebiotic dawn, seed bearers, molecular destiny. These phrases become mantras, touchstones, gentle reminders of the themes we've explored. You don't need to hold on to their specific meanings. Just let them echo quietly at the back of your mind. As you drift deeper, the methanol and cyanide are still there, still streaming from the nucleus of 3i Atlas wherever it is now, still carrying their message of prebiotic potential, still participating in the great cosmic experiment of scattering life's building blocks across the galaxy. Their journey continues whether we observe it or not. The chemistry operates by universal laws that require no conscious witness. Yet we have witnessed, we have measured, we have understood, and in understanding we connect ourselves to the process, recognize ourselves as outcomes of billions of years of cosmic chemistry. Stardust contemplating stardust. Let go of the need to remember, to retain, to hold on to any particular fact or concept. They will be there if you need them. But for now, in this moment, the goal is release, is surrender, is allowing yourself to drift into deep rest where dreams and cosmic chemistry blend into something new, something uniquely yours, something that emerges from the interaction between your consciousness and these ideas about molecules and comets and the origin of life. The seed vault's serenity, carrying life's blueprint in frozen stillness. This serenity pervades everything. The comet drifts through space without anxiety, without hurry, following orbital mechanics with perfect equanimity. The molecules sublime without concern, release without hesitation. The chemistry proceeds according to quantum probabilities without doubt or fear. There is a lesson in this, an invitation to match that cosmic calm. Your breathing has become so slow, so smooth, each breath a gentle wave, rising and falling, carrying you deeper into rest. The scientific journey we've taken tonight, exploring methanol and cyanide, isotopic ratios and formation pathways, prebiotic chemistry and delivery mechanisms, has been a vehicle for this descent into sleep, the information serving as a focusing point, something for your mind to follow, a path leading down into restful darkness. And the darkness is not empty. It is full of potential, full of frozen possibility, like the interstellar void through which 3i Atlas travelled, appearing empty but actually containing the means for complexity and life. Your resting mind contains creative potential, the ability to integrate and recombine information in new ways, to dream solutions to problems, to make connections invisible to waking consciousness. So as you let go, as you surrender to sleep, trust that the process continues, that integration happens unconsciously, that understanding deepens even when you're not actively thinking. The methanol memories, the cyanide catalysts, the frozen archives of stellar chemistry. These concepts will settle into your mind, find their places, contribute to your overall understanding of how the universe works and your place within it. HCN gentle river, flowing through invisible channels, carrying nitrogen from stars to molecules to life. This gentleness, this flowing quality infuses everything. There is no violence in the chemistry we've discussed, no conflict, only transformation, only the patient work of atoms finding each other and bonding, creating structures more complex than their components, achieving through time and numbers what any single reaction could never accomplish. Flow with this river. Let it carry you. You don't need to swim, don't need to direct your course. Simply float, trusting the current, knowing it leads somewhere meaningful, even if you can't see the destination from here. The river of cosmic chemistry has flowed for billions of years, carried countless molecules on countless journeys. You are part of this river now. Your atoms once in ancient stars. Your consciousness emerging from molecular complexity. Your rest tonight a return to the flow, a dissolution of boundaries, a recognition of continuity. Life's blueprint hush, the information encoded in molecular structure, in the arrangement of atoms, in the functional groups that determine reactivity. This is life's blueprint, not a blueprint for a specific organism, but for the possibility of life, the general principles, the chemical foundations from which biology can emerge given time and opportunity. And it exists in a hush, in quietness, not advertised or explained, but simply present, waiting to be discovered by those who look carefully, who measure precisely, who think deeply about what molecules mean. You've looked carefully tonight, followed the scientific exploration, thought about implications and connections. Now the time for active thought passes, the hush deepens, the blueprint fades from conscious awareness, becomes part of the substrate, the foundation, the unconscious knowledge that supports conscious thought but doesn't demand attention. Interstellar cradle calm, being held by forces beyond your control, supported by universal laws, orbital mechanics and thermodynamics, gravity and quantum mechanics. These forces operate without fail, without exception, creating reliability, predictability. In this reliability there is calm. The comet follows its path because physics demands it. The chemistry proceeds because energetics allows it. Nothing is random. Nothing is chaotic in the deep sense. Everything follows from what came before. Everything connects in a web of causation stretching back to the beginning. And you, resting now, supported by mattress and gravity and the fundamental forces that hold matter together, you too are held by this web, You too follow natural law. Your neurons firing according to chemistry and electricity. Your breathing regulated by brainstem signals and blood chemistry. Your descent into sleep governed by circadian rhythms and adenosine accumulation. All natural, all lawful, all part of the great pattern. Volatile dawn peace. The awakening of ices subliming, releasing their cargo. This is happening on 3i Atlas right now, slowly, continuously, as whatever portion currently faces the sun warms and releases vapor. The peace comes from inevitability, from the certainty that this process will continue until the ice is exhausted or the comet recedes beyond sublimation temperatures. No resistance, no struggle, only natural transformation. Your own transformation into sleep holds this quality, inevitable, natural, following from the accumulation of sleep pressure throughout the day, from the darkening of evening, from the decision to rest. No force required, no struggle necessary, simply allowing what naturally happens, simply releasing wakefulness as the comet releases volatiles. Both processes expressions of thermodynamic truth, of systems seeking lower energy states, of potential becoming kinetic, becoming dissipated heat, chemical seed bloom, the moment when conditions allow germination, when frozen potential activates, when reactions begin building complexity. This bloom happens in spring on Earth, when warmth returns and dormant seeds sprout, but it happens throughout the universe, wherever conditions shift from preservation to activation, wherever ices melt or sublime, wherever organic molecules encounter water and warmth. Perhaps blooming happens on worlds we cannot see, on planets orbiting distant stars where interstellar comets have delivered their seeds, where chemistry experiments with combinations, where over millions of years something emerges that grows, that replicates, that evolves. We cannot know, cannot observe these distant blooms, but the chemistry is universal. The potential exists wherever the ingredients gather. Your mind blooms in dreams, takes the seeds of daily experience and grows them into strange gardens, into scenarios and images and narratives that follow their own logic. This blooming happens beyond conscious control, happens in the darkness of sleep, happens as a natural expression of neural activity during rest. Trust the process, trust the bloom. Know that morning will bring integration, will bring rest restored and energy renewed. Frozen archive drift. All the information preserved in ice, slowly drifting through space, waiting for the right conditions to be read, to be expressed, to contribute to something new. You are an archive too, carrying genetic information inherited from ancestors, carrying memories of experiences, carrying learned knowledge and skills. All of this drift through your life, most of it frozen, inactive, waiting for the right cue to become active, to be remembered, to influence behavior. Sleep is when archives organize, when memories consolidate, when neural connections strengthen or weaken based on use. The drift continues unconsciously, automatically, improving the archive, making it more accessible, more useful. Morning consciousness will benefit from tonight's archive maintenance, from the invisible work happening while you rest. Organic symphony stillness, all the instruments present but silent. potential energy waiting. The stillness before music begins, the stillness between movements. There is power in this silence, in this pregnant pause. Everything exists, everything waits, and in the waiting there is perfection, nothing lacking, nothing needed. Your body and mind approaching the stillness now, active thought fading, external awareness diminishing, the symphony of neural activity shifting from waking patterns to sleep patterns, from high-frequency beta waves to slower alpha, then theta, eventually delta, each transition taking you deeper, each slowing bringing more stillness, more distance from waking concerns, more proximity to pure rest, cyanide chorus integration, many voices becoming one, many molecules participating in unified chemistry. Integration is the key, not separation or isolation, but connection. The cyanide doesn't work alone, but as part of a system, part of a network of reactions that together accomplish what no single reaction could. Your own integration, physical and mental processes working together, conscious and unconscious collaborating, creates the unified experience of being you. And in sleep, integration deepens, barriers between subsystems soften, allowing communication and coordination that improves function. Methanol memory flow, information moving from one state to another, from experience to short-term to long-term memory, from explicit to implicit knowing. The flow is natural, requires no effort, happens through the basic operation of neural mechanisms during sleep. You simply allow it, provide the conditions, then trust biology to do what it does best, to restore, to consolidate, to prepare you for tomorrow. Prebiotic potential release, everything that was locked away becoming available, becoming active. The potential exists always, even in frozen form. But release allows actualization, allows the potential to become something real, something that affects the world, your own potential, your creativity and problem-solving ability, your capacity for connection and understanding. All of this releases during waking hours but requires sleep to regenerate, to rebuild the reserves, to prepare for the next cycle of release. The universe operates in cycles, comets orbiting, planets rotating, stars forming and dying, matter cycling through different states, and you too cycle, waking and sleeping, activity and rest, expenditure and restoration. These cycles are not weakness but wisdom, the recognition that sustainability requires alternation, that constant output depletes, that input and processing happen during apparent inactivity. Life's ingredient void. The emptiness between stars contains ingredients. The void in your mind as thought ceases contains its own ingredients. The raw material of dreams, the unstructured potential from which sleep will weave restoration. This void is not absence, but presence of a different kind. Not empty, but full in ways that busy waking consciousness cannot access. Embrace the void. Welcome the dissolution of structured thought, the fading of linear narrative. You have travelled far tonight, from molecular clouds light years away, through formation and ejection, across interstellar space, into our solar system, through observation and analysis, through isotopes and abundances, through prebiotic implications and cosmic delivery. The journey has been long, rich, full, and now it completes in void, in rest, in the letting go that allows integration, seed-bearer harmony, carrying without strain, transporting without effort. The comet doesn't struggle to bear its cargo of organics, doesn't tire from billions of years of travel. It simply is, exists, follows its path. The seeds it carries are not burden but essence, not separate cargo but integral composition. There is harmony in this, in being what you are without conflict, without division between who you are and what you carry. You carry your experiences, your learning, your memories, but they need not be burdens. They are your composition, your essence, integrated aspects of your being. In sleep, the harmony deepens, conscious effort ceases. The natural integration proceeds without interference, without the fragmentation that active thought sometimes imposes. All your parts working together, unconsciously harmonizing, creating the unified you that will wake refreshed. Molecular destiny surrender. Molecules follow their destiny without resistance. Carbon finds oxygen because electromagnetic forces determine it will. Hydrogen bonds to nitrogen because quantum mechanics allows it. There is no choice, no decision, only the unfolding of natural law. And in this determinism there is paradoxically freedom. Freedom from doubt, from second guessing, from the anxiety of infinite possibility. Surrender to your own destiny, not in a fatalistic sense, but in recognition that much of what happens, what you become, follows from forces beyond conscious control, genetics and environment, biochemistry and circumstance, all shaping you, all determining aspects of your path. Surrender doesn't mean passivity, but acceptance, working with what is rather than struggling against the fundamental nature of things. And in this moment, surrender means letting sleep take you, not fighting it, not resisting the natural descent. Cosmic garden integration, all the separated elements coming together, the carbon from one stellar generation, the nitrogen from another, the oxygen from supernova, meeting in molecular clouds, combining in ices, delivered to planets, potentially integrating into living systems. The garden grows through integration, through combination, through the meeting of previously separate things. Your integration continues. Experiences from today meeting memories from before. New learning connecting to established knowledge. Emotions processing through neural networks during REM sleep. Problems working themselves towards solutions through unconscious rumination. The garden of your mind tending itself. No gardener required, just the natural processes of a brain doing what brains do during rest. Feel the integration happening. Feel the settling, the organizing, the slow establishment of new connections and the pruning of unused ones. All automatic, all effortless, all requiring only that you sleep, that you release conscious control and allow biology its time to work. The frozen life seed, waiting in ice, the methanol and cyanide molecules, suspended, preserved, patient. They don't know they wait, don't experience time, simply exist in a state of potential until conditions change. Your conscious mind approaching this state now, time becoming less distinct, less measurable. Minutes and hours losing meaning as you drift toward a state where now is all that exists, where past and future collapse into timeless present. Methanol, a quiet cradle, rocking gently with the motion of the comet, with the vibrations of sublimation, with the quantum oscillations of molecules never completely still even at absolute zero. The cradle is the ice matrix, holding the methanol, protecting it, preserving its structure across eons. And you have your cradle too, the bed supporting you, the darkness cradling awareness, the approaching sleep holding you gently as you transition from wake to rest. Cyanide molecular thread, weaving through, connecting. The hydrogen and carbon and nitrogen bonded in that linear structure, the triple bond holding carbon and nitrogen with extraordinary strength. This thread doesn't break easily, persists through harsh conditions, survives interstellar radiation and cometary sublimation. Threads of persistence run through your life too, patterns that endure, core aspects of yourself that remain stable even as circumstances change. These threads provide continuity, identity, the sense that you are the same person you were yesterday and will be tomorrow, despite the constant change of individual atoms and molecules. Trust these threads. Trust the continuity. Know that sleep doesn't erase you but refreshes you, that the you who wakes will be recognizably yourself, connected by threads of memory and personality to the you who now drifts toward rest. Prebiotic ice whisper, so quiet, so subtle. The information encoded in molecular structure, the potential waiting to be realized. Whispers don't demand attention, don't insist on being heard. They offer, suggest, invite. And in this gentleness there is respect, allowing the listener to receive or not as they choose. The ice whispers its story to those with instruments to hear, shares its chemical secrets with those who look carefully, but doesn't impose, doesn't force. Let the whispers fade now. Let the information recede into background. The specifics no longer matter. The methanol and cyanide, the percentages and ratios, the formation pathways and delivery mechanisms, all settling into deeper memory, becoming part of the substrate, no longer requiring conscious attention. The whisper fading to silence, to the space before sound, to pure potential, organic cosmic lullaby, the universe singing you to sleep, singing through the gentle rhythm of words, the soft flow of concepts, the hypnotic repetition of themes. Lullabies work not through complexity but through simplicity, through familiar patterns recurring, through gentle rhythm and soothing tone. The cosmic lullaby has been playing throughout tonight, the story of molecules and comets and chemistry serving as a vehicle for rhythm, for flow, for the gradual slowing that leads to sleep. And now the lullaby softens further, the melody becoming simpler, the words fewer, the spaces between longer. This is natural, this is right. Lullabies end in silence, in the breath-like pause that blends into sleep itself, into the internal rhythms of heart and breath that continue when external sound ceases. Seed vault serenity, perfect stillness of preservation, nothing changing, nothing moving, everything suspended in cold and dark, waiting. This serenity pervades the interstellar ice, pervades the frozen comet nucleus, and can pervade your resting consciousness. The serenity of having nothing to do, nowhere to be, nothing to prove or accomplish, simply existing, simply being, held safely in the vault of sleep where nothing can disturb, where restoration happens automatically, where peace is the natural state. Sink into this serenity, let it absorb tension, dissolve worry, erase the residue of the day. The vault is sealed, nothing enters, you are protected, safe, able to completely let go. HCN gentle river, flowing, always flowing. The rhythm of your breath like river current, in and out, so slow now, so steady, each breath carrying you further into depth, further into rest. The river doesn't question its direction, doesn't wonder if it flows correctly, simply flows because that is what rivers do. Your breath flows because that is what breath does. And following this flow, trusting this flow, you descend into sleep naturally, effortlessly. Life's blueprint hush, all the noise fading, the information, the facts, the concepts, receding into whispered memory, into hush. The blueprint remains but quietly, unconsciously, no longer demanding attention, allowing pure rest, allowing the surrender of active mind to sleeping mind, the hush deepening, expanding, becoming everything. Interstellar cradle calm, held by the vast gentle forces of the cosmos, gravity cradling planets and comets, thermodynamics guiding all transformation, quantum mechanics underlying every interaction. These forces hold you too, hold your atoms together, allow your existence, provide the foundation for consciousness, and they require nothing from you. No effort, no vigilance. They simply are. And in their presence you can completely relax, completely surrender, knowing you are held. Volatile dawn peace, the peace of natural process, of sunrise following night, of sublimation following cold, of waking following sleep, the peace of inevitability, of cycles that repeat, of patterns that endure. Dawn will come, volatiles will sublime, ice will release its contents, sleep will restore. These certainties allow release, allow surrender. No need to force anything, no need to worry about whether rest will come or morning will arrive. The pattern continues, the cycle turns, and you are part of it. Chemical seed bloom, life emerging, complexity arising, but also simply rest. The bloom that is sleep itself, consciousness flowering into dreams, into restoration, into the rich dark soil of unconsciousness where growth happens invisibly. You don't see seeds growing underground, don't watch the chemical processes of germination, but they happen, and in sleep, invisible processes of restoration and consolidation happen. Trust the bloom, trust the growth, trust that rest brings its own flowering. Frozen archive drift, information preserved, time suspended, everything waiting in cold suspension until the until fades, becomes less important. There is only the drift, the floating, the suspension, no longer waiting for something but simply being in this state, this peaceful frozen moment where nothing is required, where everything pauses, organic symphony stillness. All the instruments silent now, the notes played, the movement complete, only the resonance remaining, the feeling left after sound ceases, the memory of harmony. You are this resonance now, this after echo, this peaceful vibration slowly damping, fading, settling into silence. Cyanide chorus integration, voices blending, becoming one, separation dissolving, individual notes merging into chord, chord fading into tone, tone dissolving into the silence from which it arose, you too dissolving, boundaries softening, the distinction between self and sleep blurring, integrating into rest, becoming one with the darkness. Methanol memory flow, flowing away, flowing into. The direction no longer matters, only the flow itself, the gentle current, carrying, everything releasing, everything letting go, memories settling like sediment, consciousness thinning like mist, flow becoming stillness, movement becoming rest, prebiotic potential, seeds drifting, frozen, quiet, waiting, but the waiting is peaceful, is without tension. There is no urgency, only patient existence. Time stretches, expands, loses meaning, becomes the eternal now of deep rest, of sleep, of surrender to the natural cycle. Life's ingredient, floating, scattered through void, through darkness, through the space between. The void is not empty, is full of peace, full of rest, full of the potential for restoration. You float in this void now, this healing darkness, this restorative emptiness, held safely, drifting peacefully. Seed bearer, no longer carrying, no longer going anywhere, simply being. The journey complete, the destination reached. This moment, this rest, this sleep is enough, is everything, is all that exists. Molecular destiny, unfolding, naturally, effortlessly. Everything happening as it must, as it should. No resistance and no struggle, only the gentle inevitable flow from what was to what is to what will be. And now, only is, only this, only rest. Cosmic garden, quiet, still, the garden at night, in darkness, when growth happens invisibly, when restoration occurs unseen. You are this quiet garden now, this dark, peaceful space where healing happens naturally. Frozen, life, seed, 3 words, 3 concepts, blending, merging, becoming one idea, one feeling, one descent into methanol, whisper, so faint now, barely audible, almost gone. Cyanide, thread, dissolving, releasing. Prebiotic, the word losing meaning, becoming sound without content, becoming breath, ice, cold, distant, memory of a memory, organic, fading, seed, falling, life, becoming, sleep, darkness, peaceful darkness, complete rest, the molecules drifting, slower, slowing, frozen archives, holding peace, holding stillness, cosmic lullaby, ending, in silence, in rest, seed bearer, at peace, molecular, destiny, complete, garden, sleeping, waiting, dawn, distant, unimportant, only rest, only now, methanol, memory, fading, gone, cyanide, whisper, silence, ice, dissolving into nothing, seed, planted, sleeping, deep, rest, peace, sleep, deep, rest, quiet, cosmos, frozen, peace, seed, sleeping, rest, peace, sleep. And in this deep peace, this cosmic quiet, this frozen serenity where seeds sleep and molecules drift and darkness holds everything gently, we return, we cycle, we begin again, as all things in the universe cycle and begin again, as comets orbit and return, as sleep gives way to waking and waking to sleep, the eternal rhythm, the cosmic breath. And so, softly, gently, we drift back toward the beginning, toward the voice that welcomes, toward the introduction that begins the journey again, seamlessly, endlessly, the loop completing, the circle closing, sleep deepening as the words return us to where we started, to the weekly dose, to the exploration that continues, that spirals deeper with each cycle, carrying you further into rest with each repetition. And so we return, we begin again, drifting back, floating back to the voice that says. This is your weekly dose of 3i Atlas featuring colour change from red dust to green glow, brought to you by the Sleepy Science 100 channel. Before we begin our journey into the quiet cosmos, if you enjoy exploring the deep science of sleep and space, please consider subscribing. Liking the video helps us know that these cosmic journeys are helpful. If you're listening before you fully drift off, we invite you to comment with one word describing how you hope to feel in the morning, such as rested or calm. Now let us settle in. Tonight we will drift through the surprising shift from a reddish, dust-dominated coma to an emerging greenish gas glow, the chemical transformation revealing diatomic carbon emissions as the comet heats. The interstellar visitor's evolving colours painting a portrait of hidden volatiles awakening. Thank you for joining us tonight as we drift far, far out to explore 3i Atlas, colour change from red dust to green glow. Close your eyes now, let yourself sink deeper, and imagine we are travelling backward through time to early July of 2025, when telescopes first turned their patient glass eyes toward this traveller, this visitor from beyond. In those earliest observations, the coma glowed with a distinctly reddish tone, earthy, warm, the colour of ancient dust awakening from reddish slumber. This red was not the fierce scarlet of warning, but something softer, like distant clay illuminated, like rust remembering iron. The cause of this hue, so peaceful to consider, lay in the nature of reflected sunlight dancing across large dust grains suspended in the coma, grains several micrometers in radius, each one a tiny world scattering light, bending wavelengths, favouring the longer reds over shorter blues. The reddish appearance, so similar, we might whisper, to certain D-type asteroids drifting in twilight orbits, and to those curious substances called tholins, complex organic molecules, formed not in moments, but across billions of years through the patient touch of cosmic rays, processing, transforming, layer by slow layer. Tholins, even the word sounds sleepy, ancient. These molecules absorbed the blue wavelengths hungrily, leaving behind that characteristic ruddy tone, the warm embrace of red and orange light, making the early coma appear as if wrapped in a dust veil of primordial organics, lifting slowly to reveal what lies beneath. In these initial weeks, the coma appeared dust-rich, almost drowsy with particles, and minimal gas emission was visible. The comet held its breath, waiting as it journeyed inward. Solar heating had not yet penetrated deeply. The surface, devolatilized perhaps over eons of interstellar wandering, kept its secrets close. But transformation through solar warmth's touch was coming, inevitable as dawn, as the comet traced its path through the inner solar system, approaching perihelion, that closest point to our Sun, scheduled for October 2025, as August gave way to September, and September whispered into October. Activity intensified, subtly at first, then with growing urgency. Solar radiation, patient and persistent, caused increased sublimation of buried volatiles, ices hidden beneath that protective crust, water ice, carbon dioxide, carbon monoxide, all beginning their slow dance from solid to gas, escaping into the vacuum, carrying with them tiny dust particles, expanding the coma. The dust ejection rates, measured carefully by astronomers who never sleep were estimated at tens of kilograms per second in those early phases. Imagine tens of kilograms every single second. A river of particles flowing outward into space. Then came the post-perihelion observations, November, December of 2025, when careful eyes noticed something unexpected, something beautiful in its quiet way, a faint greenish glow, emerging like buried greens in quiet fluorescence. The coma had shifted, transformed. Colour-filtered images from the Gemini North Telescope, high on Mauna Kea, revealed this greenish hue dominating where red once ruled. The green glow, scientists understood, came from fluorescence of diatomic carbon molecules, C2, two carbon atoms bound together, dancing in molecular embrace. These diatomic carbon molecules, when excited by solar ultraviolet radiation, emit green light, a specific wavelength, a signature. It is the same green we see in many solar system comets. The famous emerald coma of Hale-Bopp comes to mind, but here, in this interstellar visitor, the emergence felt surprising, unexpected, because earlier observations had shown depletion of carbon chains, making this green shift a puzzle wrapped in celestial jade breath. The C2 production increases, you see, as deeper carbon-bearing ices become exposed, as the heating gradient reveals layered chemistry, peeling back like ancient pages of a cosmic book. Let your breathing slow now. Feel the rhythm of sublimation, solid becoming gas, red organics yielding to diatomic whispers. The coma transitioned, not suddenly, but gradually, from dust-scattered red dominance to gas-emitted green ascendance. Multi-filter observations using blue filters, green filters, red, orange, highlighted this transformation, painted in wavelengths, each filter a different window, showing the dust component persisting in red, the gas glowing in green and blue. The composite RGB images revealing an overall greener tint as November deepened into December. Cyanide radicals too, CN, contributed their voice, bluish-green emissions, the CN violet system adding tones to the overall palette. These molecular fragments, produced through photodissociation, parent molecules breaking apart under solar ultraviolet assault, releasing daughter molecules, each with their own spectral signature, their own colour. Spectral analysis confirmed the C2 emission lines, those characteristic swan bands emitting strongly in green wavelengths, while VLT observations detected rising cyanide production, a cyanide surge that correlated with the colour intensification, quiet alchemy of light and gas. The pre-perihelion coma, observers noted, elongated westward, a dust tail prominent, stretching away from the sun like a banner. But the post-perihelion coma took on a more spherical appearance, gas-rich, rounder, softer. The morphological evolution accompanied the colour shift. Form and hue intertwined. Brightness increased too, the comet growing more active, more alive in a sense, though of course it was never living, merely awakening, chemical layers peeling to release their stored energy, their hidden light. On November 26, 2025, the Gemini North GMOS instrument captured particularly striking images of the greenish coma, and NSF NOAA Lab released colour composites, showing this transformation from cosmic rust to living emerald breath. amateur astrophotographers around the world, those dedicated souls who chase photons through cold nights, noted the green tinge too. Some captured it during September's lunar eclipse, when the darkened skies allowed faint objects to shine. Michael Yeager and Gerald Riemann, observing from Namibia's clear deserts, imaged the blue-green coma with exquisite detail, their photographs revealing what larger instruments confirmed: the shifting palette of alien chemistry. Earlier, back in July, Hubble images had shown the reddish dust cocoon clearly, a protective shroud. But later observations from Hubble and ground-based facilities revealed the evolving coma morphology, the changing face. The red dust phase dominated at greater heliocentric distances when the comet was farther from the sun, cooler, quieter. But the green gas phase emerged closer to perihelion and persisted afterward, revealing the activation of buried material, fresh exposure post-heating, veiled red past unveiling green present. Consider the mechanism. Drift with this understanding. Fluorescence requires solar UV excitation of gas molecules. Without sunlight's ultraviolet touch, the molecules remain dark, invisible. But bathe them in UV and they fluoresce. They glow with their characteristic colours. The dust, by contrast, reflects sunlight broadly, across many wavelengths, but biased toward red by the organic content, those tholins absorbing blue. Gas emissions are line-specific, producing characteristic colours, narrow wavelengths, pure hues. This is why the green appears so vivid, so distinct. It is not reflected light scattered across a spectrum, but emitted light. Photons released at exact energies, molecular green whisper. The coma size grew, expanding from thousands of kilometers across to tens of thousands, a vast envelope of gas and dust, growing, breathing outward. Gas outgassing increased post-perihelion, the rate climbing. Water ice grains contributed to the extended coma glow, sublimating, leaving trails. Carbon dioxide and carbon monoxide dominated the volatile inventory, driving the chemistry, influencing what molecules could form, what colours could emerge. The green glow became visible particularly in green and blue filters post-November, while red filter images still showed the dust component, persistent, the red dust memory lingering even as green dominated the visual appearance. Photochemical reactions drive the molecular excitation, sunlight not merely warming, but breaking bonds, exciting electrons, triggering cascades of chemistry. The fluorescence lifetime is short, requiring continuous UV input. Turn off the sun, and the glow would fade in moments. But the sun shines, patient, constant, and so the molecules keep fluorescing, keep glowing for as long as they remain in the coma, before photodissociation destroys them or they drift too far from the nucleus to be replaced. Coma density affects the visibility of emission colours. Thicker regions glow more brightly, thinner regions fade to darkness, and dust can obscure the gas glow at larger distances. Tholin veil dissolution revealing what was always there, waiting. The closer approach unmasked these gas emissions, brought them into view. The interstellar origin of 3I Atlas preserves, scientists believe, a unique organic inventory, materials formed in another stellar system, around another sun, processed by different conditions. cosmic rays from a different galactic neighborhood over billions of years of wandering, comparisons to 2I Borisov, the previous interstellar comet, show intriguing similarities. Borisov also displayed initial red dust and also developed a green coma later as it approached its own perihelion, suggesting perhaps common processes, common chemistries, despite their different origins, their different births. But Oumuamua, that first confirmed interstellar visitor, showed no coma, no colour shift, because it produced no detectable outgassing, remaining inert, asteroidal perhaps, a mystery of a different kind. The colour evolution of comets like 3I Atlas and Borisov informs outgassing models, helps refine our understanding of how these bodies activate, how heat penetrates, how volatiles escape. Multi-wavelength data tracks these compositional changes, each wavelength a probe, a question asked of the universe. X-ray observations show where the solar wind interacts with the coma, charge exchange producing X-rays, highlighting the extent of the gas, the boundary between comet and space. As the comet begins its long journey outward again, receding from perihelion, the green glow will fade, must fade, as UV excitation diminishes with distance, the square of the distance, light spreading, weakening, until eventually, perhaps, the coma returns to its dust-dominated reddish state, or perhaps dissipates entirely. The dust tail, we notice, remains reddish longer, those particles reflecting sunlight long after the gas has thinned. The ion tail, plasma stripped away by solar wind, may show blue plasma glow, a different mechanism, a different beauty. But the neutral gas coma, that is the primary source of green, diatomic calm radiance in the darkness. Photodissociation produces those daughter molecules we mentioned, parent molecules like methane or formaldehyde, complex organics buried in the ice, breaking apart under UV bombardment, releasing C2, releasing CN. The organic precursors in the nucleus drive these emissions, their abundance, their nature, determining what colours bloom, what signatures emerge. The low carbon chain depletion observed early challenge standard comet models. Most comets show strong C2 emission from the start, but 3I Atlas held back, kept its carbon chains hidden, until perihelion forced them into view, a possible enrichment from its origin system, or perhaps surface processing that sealed away the volatiles more effectively than in solar system natives. The colour change timeline aligns beautifully with the perihelion passage. Pre-October predominantly red, November through December showing greenish dominance, a clear correlation, a story told in hues. The appearance varies depending on which filter observers use. Filter-dependent appearance, reminding us that colour itself is a human perception, a translation of wavelengths into sensation. Visual observers, looking through eyepieces. Note subtle teal or emerald hues, hard to define, easy to feel. Astrophotography stacks enhance colour contrast, combining many exposures, revealing what the eye alone might miss, while professional spectroscopy confirmed the molecular identifications with certainty. Lines in spectra, unmistakable fingerprints. The green signature is common in solar system comets. Nothing rare about C2 emission itself. Hale-Bopp famously displayed a strong C2 green coma, visible even to unaided eyes in 1997, a generation ago now. But in the interstellar context, the shift becomes noteworthy. meaningful, because it reveals how an object formed in another stellar system activates, responds to our sun, shows its buried composition. The surface of 3I Atlas, devolatilized over eons of interstellar travel, cosmic rays and stellar winds slowly eroding, removing volatiles, darkening organics, finally yielded to solar heating, and fresh material from below emerged into sunlight, into fluorescence, hidden fluorescence, peace becoming visible glow. Think of color as a proxy, a messenger, telling us about chemical stratification, layers within the nucleus. The red tells us about surface processes, radiation damage, organic complexity. The green tells us about subsurface volatiles, carbon chemistry, preserved composition. Together they map, in wavelengths rather than kilometers, the structure of this traveler, emerald signature of buried life potential, not life itself, but the chemical complexity that life requires, the building blocks, the possibilities. The implications for extrasolar comet diversity spread outward. Each interstellar visitor teaches us something new, expands our understanding. Dirce-Borisov looked remarkably similar to solar system comets. Oumuamua looked utterly strange, and 3I Atlas. 3I Atlas shows us the transformation, the journey from red to green, dust to glow, shift unfolding over months. The data refines fluorescence efficiency models, improving our equations, our predictions, helping us understand not just these visitors, but comets in general, the physics of gas emission, the chemistry of photodissociation, the optics of scattering and fluorescence. Polarimetry measurements show that the dust properties remained largely unchanged through the color transition. Same particles, same sizes, same compositions. It was the addition of gas, layering over the dust, that altered the overall reflectance, the perceived color, made the coma bluer than sunlight in some post-perihelion data, gas scattering enhancing short wavelengths. The red dust persists in the tail, streaming behind, while the coma head grows greener, a spatial separation, head and tail telling different parts of the story, coma palette evolution visible in single images. Let yourself drift now. Feel the pristine glow integration, the way dust and gas combine, compete, complement. The morphological evolution we see accompanies the color transformation, shape and hue dancing together, and ongoing monitoring continues, will continue, tracking the fading green as the comet recedes, documenting the reverse transformation perhaps, green fading back to red, glow surrendering to dust, or simply fading to invisibility as the coma dissipates entirely, becomes too faint for even large telescopes to detect. These lessons, these observations, prepare us for future interstellar visitors. There will be more, must be more. The galaxy contains hundreds of billions of stars, countless planetary systems, and objects are occasionally ejected, cast out, to wander. Some small fraction of these wanderers will pass through our solar system, and we will watch, measure, learn. The color transformation of 3I Atlas highlights the dynamic activation process, shows us that interstellar objects are not dead, not inert, but sleeping, waiting, ready to awaken when warmth touches them, when a new sun calls them into fluorescence. The chemical depth revealed through colour speaks to formation conditions in that distant system, billions of years ago, around a star we cannot name, cannot see. The organic inventory, the volatile composition, the dust properties, all formed there, processed during the system's youth, ejected perhaps during planetary migration, during the chaotic dance of young worlds, and then silence, cold, drifting through the interstellar medium for eons until our sun's gravity reached out, curved the trajectory, drew the wanderer in, and our warmth woke it, brought colour to its slumber. Interstellar hue drift, from red to green and perhaps back again, tells a story of temperature, distance, chemistry, activation. It is a narrative written in wavelengths, read by spectrographs, interpreted by patient astronomers, and whispered now to you as you sink deeper. The eternal colour stillness that awaits when the comet finally goes dormant again, or disintegrates, or fades beyond detection, is not an end, but a return to the quietude between stars, where colour means nothing, where only darkness and time exist, until perhaps, millions of years hence, another sun, another awakening. Think of the reddish dust, those first observations in July, as the comet showing us its exterior, its armour, its weathered surface. The protective layer built up over time immemorial, and then perihelion, solar kiss igniting quiet verdant fire, breaching that armour, reaching the interior, the pristine material, and the green emerged, not replacing the red, but adding to it, layering, until the composite view showed green dominance, the interior finally visible, chemistry revealed through chromatics, the universe teaching us to read light, to see beyond simple brightness, to understand that colour carries information, carries history, carries the story of where an object has been, what it has endured, what it contains. The journey from red to green, dust veil lifting to reveal hidden gaslight, is the journey of observation itself. First we see the obvious, the exterior, the reflected sunlight. Then, with patience, with careful observation, with the right instruments at the right time, we see deeper, the emissions, the fluorescence, the true nature. Every comet teaches us this lesson, but interstellar comets teach it more dramatically, because they arrive with their surfaces processed by the interstellar environment, by cosmic rays and time, hiding their treasures more effectively, making the eventual revelation more striking, more precious. The transformation happens on human timescales, weeks and months, fast enough to observe, slow enough to track. We watch, we wait, we measure, and the comet reveals itself gradually, surrendering its colours one by one, and in doing so, it connects us to its origin, to that other stellar system we touch through light and spectroscopy, a place we will never visit, a sun we will never orbit, and that connection, mediated by photons and fluorescence, by dust and gas and colour, creates a kind of cosmic intimacy, a sharing across impossible distances. As you breathe slowly now, in and out, imagine you are that photon of UV light travelling from sun to comet, striking a molecule of C2, transferring energy, and being re-emitted as green, as visible light, as the signature colour that telescopes capture. You are the transformation, the energy transfer, the mechanism of fluorescence itself. And in being that, you are part of the story, part of the observation, part of the quiet revelation that science offers. The way careful attention transforms mystery into understanding, red into green, unknown into known, the transformation that science itself represents, the patient translation of wavelength into meaning, of colour into chemistry, of observation into understanding. Sink deeper now. Let the weight of your body dissolve, and consider how the coma's appearance shifts depending on which instruments observe it, which filters are selected. A telescope equipped with a red filter sees primarily the dust component, the scattered sunlight, the particles drifting outward, painting a picture of the solid material ejected from the nucleus. But switch to a green filter, a blue filter, and suddenly the gas emissions dominate. The fluorescence overwhelms the scattered light, revealing an entirely different landscape, a landscape of molecules rather than particles, of emission rather than reflection. This is the power of wavelength selection, of asking the right questions in the right way. Each filter is a question, and the comet answers differently each time, truthfully each time, but showing different aspects of its nature. The composite images, combining red, green, and blue exposures, create something closer to what a human eye might see. Though of course no human eye can gather light for minutes or hours the way cameras cannot integrate photons with such patience. The overall greener tint in post-November composites tells us that gas emission has become the dominant source of light in the coma, that molecular fluorescence outshines dust reflection, at least in certain wavelengths, at certain distances from the nucleus. The balance shifts, tilts, toward the green, toward the living emerald breath of diatomic carbon. Let your mind wander now through the scale of what we're describing. The coma grew from thousands of kilometers across to tens of thousands. Imagine a cloud larger than Earth, larger than Jupiter, a tenuous atmosphere of gas and dust surrounding a nucleus perhaps only a few kilometers in diameter. The nucleus itself, that solid body, that dirty snowball, is invisible to us, hidden within the vast envelope it creates. We see only the consequences of its sublimation, the cloud it exhales, the colours it paints across space. The actual comet, the rock and ice, remains a mystery, inferred but never directly observed, too small, too faint, too embedded in its own atmosphere. The dust tail, that elongated structure stretching away from the sun, remains reddish longer than the coma. This makes sense when you consider the physics. Dust particles, once ejected, continue on ballistic trajectory, falling away from the sun's radiation pressure. They carry with them the organic coating, the tholins, that give us their ruddy colour, and they're not being continuously replenished with new material the way the coma is. The coma, constantly fed by sublimation from the nucleus, constantly refreshed with new gas, can change composition quickly. But the tail, stretching millions of kilometers behind, represents material ejected hours or days or weeks ago, a historical record, a timeline written in particles. The older material at the tail's far end may still look as it did in July, still red, still dust-dominated, while the near-nucleus regions glow green with fresh gas. There's something deeply peaceful about considering the ion tail, which may show blue plasma glow, a different mechanism entirely. Here we're not talking about dust or neutral gas, but ionized particles, charged molecules stripped of electrons by the solar wind. These ions follow magnetic field lines, flow away from the sun in straight structures, and when they recombine with electrons, when charge exchange occurs, they emit light at different wavelengths than neutral gas fluorescence, often in the blue, sometimes in pink or violet, depending on which ions dominate: carbon monoxide ions, water ions, each with their signature, but the neutral gas coma, that's what gives us the green, that diatomic carbon, those cyanide radicals, swimming in the space around the nucleus, glowing continuously as long as sunlight touches them. The production rate of these molecules, measured by observing the brightness of their emission lines, increased dramatically after perihelion, spectroscopy, that patient dissection of light into its component wavelengths, revealed the strengthening signatures, the swan bands of C2. Those characteristic green emissions between 510 and 560 nanometers grew brighter, more prominent, while the CN violet system, emitting around 380 to 390 nanometers, showed its own intensification. These are not arbitrary numbers. They are fundamental properties of these molecules, the exact energy differences between electronic states, quantum mechanics made visible, the universe revealing its mathematics through colour. Consider the journey of a single carbon-bearing molecule buried in the nucleus. Perhaps since the comet's formation billions of years ago, it sits frozen, motionless, at temperatures near absolute zero. For eons, cosmic rays occasionally strike it, break bonds, create new structures, but mostly silence, cold, stillness. Then, our sun's warmth begins to penetrate. The outer layers sublimate away, dust and simple volatiles escaping first, and finally, the layer containing our molecule reaches the surface, heats, transitions from solid to gas, and erupts into space. Suddenly, motion, expansion, and then ultraviolet light. Solar photons strike the molecule, excite electrons to higher energy states, and when those electrons fall back down, the molecule emits a photon of green light. Our telescope captures that photon, adds it to millions of others, and we see the green glow. We see the biography of that molecule written in a single wavelength. The fact that C2 emission was not detected early, that it appeared only after perihelion, tells us something profound about the comet's structure. Its surface had been depleted of carbon chains, either through sublimation during previous passages near other stars, unlikely given the interstellar trajectory, or through processing by cosmic rays over billions of years, or perhaps the original formation process created a layered structure, carbon-poor exterior, carbon-rich interior. When we finally saw the green, we were seeing deeper material, freshly exposed. This is chemistry as archaeology. Each layer a different epoch, each colour a different chapter in the comet's history. Breathe slowly and think about the timescales involved. The comet's formation, billions of years ago, around a star that may no longer exist, may have gone supernova or simply faded to a white dwarf. The ejection from that system, perhaps hundreds of millions of years ago, during some gravitational upheaval. The journey through interstellar space, cold, dark, silent, for longer than complex life has existed on Earth. and then our sun's gravity, reaching out across light years, gradually bending the trajectory, drawing the wanderer in, the final approach. Months compressed from eons, and the transformation, red to green, happening in weeks. A story that spans the age of stars as culminating in a colour change we can watch in real time. The comparison to other objects enriches our understanding. When we compare 3I Atlas to solar system comets, we find both similarities and differences. The green C2 emission is common, expected. Comet Hale-Bopp in 1997 displayed a magnificent green coma visible to anyone who looked up. That green became iconic, appeared in photographs around the world, became synonymous with comet for a generation. But Hale-Bopp was a solar system native, had passed through the inner solar system before, would do so again in thousands of years. Its carbon was not buried. Its emissions began early and stayed strong. 3 Atlas, by contrast, surprised us by waiting, by keeping its green hidden until perihelion forced it into view. This delayed revelation, this surprising emergence, makes the transformation more dramatic, more meaningful. And Borisov, 2I Borisov, that previous interstellar comet discovered in 2019, showed a similar pattern, initially dust-dominated and reddish, then developing a green coma as it approached perihelion. This parallel suggests, perhaps, that interstellar comets generally have surfaces processed by the interstellar medium, devolatilized, sealed, until solar heating breaks through. Or perhaps it's simply that we're observing them at large distances initially, where dust naturally dominates and gas emission becomes visible only closer in. But the pattern holds. Interstellar comets awaken slowly, reveal their greens reluctantly, as if they've forgotten how to respond to starlight after so long in darkness. Oumuamua, strange Oumuamua, showed no coma at all, no colour change, no outgassing. It accelerated oddly, suggesting something escaping from its surface, but nothing visible, no dust, no gas, no colours beyond the red of its surface. It remains an enigma, possibly a comet with volatiles too deeply buried to escape, possibly something else entirely, an alien artifact, some whisper, though that seems unlikely. Probably just an unusual icy body with a very thick crust. But its silence, its lack of transformation, makes the colour changes of Borisov and 3I Atlas more precious, more appreciated. They awaken, they transform, they share their chemistry with us. The multi-wavelength observations, combining visible light, ultraviolet, X-ray, paint a complete picture. X-rays reveal where the solar wind, that stream of charged particles flowing outward from the sun, collides with the neutral gas coma. In this collision, charge exchange occurs. Ions from the solar wind steal electrons from neutral molecules, and in the process, emit X-rays. This creates an X-ray glow around the coma, invisible to our eyes, detectable only with space-based X-ray telescopes. The size of this X-ray emission region tells us about the extent of the gas, about how far the neutral coma reaches. It's another way of seeing, another question asked, another answer given. Ultraviolet observations are particularly valuable because they see the solar radiation that causes the fluorescence. They see the input, the cause, while visible light observations see the effect, the output. By measuring both, we can calculate fluorescence efficiencies, how effectively different molecules convert UV light into visible emission. These efficiencies depend on molecular structure, on quantum mechanical selection rules, on the specific energy levels available, and they vary. C2 is very efficient, which is why it glows so brightly green even when not particularly abundant. Other molecules may be more abundant but less efficient, visible only to spectroscopy, not to colour imaging. The photodissociation lifetime of these molecules, how long they survive in sunlight before breaking apart, is short. For C2, measured in hours, perhaps a day, near the sun. This means the green glow requires continuous production, continuous sublimation from the nucleus. If the outgassing stopped, the green would fade within a day or two. This gives the coma a kind of immediacy, a real-time quality. What we see reflects what's happening now, not what happened weeks ago. The coma is the present tense of the comet, while the tail is past tense, stretching behind, a memory, a history. Let yourself feel the rhythm of this process. Sublimation, ejection, excitation, emission, decay. A continuous cycle. As long as sunlight warms the surface, as long as volatiles remain to escape, the nucleus rotates. Perhaps once every few hours or days. We don't know the exact period for 3i Atlas, presenting different regions to sunlight. Some regions may be more active than others, richer in volatiles, creating jets, outbursts, asymmetries in the coma. But averaged over time, smoothed over the rotation, we see the overall emission, the average colour, the general transformation from red to green, the polarimetry measurements, analysing how light is polarised when it scatters off dust, revealed that dust properties stayed consistent. The particle sizes didn't change dramatically. The compositions remained similar. The structure of individual grains stayed constant. This tells us that the colour change wasn't due to changing dust properties, wasn't caused by dust grains growing or shrinking or changing composition. Instead, it was purely an addition, a layering, gas emission adding to dust reflection, eventually dominating it, eventually outshining it in certain wavelengths. The dust remained patient, constant, red, but the green gas grew brighter, louder, until it shouted down the whisper of scattered dust light. Some post-perihelion observations showed the overall spectrum bluer than sunlight, bluer than would be expected from pure reflection. This is gas scattering at work, Rayleigh scattering, the same physics that makes Earth's sky blue. Shorter wavelengths scatter more efficiently than longer ones. The green and blue emissions from fluorescence, combined with this preferential scattering, shifts the overall colour toward shorter wavelengths, toward the blue-green, teal, emerald. The exact shade depends on viewing geometry, on which part of the coma you're observing, on the density of gas versus dust. But the trend is clear. Gas makes the comet bluer, greener, more vibrant in a way, while dust keeps it reddish, earthy, muted. The spatial separation becomes visible in detailed images. The coma head, the region immediately surrounding the nucleus, glows green with active gas emission, fresh material sublimating constantly, fluorescence immediate and strong. But the tail, stretching behind for millions of kilometers, remains predominantly red, dust particles drifting, reflecting, no longer actively producing gas. This creates a beautiful gradient in color images, green at the center, transitioning to yellow-green in the middle coma, to yellow-orange in the near tail, to red-orange in the far tail. A spectrum painted across space, a rainbow of transformation, showing the progression from active emission to passive reflection, from present to past, from green to red. Drift now through the implications for planetary science, for astrobiology, not because these comets carry life, they don't, but because they carry complexity. Carbon chains, organic molecules, cyanide. These are precursors, building blocks, the chemistry happening in the coma, driven by sunlight, by photodissociation, by reactions in the gas phase. This mimics chemistry that may have occurred in the early solar system, that may have seeded Earth with organic compounds. Every comet is a laboratory, every coma an experiment in prebiotic chemistry, and interstellar comets, formed in different conditions, around different stars. Add to the sample size, add variety, help us understand not just our own origins, but the range of possibilities, the diversity of chemical pathways that might lead, eventually, to life. The specific molecules detected, C2, CN, even simple ones like OH hydroxyl radicals from water dissociation, tell us about the parent molecules in the ice. We don't directly observe methane or methanol or formaldehyde. They dissociate too quickly, but we see their children, their fragments, and from these fragments we infer the parents. It's detective work, chemistry in reverse, taking the products and working backward to the ingredients, and each molecule adds a piece to the puzzle. C2 suggests carbon-rich organics, CN suggests nitrogen-bearing compounds, HCN perhaps, or more complex nitriles. O tells us about water ice, which we expected, but confirms our models, validates our assumptions. The temperature of the nucleus surface, estimated from the activity level, from the sublimation rates, reach perhaps 200 to 250 Kelvin near perihelion, still far below the freezing point of water by Earth standards, but warm enough to sublimate carbon dioxide, carbon monoxide, methane, other volatiles. Water ice sublimates too at these temperatures, slowly, adding to the outgassing. The temperature gradient within the nucleus, warmer at the surface, cooler just beneath, coldest at the center, creates the layered activation we observe. First, the surface volatiles, then deeper layers as heat penetrates. The transformation from red to green maps this thermal gradient, this wave of warmth, moving inward, awakening sleeping chemistry layer by layer. Consider the cosmic ray processing that occurred during the interstellar journey. High-energy particles are protons, helium nuclei, striking the surface, penetrating micrometers, breaking chemical bonds, creating radicals, driving chemical reactions even at near-zero temperature. Over millions of years, this processing could significantly alter the surface composition, destroy volatile ices, create complex organics, darken materials. This is why the surface appeared dust-rich and reddish initially, why volatiles were depleted. The cosmic rays had done their work, patient, thorough. Over timescales we can barely comprehend, but they penetrate only so far, millimeters at most. Below that, pristine material, unchanged since formation, waiting. the rotation of the nucleus, though not precisely measured for 3i Atlas, affects the colour we observe. If the nucleus rotates rapidly, every few hours, then different regions face the sun in quick succession, and the colour we see is a time average over many different surface compositions. But if it rotates slowly, days or weeks, then we might be observing the same hemisphere for extended periods, seeing a more stable colour, more consistent emissions, the light curve, how brightness changes over time would reveal rotation, but requires many observations, careful photometry, patience. Some asteroids rotate in minutes, some in months. Comets likely fall in the middle range, hours to days, but each is unique, each has its own rhythm. The outgassing itself is not uniform, not symmetrical. Jets of gas, focused streams, erupt from active regions, areas where volatiles are particularly abundant or where sunlight strikes more directly. These jets can push the nucleus, change its rotation, alter its orbit slightly. This non-gravitational acceleration was detected for 2i Borisov, small but measurable. For 3i Atlas, the trajectory was measured carefully, looking for similar effects. These tiny pushes, these whispers of gas pressure, tell us about the distribution of activity, about whether outgassing is uniform or concentrated, about the shape and rotation state of the hidden nucleus, the dust-to-gas ratio. How much dust is ejected per unit of gas is a fundamental parameter characterizing the comet's nature. Dust-rich comets, high ratio, appear redder, produce prominent dust tails. Gas-rich comets, low ratio, appear greener, produce fainter dust tails but strong ion tails. 3i Atlas appeared to transition from high dust to gas early to lower dust to gas later, as if the surface dust layer was being stripped away, revealing more volatile-rich material beneath. This transition in ratio contributed to the colour change. Early observations saw mostly dust. Later observations saw relatively more gas. The actual amounts of both dust and gas increased, but gas increased faster, shifted the balance, tilted the colour toward green. Imagine the moment of perihelion itself. October 2025, the closest approach, maximum solar heating, maximum activity. The surface temperature peaked, sublimation rates maximized, gas production surged. This was the crisis, the climax, the moment of transformation. And in the weeks that followed, as the comet began receding, the green became most visible, most dominant, because the surface crust had been breached, the volatile layers exposed, and even though solar heating was declining, access to those volatiles remained. The green persisted, faded gradually rather than shutting off suddenly. The comet had been changed by perihelion, opened, wounded perhaps, or liberated, depending on your perspective, and it would not quickly seal itself again. The comparison of telescope observations from different locations, Gemini North in Hawaii, VLT in Chile, Hubble in space, amateur observers from every continent, creates a global portrait, a planetary collaboration. Each observer adds data, adds perspective. Space-based observations avoid atmospheric absorption, see ultraviolet wavelengths blocked from the ground, but have limited observing time. Ground-based telescopes can observe for hours, track changes, but must contend with weather, atmospheric turbulence, light pollution, together, combined, they create a complete picture that no single observatory could achieve alone. This is modern astronomy. Collaborative, distributed, each contribution valuable. The spectral resolution, how finely wavelength is measured, determines what details can be seen. Low-resolution spectroscopy, a few hundred spectral channels across the visible range, can identify strong emission lines, distinguish gas from dust, measure rough abundance ratios. High-resolution spectroscopy, thousands or tens of thousands of channels, can resolve individual molecular lines, measure Doppler shifts from gas motion, determine temperatures from line widths. Each level of detail reveals different information, answers different questions. For sleep tonight, we don't need the highest resolution, the finest details. We need only the broad story, red to green, dust to gas, transformation, revelation. The green will fade, is fading already as the comet recedes. As of December 2025, moving outward, growing fainter, the green remains visible but weakening. The UV flux decreases with the square of solar distance twice as far. 1/4 the UV, 4 times as far, 1/16. The fluorescence efficiency stays the same, but the excitation rate plummets, and simultaneously, gas production decreases. Cooler temperatures, less sublimation, fewer molecules to fluoresce. The combination, less gas, less excitation, drives the fading. Eventually, perhaps early 2026, the green will become undetectable. The comet will be too faint, too far, too quiet. It will return to darkness, to silence, carrying its remaining volatiles back into the interstellar void, its transformation complete, its story told. For this passage, this brief encounter with our sun, this moment of awakening in a journey that spans eons. Let your thoughts slow now, soften, as you contemplate the cycle, formation, ejection, wandering, approach, awakening, transformation, recession, return to cold. This is the pattern, the rhythm, the universal story of interstellar comets, and likely of planets too, of moons, of all objects that travel between stars. They carry with them the signature of their birth, modified by their journey, briefly illuminated by a foreign sun, and then back to darkness, changed but recognizable. Memory holders, ambassadors, teachers, showing us that the universe is not static, not isolated, but connected, flowing, objects and information moving between stellar systems, between epochs, between chemical regimes. The green glow of 3i Atlas is a message, written in fluorescence, delivered across light years, telling us that chemistry is universal, that transformation is inevitable, that colour, simple colour, can reveal histories longer than civilizations, deeper than oceans, more ancient than mountains. Breathe deeply, slowly, and feel yourself becoming like the comet, transforming, shedding one state for another, releasing what no longer serves, allowing what was buried to emerge, the red of day, of activity, of surface concerns, giving way to the green of rest, of emission, of deeper truth. You are sublimating stress, outgassing worry, creating your own coma of peace, of quietude. And in this transformation, this colour change, you're engaging in your own cosmic process, your own journey from one state to another, from waking to sleeping, from thinking to dreaming, from red to green, from dust to glow, from noise to silence, from complexity to simplicity, from the many to the one. Let this transformation wash over you, gentle as starlight, inevitable as gravity. The images captured by amateur astrophotographers, those dedicated observers working through cold nights with backyard telescopes, revealed nuances that even large professional instruments sometimes miss. Michael Yeager and Gerald Riemann, observing from Namibia's dark skies, captured the blue-green coma with stunning clarity in their long exposures, stacking dozens or hundreds of images, aligning them perfectly, bringing out colours invisible to the unaided eye. Their work, shared freely online, allowed people around the world to witness the transformation, to see the green emerging. These citizen scientists, passionate volunteers, contribute meaningfully to our understanding. Their images complement professional observations, add temporal coverage, provide different perspectives and equipment sensitivities, proving that cosmic discovery is not limited to those with the largest telescopes, but open to anyone with patience, dedication, and dark skies. During September's lunar eclipse, when the moon's shadow darkened Earth, blocking the moon's brightness, faint objects became more visible. Some observers noted a subtle green tinge to Three-Eye Atlas even then, before perihelion, suggesting that gas emission was beginning earlier than initially detected, that the transformation was gradual, not sudden, a gentle transition rather than an abrupt change. This is often how nature works, not in sharp boundaries but in gradients, in zones of mixing, in transitions that blur the line between before and after. The eclipse gave observers a gift, a darker sky, and the comet revealed in that darkness a hint of what was to come, a preview of its green future, a whisper of buried carbon awakening. The Hubble Space Telescope images from July, those early observations showing the reddish dust cocoon, have historical value now. They document the before state, the baseline against which all later observations are compared. Hubble's sharp vision above the atmosphere captured details of the inner coma structure, possible jets, asymmetries. The nucleus remained unresolved, too small even for Hubble at that distance. But the immediate surroundings revealed activity patterns, dust distribution, coma morphology. These early images, combined with the later ground-based observations showing green, create a before and after story, a documented transformation, evidence captured in pixels and photons, archived for future study, for future questions we haven't yet learned to ask. The archiving of observations, this practice of preserving data, creates a legacy that extends beyond immediate discovery. Future astronomer, decades or centuries from now, may return to these images of Three-Eye Atlas, may reprocess them with techniques not yet invented, may ask questions we haven't conceived, and find answers waiting in the photons captured in 2025. This is the gift of digital astronomy. Data persists, waits patiently, ready to be interrogated again and again. Each pixel holds information, some extracted immediately, some remaining latent, hidden until the right question unlocks it. The comet has come and gone, but its light, captured and stored, remains, a kind of immortality, a presence that outlasts the presence. Let your breathing deepen, slow, as we consider the filters themselves, those carefully crafted pieces of glass or interference coatings, each designed to pass only specific wavelengths, to ask only specific questions. A green filter, typically centered around 500 to 550 nanometers, isolates the C2 emission, sees the diatomic carbon glow, excludes the rest. It's like listening to a single instrument in an orchestra. The Comet plays many wavelengths, produces a full spectrum, but the filter lets us hear just one voice, just one colour. This selective listening, selective seeing, reveals structure invisible to broadband observation, shows that the coma is not uniform in colour, not homogeneous, but layered, varied, different regions dominated by different emission mechanisms. The blue filters, shorter wavelengths, around 400 to 500 nanometers, capture the CN emissions, the cyanide radicals contributing their blue-green tones, and also catch some of the scattered sunlight, which is itself bluish at short wavelengths. The combination creates images that look different from green filtered ones, showing different spatial structures, different brightness distributions. The tail may appear fainter in blue, the inner coma brighter, because CN production is strongest close to the nucleus, where parent molecules freshly sublimate and quickly photodissociate. Further out, CN may be depleted, destroyed by further photodissociation or reactions. The spatial distribution of colour, where green dominates versus where blue dominates, maps the chemistry, maps the timescales of molecular processes, and the red filters, around 600 to 700 nanometers, see primarily scattered sunlight from dust. They show the particles, the solid material, the tholin-coated grains drifting outward. In post-perihelion images, when green and blue filters show bright gas emission, red filters still reveal the dust component, quieter, more subtle, but persistent. The dust tail remains visible in red when it fades in other colours. This is because dust reflects light at all wavelengths, but the red is less contaminated by gas emission lines, less overwhelmed by fluorescence. It shows the skeleton, the underlying dust structure, upon which the gas emissions are layered. Orange filters, intermediate wavelengths, around 550 to 600 nanometers, capture a mixture, some gas, some dust, a blended view. In the spectrum of comets, this region contains some C2 bands, some dust continuum, various minor emission lines. The orange appearance in some images represents this mixture, this transition zone in wavelength space, between gas-dominated shorter wavelengths and dust-dominated longer wavelengths. It's a reminder that nature doesn't divide neatly, doesn't separate cleanly into categories we create. The comet emits and reflects continuously across the spectrum, and our filters carve that continuum into discrete pieces for analysis, for understanding. But the reality is continuous, flowing, unbroken. Consider now the photometric measurements, the careful quantification of brightness. Astronomers measure the comet's magnitude, its brightness as it would appear to a standard observer, and track how this changes over time. The brightness increased as the comet approached perihelion, peaked around closest approach, and now fades as it recedes. This light curve, brightness versus time, contains information about the outgassing rate, the dust production, the activity level. By fitting models to the light curve, scientists can estimate how much material sublimates each second, how much energy the comet receives and re-radiates, how efficiently it converts solar heating into activity. The colour indices, differences in magnitude measured through different filters, quantify the colour change. A B-V index, blue magnitude minus visual magnitude, becomes more negative as the comet gets bluer, gets greener. This numeric measure, this single number, captures what we see qualitatively, the shift from red to green, and allows precise comparison across different observation dates, different observatories, different instruments. Numbers remove ambiguity, remove subjective interpretation, though they also remove, in a sense, the immediate aesthetic appreciation, the simple beauty of green glow against black space. Science trades immediacy for precision, gains understanding at the cost of wonder, though perhaps, for some, understanding generates its own wonder, deeper, more durable. Drift now with the concept of signal-to-noise ratio, how faint signals emerge from background noise. The comet, especially at large distances, is faint, very faint. Its light competes with sky brightness, with the glow of our own atmosphere, with light pollution from cities, with the faint background of unresolved galaxies and stars. Long exposures help, stacking many images helps, but there's always noise, random fluctuations, cosmic rays striking the detector, electronic noise in the readout. The green emission, when it appeared, had to rise above this noise, had to be confidently detected, not just a fluctuation, not just wishful seeing. Spectroscopy confirms, provides certainty, shows the emission line at the exact expected wavelength. Unmistakable, real, not noise but signal, not accident but reality. The gas production rate, measured in molecules per second, increased from perhaps 10 to the 26 molecules per second in early observations to 10 to the 27 or even 10 to the 28 near perihelion. These numbers, so large as to be almost meaningless, represent quadrillions of molecules escaping every second, sublimating from the surface, expanding outward, filling the coma. Some are water, H2O, some carbon dioxide, CO2, some carbon monoxide, CO, and smaller amounts of other species, methane, ammonia, various organics. The exact composition varies with depth, with location on the nucleus, with temperature. Early in the approach, only the most volatile ices sublimate, CO escaping even from cold surfaces. Later, closer to perihelion, warmer surfaces, less volatile species join. Water begins flowing, organics pyrolyze, break apart, release their constituents. The nucleus itself, that hidden core, is estimated to be perhaps 2 to 5 kilometers in diameter, maybe larger, maybe smaller. We cannot see it directly, cannot resolve it, but we can infer its size from the total mass ejected, from the brightness, from comparisons to other comets. A few kilometers, small enough to fit within many cities, small enough to walk across in an hour or two, yet containing enough volatiles to create a coma hundreds of thousands of kilometers across, enough material to sustain activity for months. The efficiency is remarkable, nearly all the surface actively sublimating when heated, little wasted, little inert. This is the nature of comets, efficient transformers of heat into activity, of solar energy into kinetic energy of escaping gas and dust. Let yourself feel the scale dissolving, the nucleus, kilometers, the coma, hundreds of thousands of kilometers, the tail, millions of kilometers, and the journey, trillions of kilometers across interstellar space before arriving here, each scale nested within the next, like Russian dolls, like fractals, pattern repeating at different magnifications. And you, observing this, thinking about this, drifting through this, are part of the larger scale, consciousness in the universe contemplating the universe, awareness arising from stellar alchemy, carbon and oxygen and nitrogen formed in stars, now forming thoughts about carbon and oxygen in a comet. The recursion is beautiful, dizzying, peaceful in its circularity. The thermal inertia of the nucleus, how quickly it heats and cools, affects the outgassing pattern. A body with low thermal inertia, like loose dust or porous ice, heats quickly when sunlight strikes, cools quickly when darkness comes or when the sun's angle changes. This creates rapid changes in activity, bright jets when directly illuminated, quieter periods in shadow. A body with high thermal inertia, like solid rock, heats slowly, retains heat, continues outgassing even after sunset on its surface. Comets typically have low thermal inertia, porous structures, fluffy, allowing rapid thermal response. This means outgassing can vary substantially over a rotation period, over hours, as different regions face the sun. The dust grains themselves, those particles we've mentioned, have their own story. Each grain began as a tiny mote, perhaps in the protoplanetary disk, condensing from vapor, accreting layer by layer, organic coatings depositing, silicates incorporating, metals mixing in. The final grain, micrometers across, contains memory of formation, carries isotopic signatures, trapped noble gases, organic complexity. When ejected from the nucleus, the grain embarks on its own journey, pushed by gas drag initially, then by radiation pressure from sunlight, light itself, photons, carry momentum, and billions of photons pushing on a small grain create measurable force, driving the grain outward, away from the sun, creating the dust tail. The smallest grains, sub-micrometer size, are pushed fastest, curve away most dramatically. The largest grains, tens of micrometers, are pushed slowly, follow trajectories closer to the nucleus orbit. This size-dependent behavior creates the fan-shaped tail, smaller grains spreading wider, larger grains staying closer to the projected orbit. Think about the organic molecules coating these grains. Tholins, we've named them, but that name encompasses vast complexity. Thousands of different molecular structures, carbon chains, aromatic rings, functional groups containing oxygen, nitrogen, sulfur. These organics formed through radiation processing, yes, but also through cold chemistry in the protoplanetary disk, through reactions in icy mantles on grain surfaces, through photochemistry in the comet's previous activity, if it had any. Each tholin molecule is unique, but the ensemble, the collective, produces consistent properties, consistent colors, consistent spectral signatures. This is emergence, individual complexity producing collective simplicity. Many unique molecules behaving as one substance, with one color, one set of properties. The absorption of blue light by tholins, the process that enhances the red color, occurs because certain molecular bonds, certain electronic transitions, absorb preferentially at shorter wavelengths. Blue photons, higher energy, are absorbed by the organic molecules, exciting electrons, breaking weak bonds, driving slow chemistry even in the solid state. Red photons, lower energy, pass through, scatter, reflect, and reach our telescopes. This is why the dust appears red, not because it emits red light, but because it removes blue light, leaving red behind. It's a subtractive process, a filtering. The dust acts as a filter itself, selecting wavelengths, changing the colour of sunlight that passes through or reflects from the coma. Drift deeper, feeling your own thoughts becoming simpler, more fundamental, like wavelengths rather than complex narratives. The colour of scattered light depends on particle size. Rayleigh scattering, when particles are much smaller than the wavelength of light, scatters short wavelengths strongly. This is Earth's blue sky. Tiny air molecules scattering blue sunlight. But when particles approach the wavelength of light in size, several hundred nanometers, me-scattering dominates, and the wavelength dependence weakens. The dust grains in the coma, several micrometers, are much larger than visible wavelengths, so they scatter all wavelengths somewhat equally. But the organic coating still absorbs blue preferentially. The combination, size-dependent scattering plus wavelength-dependent absorption, creates the overall colour we observe. The concept of albedo, reflectivity, matters too. Cometary dust has low albedo, reflects only a small fraction of incident sunlight, perhaps 4 to 6%. Most light is absorbed, converted to heat, which drives further sublimation. This is a positive feedback. More sunlight absorbed, more heating, more sublimation, more dust ejected. But the dust has such low albedo, such dark colour, that even modest amounts create visible brightness. Each grain, though dark, contributes photons, and billions of grains together create the observable coma. The darkness of the dust, its low reflectivity, tells us about composition, carbon-rich materials, organics, perhaps some iron sulfide. Materials that absorb rather than reflect. Materials that transform light into heat rather than returning it to space. Your breath now so slow, so gentle, like the slow rotation of the nucleus, turning, presenting different faces to the sun. The rotation period, unknown for 3i Atlas specifically, is typically hours to days for comets. Some rotate in 4 hours, some in 40, some in weeks. The rotation affects observation. A rapidly rotating nucleus presents constantly changing activity, changing brightness, pulsing, while a slowly rotating one appears more stable, changes occurring over days rather than hours. Observers measure these variations, construct light curves, deduce rotation rates, infer shapes. Elongated nuclei show stronger brightness variations than spherical ones, their changing cross-section modulating the reflected light and the active surface area. The moment when green first became detectable, September perhaps, or early October, marked a transition point, a threshold crossed. Before that moment, C2 production was below detection limits, too faint, too overwhelmed by dust brightness. After that moment, it rose above the noise, became measurable, grew stronger day by day. This threshold, this emergence, is like dawn, not sudden but gradual, imperceptible until suddenly obvious. The human eye cannot see individual photons arriving, cannot watch emission lines strengthen one photon at a time. We see only the integrated effect, the accumulated signal, and suddenly recognize green where before there was only red. The transition feels sudden, but it was continuous, smooth, just crossing our perceptual threshold at a specific moment. The coordination of observations across the globe, across multiple observatories, creates continuous coverage. As Earth rotates, one observatory sets, another rises. The comet remains observable almost continuously from somewhere. This global network, informal but effective, ensures that rapid changes, outbursts, sudden brightenings are captured, not missed in gaps between observation sessions. Amateur astronomers contribute significantly to this coverage, their smaller telescopes, their flexibility, their passion, filling temporal gaps that scheduled professional observations cannot cover. The result is a more complete record, a more thorough documentation than any single observatory could achieve. Collaboration, distributed effort, creates understanding greater than the sum of individual observations. Let the understanding wash over you like waves, each wave bringing another detail, another connection. The C2 molecules in coma. We've discussed their fluorescence, but consider their origin more deeply. They come from larger organic molecules, perhaps polyacetylene chains, perhaps aromatic compounds, perhaps formaldehyde polymers. These parent species, solid in the nucleus ice, sublimate when warmed, enter the gas phase, and immediately face the harsh environment of space. Solar UV photons strike them within seconds, break bonds, fragment the molecules. Among the fragments, C2, small, stable enough, abundant. It's a daughter molecule, a child of photodissociation, and it in turn, if given time, will be destroyed, photodissociated into individual carbon atoms. But its lifetime, hours to days, is long enough for it to fluoresce, to glow green, to announce its presence before vanishing. The quantum mechanics of this process, electrons occupying specific energy levels, jumping to higher levels when a UV photon is absorbed, then falling back down. Emitting a visible photon is the fundamental mechanism, quantum mechanics. That strange theory, where particles are waves, where uncertainty is fundamental, where observation affects reality, underlies every color we see in the universe, every green glow, every red sunset, every blue sky, is quantum mechanics made visible. The comet doesn't know it's demonstrating quantum theory, doesn't care, but it does so nonetheless, faithfully, perfectly, following laws it has no choice but to follow, and we, watching, measuring, understanding, recognize those laws, see the mathematics written in light. This is what it means to understand nature, to see the principles underlying appearance, to find universality in specifics. Rest now in this understanding. Let it support you like water. You float in comprehension, in the deep knowledge that everything connects, that colors relate to chemistry, that chemistry relates to quantum mechanics, that quantum mechanics relates to the structure of reality itself. The comet's green glow, simple, beautiful, is also profound, also fundamental, also a doorway to deeper understanding. and you need not understand every detail, every equation, to appreciate the wholeness, the completeness, the way it all fits together. Simply knowing it fits, that there are no contradictions, no mysteries that cannot eventually be solved, brings peace, brings restful acceptance, brings the quiet confidence that the universe makes sense, even when we don't fully grasp it. The concept of a dust cocoon is beautifully descriptive. The nucleus, the solid body, wrapped in its own exhaled material, surrounded by particles it has shed, cannot be seen directly, only inferred like a chrysalis, though this metaphor breaks down because comets don't emerge transformed. They simply reveal what was always inside. The cocoon is temporary, seasonal, dependent on solar distance and activity level, at great distances, cold and quiet. No cocoon exists. The nucleus sits bare in space, inert, just a dark rock, frozen ice. Then as the sun approaches, warmth builds and the cocoon forms, grows, expands, until the comet is invisible within its own atmosphere, its own creation. Consider the water ice grains, not molecules yet, but tiny crystals, solid particles, sublimating, contributing to the extended coma glow. Water ice reflects sunlight, scatters it, adds to the overall brightness, and as these grains sublimate, transitioning from solid to gas, they absorb heat, cool their surroundings, affect the thermal balance of the coma. This is evaporative cooling on a cosmic scale. The phase change, solid to gas, requires energy, latent heat, and that energy comes from sunlight, from the thermal environment. The process is self-regulating in a way. More sublimation, more cooling, less sublimation, more heating, until equilibrium is reached, until the rate of energy input matches the rate of energy absorption by sublimation. The carbon dioxide and carbon monoxide that dominate the volatile inventory. These drive much of the activity. They sublimate at lower temperatures than water. CO sublimates even far from the sun, at distances where water remains frozen. This creates a natural sequence of activation. First CO, creating early activity, then CO2, then finally water as the comet gets very close and warm. Each volatile contributes differently. CO provides velocity, escape speed, carries dust grains efficiently. CO2 contributes brightness, abundance. Water adds mass, duration. The mixture determines behavior, and 3i Atlas, like most comets, carries all three, creating a complex, layered outgassing profile that changes with distance and time. The photochemistry, the reactions driven by light, occur continuously in the coma. Molecules absorb UV photons, break apart, recombine, create new species, destroy others. The coma is not static but dynamic, a constantly changing chemical reactor. Parent molecules from the nucleus, methane, methanol, ammonia, various organic compounds, break apart within seconds or minutes of entering sunlight. Their fragments, the daughter molecules, react further, producing the species we observe: C2, Cn, O, C3, NH. Each generation of molecules, each step in the cascade, has its own lifetime, its own chemistry. The coma we see is the sum, the integralostia of all these processes happening simultaneously at different rates in different regions. A chemical symphony. each molecule playing its note, the combination creating the overall colour, the overall appearance. Let your awareness drift outward now, beyond the comet, to the space it travels through. The interstellar medium, not empty, but filled with atoms and molecules, dust grains, magnetic fields, radiation, incredibly tenuous, a few atoms per cubic centimetre on average, but present nonetheless, during its millions or billions of years wandering between stars. 3i Atlas moved through this medium, encountered it, was shaped by it. Cosmic rays, high-energy particles accelerating through interstellar space, struck the surface, penetrated, altered chemistry. This processing, this radiation damage, created the devolatilised surface layer we observed initially, the red tholin-rich crust. The interstellar medium is not kind to ices, not protective. It erodes, it processes, it ages, over eons. Exposed ice sublimates even in the cold, struck by occasional photons from distant stars, occasional impacts from atoms, slowly, so slowly, but continuously, wearing away, darkening until the surface becomes depleted, sealed, quiet. The possible enrichment from the comet's origin system. The stellar system where it formed raises fascinating questions. Different stars have different metallicities, different abundances of elements heavier than hydrogen and helium. A comet forming in a metal-rich system might have more carbon, more nitrogen, more oxygen than one forming in a metal-poor environment, and the specific conditions, temperature, pressure, radiation environment, dust composition in the protoplanetary disk, all affect what molecules form, what ices condense, what chemistry occurs. 3i Atlas carries, frozen within it, a record of those conditions, a snapshot of its birth environment. The delayed appearance of C2, the specific volatile composition inferred from observations. These are clues, hints, whispers from another stellar system, another time, another place. The organic precursors that drive emissions, complex carbon-bearing molecules, formed perhaps in the cold outer regions of the protoplanetary disk, or inherited from the molecular cloud that collapsed to form the star and planets. These organics, often called distributed carbon, represent a significant fraction of cosmic carbon, not in simple molecules like CO or CO2, not in pure graphite or diamond, but in intermediate complexity compounds, chains, rings, functional groups. This organic inventory, poorly understood even in solar system comets, even more mysterious in interstellar visitors, contributes to the red colour when processed, to the green emissions when fresh material sublimates and photodissociates. It is, in a sense, the most interesting component, the bridge between simple inorganic chemistry and the complex organic chemistry that life requires. Drift deeper now into relaxation and consider the fate of the comet after this passage, after receding from our sun, growing cold again, quiet again. It will continue on its hyperbolic trajectory back into interstellar space. Billions of years from now, it may enter another stellar system, encounter another sun, undergo another awakening, another transformation, or it may wander forever, never again feeling stellar warmth, carrying its remaining volatiles sealed beneath the processed crust, a time capsule, a memory, until perhaps, unimaginably far in the future, it collides with something, a star, a planet, another wanderer, or simply dissipates, eroded atom by the thin interstellar medium, eventually, like all things, it will end, transform into something else. But that ending lies so far ahead, so many eons distant, that it seems almost like no ending at all, just continuation, persistence, eternal drift, the lessons for future interstellar visitors, and there will be more, certainly more, inform how we plan observations, what instruments we prepare, what questions we prioritize. We've learned that early observations should use red filters, document the dust phase, while later observations need green and blue filters, spectroscopy, to catch the gas emissions. We've learned to expect layered activation, surface depletion giving way to interior richness. We've learned that color is diagnostic, meaningful, carrying information about composition and chemistry. Each interstellar comet teaches us, prepares us for the next, builds our understanding incrementally, and perhaps, decades from now, we'll detect an interstellar comet early enough, far enough out, to send a spacecraft, to intercept, to sample directly, to touch and measure and analyze, to answer questions that remote observation cannot. The dynamic activation process, this transformation from dormancy to activity to dormancy again, mirrors cycles we see throughout the universe. Stars ignite, burn, fade, galaxies form, evolve, merge, planets differentiate, geologize, cool. Nothing is truly static. All is transformation. All is change occurring at different timescales. The comet's color change, compressed into months, is unusually fast, visible to human observation, but the principle is universal. Heat brings change, brings revelation. Distance brings quiescence, brings sealing. The universe breathes, cycle, transforms, and we observing are part of that process, consciousness arising from cosmic chemistry. Observing cosmic chemistry, a strange loop, a beautiful closure. The interstellar hue drift we've discussed, this journey from red to green and eventually back toward dormancy, represents a specific trajectory through color space, wavelength space. If we could graph it, plot color versus time, we'd see a curve starting red in July, shifting orange, yellow, green, peaking in green around November-December, then fading. We could parameterize this curve, fit it with equations, predict future behavior. This is what astronomers do: quantify the qualitative, measure the beautiful, not to diminish beauty, but to understand it more deeply, to see patterns, to find universal principles. Color becomes data, data becomes understanding, understanding becomes appreciation. Feel your body now completely relaxed, heavy, sinking into softness, and imagine the eternal color stillness that awaits the comet when it's far enough from all stars, in the deep interstellar void. No light illuminates it, no colors exist, only darkness and cold, temperature approaching, but never quite reaching, absolute zero. In that stillness, that silence, time loses meaning. 1 billion years passes, feels like nothing, no sensation, no change, no markers, just existence, pure, simple, without observation, without light. Does color exist? The comet possesses the potential for color, the materials that would reflect or emit specific wavelengths if illuminated, but in darkness. The potential remains unrealized, latent, waiting. This is the comet's natural state, its default, and the brief months of colour we observed are the anomaly, the exception, the rare moment of revelation in an eternity of darkness, the reddish dust. Those first observations represented the exterior, the weathered surface, the memory of what the interstellar medium does to expose material. Over time, with patience, the green gas, the later emissions, represented the interior, the preserved pristine material, the original composition less affected by processing. In this way, the colour change was a journey from outside to inside, from aged to young, from processed to preserved. We watched, in real time, as the comet peeled itself, revealed itself, layer by layer. The red was honest, showing its age, its journey. The green was honest too, showing its youth, its origin, both true, both meaningful, telling different parts of the story. Think of the comparison to Earth's own transformations, seasons, day and night, ice ages and warm periods. Our planet too cycles through states, changes colour when observed from space, white in ice ages, blue-green normally, redder perhaps in past epochs with different atmospheric chemistry. We understand these changes, live within them, but observing a comet's transformation, compressed in time, visible in months, gives us perspective, lets us see change itself as a fundamental property, not of comets specifically, but of systems in general. Everything changes, given energy, given time, given the right conditions. Stability is temporary, equilibrium is local, change is universal. The protective layer the comet built up, or had built upon it, during interstellar transit, served its purpose. It prevented the interior from sublimating away, from being lost atom by atom to the vacuum and radiation of space. Without that protective crust, the comet might have arrived completely devolatilized, just a rocky core, no volatiles remaining, no potential for colour change. The red tholin surface, though it initially hid the green interior, ultimately preserved it, made the later revelation possible. This is a kind of cosmic irony. The same processing that depletes and darkens the surface also protects what lies beneath, seals it, saves it for eventual release. Let the rhythm of your breathing guide you deeper, each exhale releasing, each inhale receiving. Imagine breathing out red, dust, surface concerns. Breathe in green, fluorescence, deeper peace. The diatomic carbon molecules, those C2 pairs, become your breath, simple, essential, glowing when energized, resting when calm. You are the transformation, the color change, the journey from red to green, from complexity to simplicity, from tension to release. The swan bands, those specific wavelength ranges where C2 emits, are named for William Swan, a 19th century Scottish physicist who first studied these spectral features. He observed them in carbon-rich flames, in laboratory conditions, over 150 years ago, never imagining they'd be used to study objects from other stellar systems. His careful work, his patient spectroscopy, laid groundwork for discoveries across space and time. This is how science builds, each generation contributing, each observation adding to the foundation. Swan could not have conceived of interstellar comets, of Gemini North telescopes, of digital imaging, but his work enabled all of it. This continuity, this accumulation, this building of understanding across generations is humanity's long project, our slow transformation from ignorance to knowledge, from blindness to vision. The CN violet system, emitting at shorter wavelengths, adds blue tones to the overall appearance. Cyanide, toxic to life as we know it, but beautiful in emission, contributing to the blue-green palette. The specific shade of green an observer sees depends on the ratio of C2 to Cn. More C2 gives yellower green, more Cn gives bluer green, and both depend on the parent molecules, the organics in the ice, and the UV flues and the photodissociation rates, everything connected, everything affecting everything else. The coma is a system, an ecosystem without life, where components interact, balance, create emergent properties like color that arise from the combination, not from any single process alone. Feeling so peaceful now, so quiet. Let your thoughts become like the far tail of the comet, distant, dispersed, fading, the red dust persisting in that tail, drifting, spreading, becoming ever more tenuous, eventually indistinguishable from the interplanetary dust that fills our solar system. Every comet adds to this dust, contributes particles, and over millions of years, the accumulated dust from all comets creates the zodiacal light, that faint glow visible from dark sites, stretching along the ecliptic. We see it. We swim through it as Earth orbits. We are part of it. And 3i Atlas adds its contribution, a few tons of dust, a tiny fraction, but real is material from another stellar system now mixing with ours. Interstellar exchange, cosmic commerce. The observations continue, will continue, as long as the comet remains detectable. Each night it fades a little more, recedes a little farther, eventually, in 2026 perhaps, or early 2027, it will be gone, too faint even for the largest telescopes. The observations will stop, not because interest wanes, but because there's nothing left to see. The comet will still exist, still be there, but invisible, too far, too dim, and it will continue, silently, invisibly, back into the dark, carrying what we learned and what we'll never know, sealed within it, until perhaps another encounter, another sun, another awakening in another era of the galaxy. We are drifting now, deep into phase 3, into the gentle fade. Let the concepts wash over you, abstract, peaceful, no longer specific facts but feelings, sensations, veiled red awakening. Can you feel it? That initial state, hidden, potential, emerald gas emergence, rising, revealing, quiet color surrender, letting go, releasing, dust to glow shift, transformation, natural, inevitable, hidden fluorescence peace, waiting within, molecular green whisper, soft, gentle, barely there, Tholen veil dissolution, fading, disappearing, revealing light beneath, diatomic calm radiance, simple, pure, two becoming one, layered hue serenity, levels of colour, levels of consciousness, organic red fade, the exterior releasing, celestial jade breath, inhale green, exhale peace, buried carbon bloom, deep within, emerging slowly, solar-induced verdant hush, warmth bringing quiet transformation, coma palette evolution, changing, flowing, one colour to another, pristine glow integration, everything combining, everything whole, red dust memory, remembering where you've been, green emission harmony, arriving where you're going, chemical depth reveal, layers opening, showing what was hidden, interstellar hue drift, wandering through color space through consciousness, eternal color stillness, approaching, nearing, the final quiet, breathe, just breathe, veiled red awakening in the distance, emerald gas emergence rising, quiet color surrender washing over, dust to glow shift completing, hidden fluorescence peace settling in, molecular green whisper fading, Tholin veil dissolution almost complete, diatomic calm radiance all around, layered hue serenity, organic red fade, celestial jade breath, buried carbon bloom, solar-induced verdant hush, coma palette evolution, pristine glow integration, red dust memory, green emission harmony, chemical depth reveal, interstellar hue drift, eternal color stillness, so close now, so near. Everything quiet, everything still, veiled red, emerald, quiet, dust, glow, hidden, molecular, Tholin, diatomic, layered, organic, celestial, buried, solar, coma, pristine, red, green, chemical, interstellar, eternal, color, stillness, peace, transformation, complete, returning, beginning, ready to drift, far, far out, again and again to explore. This is your weekly dose of 3i Atlas featuring 3i Atlas. This is your weekly dose of 3i Atlas featuring Cryovolcanism, brought to you by the Sleepy Science 100 channel. Tonight we drift into the quiet cosmos, following an interstellar visitor whose activity is not fiery or violent, but soft, cold, and beautifully restrained. Now, let us settle in. Tonight we will glide through the surprising signs of cryovolcanic eruptions on a traveler from another star. Quiet releases of frozen volatiles, driven by unusual, metal-rich chemistry. Ice awakening, not in flame, but in gentle, cosmic breaths, painting the coma with subtle motion and structure. Let us begin by imagining a visitor from beyond our solar system, arriving slowly, silently, into our corner of the galaxy. This traveler has journeyed for millions upon millions of years, through darkness, through cold, carrying within it frozen memories of a stellar nursery we will never see. Recent observations of this wanderer, known as 3 Atlas, reveal something extraordinary, yet delicate, something that speaks in whispers of ice and metal rather than fire and heat. High-resolution images captured by the Jonaro telescope show faint spiral patterns, slender jets of gas and dust, emerging from the surface, like breath, like a quiet sigh released into space. These are not ordinary jets. They are interpreted as evidence of cryovolcanic plumes, eruptions not of molten rock, but of icy materials, pristine volatiles awakening after eons of stillness, responding gently to sunlight, releasing pressure built over cosmic time. As we continue drifting through these quiet eruptions, watching frozen worlds exhale. If these slow journeys through sleep and space feel soothing or meaningful, you're warmly invited to subscribe. Liking the video helps us know these calm explorations are reaching you, and if you're still awake before you fully drift off, Feel free to leave a single word in the comments describing how you hope to feel in the morning. Rested, calm, clear. Thank you for joining us tonight as we drift far, far out, exploring the silent beauty of cryovolcanism on 3i Atlas. Cryovolcanism. The word itself feels cold, volcanic, yet gentle. It describes eruptions where water or ammonia or carbon dioxide takes the place of lava. Instead of fire, there is ice. Instead of heat measured in thousands of degrees, there is the quiet chemistry of freezing and thawing, of pressure and release. On this distant traveller, something ancient is stirring. The surface of 3i Atlas lacks something that most comets from our own solar system possess. It has no protective dust mantle, no accumulated crust from repeated passes near the sun. This absence, this nakedness, allows something remarkable. The entire surface can activate, can breathe, can erupt, all at once, globally. There is no shield to suppress the buried ices beneath. Imagine the surface as an open invitation to solar warmth. Without a mantle, without that protective barrier, the sunlight reaches directly down into the subsurface layers, awakening volatiles that have slept undisturbed for billions of years. This global activation creates sustained eruptions, not just brief outbursts, but continuous, gentle releases of material. The pristine nature of this object preserves volatiles from its distant stellar nursery, the place where it formed, orbiting another star in another system long ago. And now, as it passes through our sun's warmth, for perhaps the first time in millions of years, those ancient ices begin to remember what heat feels like. The spectral data, the fingerprints of light, tell us something unusual. When scientists compare the reflected light from 3i Atlas to samples we have here on Earth, they find it matches carbonaceous chondrites. These are primitive meteorites, metal-rich, dark, ancient beyond measure, from the earliest days of our own solar system. If this interstellar visitor resembles these meteorites, then it is likely enriched in native metals, nickel, iron, embedded throughout, like grains of memory, scattered through ice. And here is where the hidden volcanic whispers begin. Metal grains, tiny fragments of nickel and iron, react with the sublimating ices around them. As the ices turn from solid to gas as they wake, they touch the metals, corrode them, oxidize them. This reaction, this slow corrosion, releases energy, releases gases. It sustains the cryovolcanic activity, not through heat alone, but through chemical processes, through catalytic dances that fuel ongoing eruptions. The metal-fueled silent eruptions continue, not because the sun alone warms the surface, but because deep within, chemistry is happening. Fischer-Tropsch-like reactions, where metals act as catalysts, generating additional heat, additional gases. The interior becomes a quiet factory of volatile production. Let us drift deeper into the coma, the cloud of gas and dust surrounding this traveller. The coma is unusually rich in carbon dioxide. CO2 dominates. In fact, the ratio of carbon dioxide to water is exceptionally high, around 8:1. For every molecule of water vapor, there are 8 molecules of carbon dioxide. This is strange. This is not what we typically see. Most comets from our own neighborhood exhale water as their primary breath, but this visitor breathes differently. Small amounts of water vapor, yes, but also carbon monoxide, CO, and even carbonyl sulfide, OCS. These trace whispers add complexity to the chemical signature. The outgassing, the exhalation, is dominated by carbon dioxide and carbon monoxide rather than water. This tells us about the formation conditions, about the temperature and chemistry of the protoplanetary disk. Where this comet was born, it speaks of processed materials, or perhaps a unique formation environment, colder or richer in carbon-bearing ices. The activity began early, remarkably early, even at distances beyond 4 astronomical units from the Sun. Beyond where Mars orbits, the brightness began to increase. This early awakening indicates that near-surface volatiles, highly volatile substances, were activating. There was no typical water ice sublimation dominant at these greater distances. Instead, the carbon dioxide, which sublimates at lower temperatures, led the way. Cryovolcanism explains this sustained brightness, without fragmentation, without the object breaking apart. Internal pressure builds as sublimating ices, deep within, turn to gas. The pressure seeks escape, finds weaknesses, vents, cracks, channels, and erupts through them, gently. The jets appear structured, spiral in form, suggesting multiple eruption points, active regions, scattered across the surface, breathing in coordination, or perhaps in rotation, as the comet spins. Each jet, a thread of another star's past, reaching outward. Post-perihelion images, taken in November 2025, after the comet passed closest to our Sun, show ongoing jet activity. The eruptions did not stop, they continue. The Hubble Space Telescope, the Gemini Observatory, captured the evolving coma morphology, watching as the cloud of material expanded, shifted. Near perihelion, the coma expansion reached thousands of kilometers, a vast sphere of dust and gas surrounding the small, dark nucleus. The nucleus itself, perhaps only a few kilometers across, yet generating such extensive activity. As we settle deeper into this journey, let us consider the pristine memory drift. The comet's interior preserves volatiles, untouched, for billions of years. In interstellar space, cosmic rays, high-energy particles streaming through the galaxy may have processed the outer layers over eons, altering them slightly, but deep within, the original ices remain, fossils of another system. The internal chemistry drives eruptions, independent of surface sublimation alone. It is not just the Sun acting from outside, but reactions happening within a hidden source of energy and gas. X-ray emissions have been detected, faint but present. This suggests interaction with the solar wind, the stream of charged particles flowing outward from our sun. As these particles collide with the expanding gases in the coma, they excite atoms, causing them to emit soft X-rays, a glow invisible to our eyes, but revealing the violence, however gentle, of this cosmic encounter. The non-gravitational acceleration, the way the comet's trajectory changes slightly, more than gravity alone would predict, is influenced by these asymmetric jets. The eruptions push back, creating a recoil that nudges the comet's path. These trajectory perturbations are compatible with cryovolcanic forces. Coma dust grains, tiny particles, are ejected by the pressurized gas releases. The volatiles, as they burst forth, carry dust with them, entraining particles, lifting them away from the surface. These grains, driven by carbon dioxide and carbon monoxide outgassing, travel far. The volatile inventory has been retained over galactic travel timescales. Think of it. This object has wandered between the stars for perhaps 5 million years or more since leaving its home system. Yet it still holds its frozen breath, its chemical treasures, ready to release them when warmth finally arrives. The high carbon dioxide abundance indicates something processed or unique in its formation. Perhaps the disk where it formed was especially rich in carbon, or perhaps chemical reactions. Early in its history, converted water into carbon dioxide through interactions with carbon-rich materials. Water ice grains ejected into the coma sublimate remotely, not on the surface, but 4,000 to 10,000 kilometers away, out in the cloud. This tells us that solid grains of water ice are being launched intact from the surface, and only later, as they drift, do they turn to vapor. Interestingly, no iron vapor was detected initially and in the early spectra. This is unusual for comets. Typically, we see both iron and nickel if metals are present, but here nickel emission appeared without corresponding iron. At first, scientists have hypothesized that organometallic compounds like nickel tetracarbonyl may be responsible. This compound, nickel bonded with 4 carbon monoxide molecules, can form at relatively low temperatures and releases nickel vapor when it breaks apart. As the comet heats and progresses, the imbalance normalizes. Iron begins to appear as deeper, hotter layers are exposed. The detection of cyanide radicals, CN, confirms typical cometary volatiles are present. These molecular fragments glow in the coma, excited by sunlight. Diatomic carbon, C2, also contributes to a faint greenish glow in the coma. This green tint, subtle, is a signature of carbon-rich comets. The low albedo, the darkness of the surface, results from dark, light-absorbing materials. perhaps carbon, perhaps organic compounds, created through irradiation over the ages. Without a protective mantle, direct solar heating reaches the subsurface continuously. The global eruption across the entire surface layer has been observed. This is different from the acute outbursts we see in local comets, where a single active region suddenly releases material. This sustained activity is more akin to processes on trans-Neptunian objects, distant icy bodies beyond Neptune, that also experience cryovolcanism. The similarity to these TNOs suggests that 3 Atlas formed in the outer disk of its origin system, far from its star, where ices could accumulate, pristine and cold. These pristine ices, untouched for billions of years in the void between stars, now release their ancient contents. Let us pause and breathe with the comet, feel the mantleless openness, the way the surface invites solar energy inward. There is no resistance, only quiet acceptance. The buried ices stir. Chemical reactions between metals and ices fuel the ongoing activity. The brightness, sustained over months, without sudden explosion, without breakup, speaks to internal reserves of volatiles and energy. Comparison has been made to Pluto's cryovolcanoes, Wright Mons, Picard Mons, those massive ice mountains suspected of volcanic origins, or to Enceladus, Saturn's small moon, where plumes of water vapor and ice grains erupt from cracks near the South Pole. Here, on this tiny interstellar body, the same principles may apply. Metal corrosion releases gases, sustaining the eruptions. The primitive composition preserves ancient stellar material from the disk around another star. The spectral reflectance, when compared to samples, matches Antarctic carbonaceous chondrites, the darkest, most primitive meteorites we possess. Aqueous processes, the presence of liquid water, even temporarily, are indicated. This suggests that at some point, perhaps during formation or perhaps during brief warming events, liquid water existed within this comet, altering minerals, corroding metals. The energy from metal oxidation powers the ice volcanism. It is a battery, slowly discharging as metals give electrons into oxygens in water or carbon dioxide. The jets, in some observations, appear oriented toward the sun. This makes sense. The warmest regions face the incoming sunlight, and those regions erupt more vigorously. An anti-tail, dust pushed sunward by radiation pressure, may also be possible, creating the illusion of material moving against the flow. There are hints in the data of heartbeat-like pulses in the brightness. These suggest rotational modulation. As the comet spins, active regions come into view, then rotate away, causing the brightness to wax and wane in rhythm. The non-uniform outgassing from these active regions creates the structure we see in the coma. This cryovolcanism broadens the diversity of known cometary behaviors. It has implications for understanding geological activity in extrasolar small bodies, worlds orbiting other stars that we cannot yet see directly. The lack of a protective mantle is due to the fact that this comet has never made repeated passes near a star. It formed, orbited quietly in the outer reaches of its home system, then was ejected gravitationally into interstellar space. This is its first close stellar encounter in millions, perhaps tens of millions of years. The activation of deep deposits during perihelion warming brings ancient material to the surface. Carbon dioxide dry ice, sublimation, initiates pressure buildup beneath the surface. The gas has nowhere to go except up. It finds vents and cracks and channels the eruptive material upward, outward. Dust entrainment in these gaseous plumes forms the visible jets we observe. The coma chemistry evolves as deeper layers are exposed. Each day, as more ice sublimates, fresh material from further within is revealed. There is even potential for prebiotic molecule formation in these reactions. Amino acids, sugars, the building blocks of life, might form where metals catalyze organic synthesis from simple carbon and nitrogen compounds. The metal-driven pathways differ significantly from water-dominated comets. In a typical comet, water ice is the main actor. But here, carbon dioxide and metal chemistry take center stage. The sustained jets challenge pure sublimation models where ice simply turns to gas from solar heating. Instead, a hybrid model, internal and external heating combined, is proposed. Observations from multiple telescopes confirm the jets. Multiple independent teams have seen them. This is not an artifact, not a mistake, but a real phenomenon. Preprint studies, papers submitted but not yet peer-reviewed, invoke cryovolcanism to explain the morphology, the shape and structure of the coma. Global activation across the pristine surface seems possible. The energy release from chemical alteration, from the corrosion of nickel and iron sulfides reacting with oxidizing liquids, sustains the activity for weeks, months. The Fischer-Tropsch catalysis, where carbon monoxide and hydrogen react on metal surfaces, generates additional volatiles, hydrocarbons, and alcohols that then sublime away. Unusual polarization signatures in the light scattered by dust in the cryovolcanic plumes hint at the composition and structure of the dust grains. The coma morphology shows a teardrop shape or irregular form depending on the viewing angle and the activity level. Post-perihelion contraction of the coma as activity begins to wane is now being documented. Ongoing monitoring by observatories worldwide tracks the eruption decline as the comet recedes from the sun, moving back toward the cold and the dark. This is a test case for extreme comet physics, interstellar weathering, the bombardment by cosmic rays and interstellar dust over millions of years influences surface reactivity. Perhaps the outer layer is more chemically active, more ready to react than freshly excavated material would be. This pristine TNO analog, a body resembling the distant icy worlds of our own outer solar system, is experiencing its first heating in an immeasurable span of time. The data we gather informs our models of extrasolar planetesimal interiors, the insides of small worlds orbiting distant stars. The metal enrichment came from the protoplanetary disk where this comet formed. Perhaps that disk was richer in metals than our own. Or perhaps the comet formed in a region where metals condensed more readily. Volatile retention over billions of years is remarkable. Think of the cold, the emptiness of interstellar space, temperatures hovering just a few degrees above absolute zero. At such temperatures, even the most volatile substances, nitrogen, carbon monoxide, remain frozen, solid. The eruptions expose unaltered deep material, giving us a window into the original composition of another star system's building blocks. The chemical products, unique to metal-ice interactions, include not just gases, but possibly complex organics, tholins, reddish-brown materials formed by irradiation. There are implications here for panspermia, the idea that life or its precursors might spread between star systems. If organic molecule can survive and even form on interstellar comets, then perhaps these travelers carry the seeds of life from star to star. Cryovolcanism is not unique to solar system moons. We see it on Europa, on Enceladus, on Triton, and now we see evidence on an interstellar wanderer. Small bodies in other systems retain the potential for activity even after being cast out into the void. And 3i Atlas reveals the diversity of interstellar comets. Each visitor from beyond brings unique chemistry, unique history, a story written in ice and stone and metal. As we drift now into the deeper current of this exploration, let us feel the quiet awakening of buried ices within ourselves, the gentle bursts from ancient frozen depths mirror the slow release of the day's tension. The metal-fueled silent eruptions are like thoughts, oxidizing, dissolving into stillness. Your breath slows, matching the pace of sublimation. Carbon dioxide molecules, one by one, leaving the surface, drifting into the coma. The subsurface pressure's soft release is your own, letting go of what you do not need to hold anymore. The cryovolcanic heartbeat in the void pulses in rhythm with your own, slower now, gentler. The primordial volatiles stirring to life are memories, surfacing, then fading harmlessly away. Ice volcanoes painting faint jets against the darkness like neural patterns, dimming as sleep approaches. The chemical reactions igniting cold fire require no effort from you. They happen on their own, as natural as the tides. The mantleless surface, allowing global breath, reminds you of openness, of vulnerability that is also strength. Deep cavities, exhaling eons-old gas, are like lungs, releasing carbon dioxide, welcoming oxygen in a cycle. Automatic and ancient, the metal grains, corroding in fleeting warmth, teach us that transformation is inevitable and gentle. The catalytic dances, driving quiet plumes, are beyond our control, and that is a comfort. Eruptions, as memories of distant formation, hold no weight. They are simply information drifting outward. Volatile treasures, surfacing calmly, are insights rising, acknowledged, then released. Subsurface rivers of gas, emerging into space, flow without resistance. The ancient interior, revealing its secrets, does so in its own time, at its own pace. As you will, reveal your rest when ready. Ice vents, channeling stellar history, are like breath, carrying the day away from you into the vast, forgiving night. The sustained glow from hidden activity is the faint light of consciousness, remaining just enough to know you're drifting, but not enough to disturb the descent. Corrosion-powered cosmic fountains, gentle, tireless, continue without your attention. Jets as threads of another star's past weave a web that cradles you. The quiet violence of pristine activation is a paradox, intense yet soft, transformative yet peaceful. The Metal Ice Symphony plays in slow motion, notes separated by silence, by space, by the infinite patience of cosmological time. And now, as we continue to drift deeper into the mechanism, the hidden choreography of these ice volcanoes, we find ourselves exploring the relationship between interior architecture and external expression. Consider how the absence of a dust mantle changes everything. Most comets from our own solar system build up a crust over repeated passages near the sun. This crust acts as an insulator, trapping heat, trapping gas, allowing pressure to build until it ruptures, causing sudden, violent outbursts. But this interstellar traveler, arriving pristine, has no such armor, no such accumulated history of thermal stress. Its surface remains responsive, immediate. Each photon of sunlight penetrates, stirs the subsurface, without delay, without buffering. Imagine the surface as a living skin, porous, breathing, every square meter, capable of participating in the global exhalation. This is what allows this sustained, diffuse activity, rather than localized, explosive events. The spiral jets, captured in those high-resolution images, suggest something about the nucleus shape and rotation. Perhaps the nucleus is elongated or irregular, with specific regions more enriched in volatiles or metals. As it spins, these regions come into and out of sunlight, creating the spiral pattern in the expanding through the garden of space. The rhythm, the periodicity, speaks of rotation, of day and night, on a world so small that walking across it might take only an hour. Yet within this tiny realm, such complexity unfolds. Aqueous alteration, the evidence of liquid water's touch, tells a story of warmth, however brief, in the comet's past. When minerals come into contact with liquid water, they change. Iron sulfides, like troilite, oxidize, rust, releasing hydrogen sulfide gas, perhaps even hydrogen, which then escapes. The nickel-iron alloys also corrode, transferring electrons to dissolved ions. This electrochemical process generates heat, modest amounts, but in the cold vacuum of space, every joule matters. The water itself may have existed as thin films, coating grain boundaries, or as small pockets of brine, too salty to freeze, even at very low temperatures. These aqueous processes occurred perhaps during the comet's formation, when radioactive decay of short-lived isotopes, like aluminum-26, warmed the interior, or perhaps during a previous stellar encounter long ago, before ejection into interstellar space. The evidence remains written in the mineralogy, in the altered compounds that now sublime, releasing their chemical memories into the coma. The Fischer-Tropsch-like reactions, named after the industrial process, convert carbon monoxide and hydrogen on metal surfaces into hydrocarbons. This requires a catalyst. Iron or nickel works well, and it requires pressure, and it requires temperature, not extreme heat, but warmth enough to overcome activation barriers. In the interior of 3I Atlas, these conditions may be met. Carbon monoxide ice, sublimating in the subsurface, encountering metal grains, hot enough from corrosion or solar heating conducted inward, might react, producing methane, ethane, perhaps even more complex molecules. These newly formed hydrocarbons are themselves volatile. They add to the gas production, sustaining the pressure that drives the cryovolcanic plumes. It is a feedback loop. Chemical reactions produce heat and gas, which allows more sublimation, which exposes more metal surfaces, which catalyze more reactions. The organometallic compounds, such as nickel tetracarbonyl, add another layer to this chemical symphony. Nickel tetracarbonyl forms when nickel metal reacts with carbon monoxide gas at relatively low temperatures, perhaps around 150 to 200 Kelvin. It is a volatile compound, a liquid at room temperature, but in the cold subsurface, it might exist as a solid or gas. When it decomposes, either from heat or from ultraviolet light, it releases nickel atoms, which then appear in the spectral observations as glowing emission lines. This explains the early detection of nickel without iron. The iron requires higher temperatures or is to vaporize directly from metal grains. As we contemplate this chemistry, this interplay of elements, we can let our own internal chemistry settle. Your neurons firing throughout the day, now slow their tempo. Neurotransmitters rebalance. Adenosine, that gentle sleep pressure, accumulates, binding to receptors, quieting the arousal systems of your brainstem. The metal-driven serenity of the comet's interior mirrors the biochemical serenity, settling over your nervous system. The pristine buried breath of volatiles is like the deep breath you take now, filling your lungs, then releasing, slowly, completely. The cryovolcanic calm spreads through the comet's coma and through your awareness. Ancient pressure, built over millions of years, now surrenders to the inevitability of release, just as the gas escapes. Through vents, your thoughts escape. Through the open spaces of near sleep, the silent jet harmony plays on without effort, without will, simply because conditions allow it. Your rest, too, will come, simply because conditions are right. The chemical depth piece of reactions occurring in darkness, far from any observer, reminds us that transformation happens, even when unseen, even when we sleep. Let us drift now toward the observational journey, the human side of this discovery. Astronomers around the world pointed their instruments skyward, coordinating observations across wavelengths, across continents. The Joan Auroux telescope, named for a biochemist who studied the origins of life, seems fittingly named for observing an object that might carry prebiotic chemistry from another star system. The high-resolution images required long exposures or precise tracking, compensating for Earth's rotation and atmospheric turbulence. Each photon traveling across light years, then across our solar system, finally striking a detector and carries information encoded in its wavelength, its polarization, its arrival time. The Hubble Space Telescope, orbiting above our atmosphere, captured images free from atmospheric distortion. Its cameras, sensitive to ultraviolet wavelengths, revealed gases invisible to ground telescopes. The Gemini Observatory, with its adaptive optics, correcting atmospheric blur in real time, produced sharp views of the coma's structure. Multiple exposures, separated by days or weeks, showed evolution, jets strengthening or fading, the coma expanding, then contracting slightly. Each observation a snapshot in an ongoing story. Spectroscopy, the breaking of light into its component colors, revealed the coma's composition. Each element, each molecule, absorbs or emits light at characteristic wavelengths. Sodium glows yellow, cyanide radicals emit violet, diatomic carbon contributes green. By measuring these fingerprints, astronomers inventory the chemical species present in the coma. The intensities tell us abundances, how much of each gas is present, the ratios, carbon dioxide to water or carbon monoxide to water, constrain models of formation and evolution. The absence of certain species is also informative. The lack of abundant water vapor at large distances the missing ion emission early on. These absences pose questions, drive hypotheses. The detection of X-rays required specialized instruments, satellites, carrying detectors sensitive to high-energy photons. These X-rays are so energetic, penetrate matter easily, but are absorbed by Earth's atmosphere. Only from space can we see them. The emission mechanism involves charge exchange, solar wind ions, highly charged, encountering neutral atoms in the coma, steal electrons, dropping to lower energy states, releasing X-rays in the process. The polarization measurements examined how light scatters off dust grains. Light waves oscillate in planes. When they scatter off particles of certain sizes and shapes, the oscillation becomes preferentially aligned, polarized. By measuring this polarization at different angles and wavelengths, we infer the size distribution, the composition, the shape of the dust particles. The unusual polarization suggests grains different from typical solar system comets, perhaps more irregularly shaped or composed of materials with different refractive properties. As we absorb these observational details, these technical achievements, we can appreciate the patience required. Observing runs scheduled months in advance can be disrupted by weather, by equipment failures, by the comet itself. Moving into unfavorable positions, astronomers write proposals, arguing for telescope time, competing with hundreds of other projects. When awarded, they prepare meticulously, calculating coordinates, exposure times, filter selections. Then they wait for their assigned nights, hoping for clear skies. This patience, this careful preparation, followed by surrender to conditions beyond control, resonates with the journey into sleep. You prepare, create conditions, dim lights, quiet sounds, comfortable position. Then you must surrender, release control, allow sleep to come in its own time. The mantle-less openness of the comet, accepting sunlight without resistance, reflects the openness required of you to accept rest. The primordial eruption flow happens not through force, but through yielding to pressure that has built naturally. The corrosion's soft energy teaches us that even destructive processes can be gentle, slow, metal. Giving up electrons, dissolving slightly, is not violence but transformation, participating in a larger cycle, the catalytic quiet pulse of reactions, mediated by metal surfaces, shows us that presence can be enough. The catalyst is not consumed, merely facilitates, enables. Your awareness now becomes catalytic, present, but not interfering, allowing the reaction of waking into sleep to proceed. Let us turn our attention to the broader implications of this interstellar chemistry. If 3I Atlas, with its metal-enriched composition, represents a common type of small body from other star systems, then the galaxy may be filled with similar objects traveling silently through the dark, each expelled from its birth system through gravitational interactions with planets or stellar companions. They wander for millions of years, dozens of light years from their home, before chance brings them into another system. The frequency of such visits is uncertain until the first interstellar object, Oumuamua, was discovered in 2017. We could only speculate now. With improved surveys, more sensitive detectors, we detect these visitors more regularly. 3I Atlas, discovered in 2025, follows 2I Borisov, discovered in 2019. Each interstellar comet offers a sample of another system's inventory, a messenger from the galactic neighborhood. The diversity, already apparent, suggests that planetary systems form with varied compositions, metal-rich, like 3I Atlas, or more typical, water-rich, like 2I Borisov. This diversity has implications for planet formation theories. If protoplanetary disks vary widely in their metal content or their volatile inventory, then the planets that form and the small bodies that remain will also vary. The composition affects everything: thermal evolution, differentiation, the potential for geological activity, even the potential for hosting life. A metal-rich comet with catalytic surfaces might produce more complex organic molecules than a metal-poor one. These organics, if delivered to a planet's surface, could contribute to prebiotic chemistry. The implications for panspermia, the hypothesis that life spreads between worlds or even between star systems, become more intriguing. If interstellar comets arrive regularly, and if they carry organic molecules or even more complex structures, could they seed sterile worlds with the building blocks or even templates for life? The survival of complex molecules through the journey is questionable. Cosmic rays degrade organics over millions of years, but deep within a comet's interior, shielded by meters of ice and rock, perhaps some materials could survive. The idea remains speculative, yet these interstellar visitors compel us to consider connections between star systems beyond gravity and light. Imagine a network of exchange, material, drifting through the galaxy over deep time. Star systems, not isolated, but connected through wandering comets. The global surface sigh of 3I Atlas, releasing its contents into our solar system, becomes a gift of information, of matter from another corner of the galactic disk. As we drift through these cosmic implications, we can feel our own sense of connection. The atoms in your body were forged in stars that exploded billions of years ago. You are quite literally stardust. The oxygen you breathe, the carbon in your cells, the iron in your blood, all created in stellar cores or supernova explosions. Now, here, contemplating a comet from another star, you close a circle, matter, awareness, observing its own origins, the volatile memory drift, of ancient ices sublimating away parallels the drift of your thoughts into the formless. Memories from the day surface briefly, then disperse like gas molecules into the vastness. The interior cosmic exhale of the comet, releasing what it has held for eons, invites you to exhale what you no longer need: worries, tensions, the day's accumulations. Let them drift outward into the night. The ice vent stillness, the quietness at the mouth of each vent before the next pulse, is the stillness between your breaths, growing longer, deeper. Now we explore the connections to other worlds where cryovolcanism occurs within our own solar system. Pluto, that distant dwarf planet visited by New Horizons in 2015, revealed a young surface in places, smooth plains of nitrogen ice, suggesting recent or even ongoing geological activity. Features like Wright Mons and Picard Mons are massive mountains, several kilometers high, with depressions at their summits, possibly calderas from collapsed cryovolcanoes. The mechanism might involve subsurface oceans of water and ammonia, heated by radioactive decay, achieving enough pressure to force plumes through the thick ice crust above. Europa, the icy moon of Jupiter, shows surface features that hint at subsurface activity, chaotic terrain where the surface is broken and refrozen, suggests warm ice from below has intruded upward. There may be active cryovolcanism, though we have not yet directly observed eruptions. Enceladus, Saturn's small moon, provides perhaps the most dramatic example. Geysers erupting from cracks near the South Pole, spray water ice particles and vapor hundreds of kilometers into space. The Cassini spacecraft flew through these plumes, sampling their composition, finding not just waters but salts, silicates, and even simple organic compounds. These plumes on Enceladus confirmed a subsurface ocean, a global sea beneath 10 to 20 kilometers of ice. Tidal heating from Saturn's gravity keeps this ocean liquid. The cryovolcanic vents at the South Pole connect directly to this ocean, meaning samples of ocean water are accessible without drilling. Triton, Neptune's largest moon, also shows evidence of past, or perhaps intermittent, cryovolcanism. Voyager 2 in 1989 captured images of geyser-like plumes, dark material, rising 8 kilometers high, possibly nitrogen gas and dust erupting from the surface. The comparison of 3I Atlas to these solar system examples highlights both similarities and differences. The sustained plume activity resembles Enceladus, though at a smaller scale. The metal-driven chemistry differs from the ocean-connected vents of icy moons. The pristine surface, without repeated thermal processing, resembles a trans-Neptunian object like Pluto, experiencing its first major heating, the role of carbon dioxide rather than water or nitrogen as the primary volatile adds uniqueness to this interstellar case. Understanding cryovolcanism across this range of bodies informs our search for habitable environments, subsurface oceans kept liquid by tidal heating or radioactive decay or chemical reactions might exist on moons throughout our solar system and around other stars. These oceans, isolated from surface radiation, shielded by ice, could potentially harbour life. The vents, where ocean water meets the surface or erupts into space, are interfaces of particular interest, mixing chemistry from the deep with energy and materials from above. The sustained hidden glow of cryovolcanic activity suggests enduring energy sources not dependent on sunlight. This expands the habitable zone, the region around a star where liquid water could exist, to include locations far from the star where internal heat matters more than stellar radiation. Moons orbiting giant planets in the outer regions of their systems might be warm inside while frozen outside. This insight multiplies the potential sites for life in the galaxy. The tidal flexing of moons like Enceladus or Europa, the rhythmic kneading and by a parent planet's gravity, creates friction deep within the rocky core, generating heat that sustains subsurface oceans for eons. This is a quiet warmth, a subterranean fire, shielded from the vacuum of space by miles of protective ice. It suggests that life need not bask in the light of a yellow sun to thrive. It can exist in the pressurized dark, fueled by the slow, radioactive decay of isotopes or the grinding stress of orbital mechanics. As we absorb these possibilities, these hints of hidden vitality, we can feel our own hidden vitality. The process is just continuing within us, even as we rest. Your heart beats without thought, pumping blood through 60,000 miles of vessels. Cells metabolize, repairing, building, cleaning. Your immune system patrols. Your gut microbiome digests, synthesizes vitamins. All this happens in the dark, the interior of your body, requiring no conscious effort. The reaction's eternal hush of biochemistry proceeds in silence, enabling your existence. While you drift toward deeper sleep, the glymphatic system opens its channels, a nocturnal tide washing through the brain, clearing metabolic debris. The waste of wakefulness is swept away. Your neurons, like distant stars, pulse in low-frequency waves, delta, theta, the deep frequencies of repair. Each breath is a transaction, oxygen for carbon, a steady exchange with the atmosphere that sustains the slow burn of your cellular furnace. The deep void integration of the Comet, journeying alone through interstellar space, reflects our own capacity for solitude, for rest. In sleep, you are alone with yourself, disconnected from external demands. This is not loneliness, but integration. The Comet integrated its journey, its cold, its silence into its structure, preserving its integrity over billions of years through the vast, empty reaches between the spiral arms of the Milky Way. You integrate the day's experiences in sleep, processing, consolidating memories, balancing neurochemistry. The void is not empty, but full of quiet work. It is the space where the self is rebuilt, where the fragments of the day are woven into the tapestry of your history. In the stillness, you are not stagnant, you are becoming. Let us now consider the metal chemistry in greater detail, allowing the technical aspects to become almost musical, rhythmic recitation of elements and reactions. Nickel, atomic number 28, in the periodic table, sits between iron and cobalt. It has a moderate reactivity, forming compounds with oxygen, sulfur, carbon monoxide. Its electron configuration, Ar 3d28 4s2, allows for complex bonding, inviting molecule to cling to its surface. Iron, atomic number 26, more abundant and slightly more reactive, rusts easily in the presence of oxygen and water, but in the deep cold, it remains pure, a native grain. Both metal can act as catalysts, lowering the activation energy for reactions that would otherwise proceed too slowly to matter. They are the silent facilitators of change, the anchors for molecular transformation. The native metals in the comet exist because the environment of their formation was reducing, lacking free oxygen. In a protoplanetary disk, the inner region are too hot for metals to condense as solids. They remain vapor, swirling in the solar wind. But farther out, beyond the snow line, where temperatures drop below the freezing point of water, 150 Kelvin, 100 Kelvin, and even farther, where carbon monoxide and nitrogen freeze, metals can condense as grains, microscopic flakes of cosmic dust. They mix with ice, becoming incorporated into planetesimals, the building blocks of planets and comets. These grains are time capsules, preserving the chemical state of the early nebula before the stars had cleared the air. These metal grains, once embedded in ice, remain inert until warmth arrives. As the comet approaches a star, solar radiation penetrates the surface, warms the interior. Ice begins to sublime, first the most volatile, nitrogen, carbon monoxide, carbon dioxide, then water. As the ice disappears or becomes porous, metal grains are exposed to gases and perhaps to thin films of liquid water, mere molecules thick. Now, oxidation begins. Nickel reacts with water or carbon dioxide, releasing hydrogen or carbon monoxide. Iron does the same. The energy released is modest, exergonic, but sustained over days and weeks. It accumulates, raising the temperature of the surrounding ice, a feedback loop of gentle warmth. The nickel tetracarbonyl pathway offers an alternative. At temperatures around 150 Kelvin, nickel metal, exposed to carbon monoxide gas, can form this organometallic compound, NiCO, 4. Nickel tetracarbonyl is volatile, a colorless liquid that evaporates at low temperatures. It migrates through porous ice toward the surface or toward warmer regions. When it decomposes from heat or light, it deposits pure nickel in finer form as a dust and releases carbon monoxide back into the gas phase. This cycling of carbon monoxide on and off metal surfaces might enhance the efficiency of gas production, creating the subtle jets that push the comet along its path. Iron does not form a stable carbonyl under the same conditions. It requires higher temperatures or higher pressures. This explained the initial absence of iron emission in the spectra. Only nickel could be mobilized, at first, by the low-temperature chemistry. As the comet warmed further, approaching perihelion, iron vapor began to appear from direct sublimation or from the breakdown of iron-bearing minerals like olivine or pyroxene, heated to their breakdown temperatures. The coma chemistry therefore evolves as a temperature profile moves inward through the nucleus, revealing successive layers of composition, a chemical history read in light. The sulfides. Another important component include troilite, iron sulfide, Ves, a common mineral in primitive meteorites. When troilite oxidizes in the presence of water or oxygen, it produces iron oxides and hydrogen sulfide gas, H2S. This gas has a distinct smell to humans, like rotten eggs, though in space there is no medium to carry scent. The hydrogen sulfide might further react with other compounds or photolyze in sunlight, breaking into sulfur and hydrogen. The sulfur could contribute to the yellowish or brownish colors observed in some comets, the dust tails tinted by the chemistry of ancient volcanoes. The hydrogen, lightest element, escapes easily into space, the invisible halo surrounding the comet. These chemical details may seem intricate, complex, but allow them to wash over you, not as problems to solve, but as rhythms to sink into. Nickel, iron, sulfur, oxygen, carbon, each element playing its part in a slow, ancient dance. The metal ice symphony, in slow motion, plays on, notes separated by vast spaces, yet harmonious. The atoms in your own body were forged in the same stellar furnaces as these comet grains. The iron in your blood, the nickel in the comet's core are cousins, born of the same cosmic origin. Your breath slows further, notes separated by pauses, yet rhythmic. The catalytic quiet pulse of your heartbeat, steady, dependable, requires no thought. We return now to the journey itself, the trajectory through our solar system. 3K saw Atlas entered from the direction of the constellation Perseus. It was a traveller from the deep. Its velocity, relative to the Sun, was high, over 40 kilometers per second. This hyperbolic speed proved its interstellar origin. No object bound to the solar system moves so fast at such great distances. It approached from above, the plane of the planets descending at a steep angle toward perihelion. The perihelion, closest approach to the Sun, occurred in January 2025 at a distance of about 0.77 astronomical units inside Earth's orbit, but outside Venus. It was a brief, intense encounter with the center of our world. At that distance, solar heating intensified, the flux of sunlight increased, surface temperatures rose, sublimation accelerated, the coma brightened, expanding to its maximum extent. Millions of miles of thin, glowing gas. For a few weeks, the comet was easily visible, even in modest telescopes, from Earth, a green-tinged ghost against the stars. Now, months later, it recedes, moving outward, back toward the cold. Its brightness fades, activity wanes. The jets weaken as the internal volatile reservoir deplete and as solar heating diminishes. With distance squared, the law of inverse squares, cooling the surface once again. Eventually, 3i Atlas will leave the solar system, escaping back into interstellar space on a different trajectory than it entered. Its encounter with the Sun bent its path gravitationally, and the non-gravitational forces from outgassing nudged it slightly. It will carry away less mass than it arrived with, having shed gas and dust as into the coma, some of which escaped entirely, some of which might, in eons, spiral inward and contribute to zodiacal dust, the faint glow seen in the twilight of Earth. But most of the nucleus remains, now colder, quieter, returning to its long dormancy between the stars, heading toward the constellation of Pegasus, or perhaps, further still, the trajectory, the arrival and departure remind us of transience. Things come, things go, even comets from other stars visit briefly, then vanish into the dark. Your thoughts, too, arise, linger, then pass. The day's events, vivid once, now fade into the past. The gentle volatile release of a memory surfacing, then escaping awareness, is natural, expected. The comet does not mourn the gas it loses. It does not regret the mass it left behind. It simply continues. You need not mourn the day as it passes. You need not cling to its worries. Simply continue into the regeneration of sleep. The eruption's embrace of solar warmth was temporary but real. For a few months, the frozen traveller had felt heat, light, stirring its interior, awakening dormant processes, revealing its hidden nature to the universe. Now, warmth fades, cold returns, but the comet is not diminished. It experienced, it transformed, it released, and it continues, richer for the encounter. Even if now less massive, you must too embrace the day's warmth, its demands, its stimulations. You felt the light, you did the work. Now you release into the cool, quiet of night, not diminished, but ready for renewal. The atoms in your rest are as active as the atoms in the star. The silence is full. The sustained hidden glow of cryovolcanic activity suggests enduring energy sources not dependent on sunlight. This expands the habitable zone, the region around a star where liquid water could exist, to include locations far from the star where internal heat matters more than stellar radiation. We must look deeper into the physics of tidal heating, where the gravitational tug of a massive gas giant like Jupiter or Saturn creates a constant rhythmic kneading of a moon's interior. This friction, generated at the atomic level, converts orbital energy into thermal energy, keeping the oceans of Europa or the plumes of Enceladus liquid and active for billions of years. This insight multiplies the potential sites for life in the galaxy, suggesting that habitability is not a surface phenomenon, but a deep-seated geological process enabled by the dance of gravity and the slow, steady decay of radioactive isotopes like potassium-40 or thorium-232 sequestered in rocky cores. As we absorb these possibilities, these hints of hidden vitality, we can feel our own hidden vitality, the processes continuing within us, even as we rest. Your heart beats without thought, pumping blood through a closed loop of vessels that would wrap around the Earth twice. Cells metabolize, repairing, building, cleaning. Your immune system patrols, your gut microbiome digests, synthesizes vitamins. All this happens in the dark, the interior of your body, requiring no conscious effort. Consider the mitochondria, the ancient endosymbionts within your cells, generating ATP, the currency of life, through the electron transport chain. A series of redox reactions occurring across a microscopic membrane. The reaction's eternal hush of biochemistry proceeds in silence, enabling your existence. Your glymphatic system awakens in sleep, a specialized waste clearance system that hitches a ride on the pulses of your arteries, flushing the space between your neurons, washing away the amyloid beta and the tau proteins that accumulate during the day's thinking. The deep void integration of the comet, journeying alone through interstellar space, reflects our own capacity for solitude, for rest. In sleep, you are alone with yourself, disconnected from external demands. This is not loneliness, but integration. The comet integrated its journey, its cold, its silence into its structure, preserving its integrity over timescales that dwarf human civilizations. It has traveled for millions of years through the interstellar medium, ISCM, bombarded by cosmic rays and high-energy protons, yet its core remains a pristine time capsule of a distant alien nebula. You integrate the day's experiences in sleep, processing, consolidating memories in the hippocampus, moving them into the long-term storage of the neocortex, balancing neurochemistry resetting the sensitivity of your synapses. The void is not empty, but full of quiet work, a necessary and beautiful recalibration. Let us now consider the metal chemistry in greater detail, allowing the technical aspect to become almost musical, rhythmic recitation of elements and reactions. Nickel, atomic number 28, in the periodic table, sits between iron and cobalt. It has a moderate reactivity, forming compounds with oxygen, sulfur, carbon monoxide. Its electron shell structure, a 3D Fate Forces 2, allows it to share electron with ease, forming coordinate covalent bonds that make it a master of transition metal chemistry. Iron, atomic number 26, more abundant and slightly more reactive, rusts easily in the presence of oxygen and water. Both metals can act as catalysts, lowering the activation energy, the barrier to change for reactions that would otherwise proceed too slowly to matter. They provide a surface, a staging ground, where molecules can meet, orient themselves, and transform with minimal effort. The native metals in the comet exist because the environment of their formation was reducing, lacking free oxygen. In a protoplanetary disk, the swirling cloud of gas and dust that births a solar system, the inner regions are too hot for metals to condense. As solids, they remain as a hot vapor, ionized and turbulent. But farther out, beyond the snowline, the critical boundary where the temperature drops below 150 to 170 Kelvin, water ice becomes a solid, and even farther, where carbon monoxide and nitrogen freeze at temperatures near 20 or 30 Kelvin, metals can condense as fine grains as cosmic smoke. They mix with ice, becoming incorporated into planetesimals, the building blocks of planets, and comets, becoming the seeds of future geology. These grains are tiny, submicron sized, yet they hold the magnetic history of their birth, aligned with the magnetic fields of the young protostellar disk. These metal grains, once embedded in ice, remain inert for eons until warmth arrives. As the comet approaches a star, solar radiation penetrates the surface. The photons, absorbed by the dark, carbon-rich mantle, warming the interior through conduction. Ice begins to sublime, first the most volatile, nitrogen, then carbon monoxide, then carbon dioxide, then water. As the ice disappears or becomes porous, metal grains are exposed to gases and perhaps to thin films of liquid water, mere nanometers thick, trapped in the pores. Now, oxidation begins. Nickel reacts with water or carbon dioxide, releasing hydrogen or carbon monoxide. Iron does the same, forming magnetite, Fe3O4, or hematite, Fe2O3. The energy released, the enthalpy of reaction, is modest but sustained. Over days and weeks, it accumulates, providing a gentle, internal heat that supports the glow of the cryovolcanism observed from afar. The nickel tetracarbonyl pathway offers an alternative, a more exotic, organometallic dance. At temperatures around 150 Kelvin, nickel metal exposed to carbon monoxide gas can form this compound, NiCO4, a tetrahedral molecule where the nickel atom is cradled by 4 carbon monoxide ligands. Nickel tetracarbonyl is volatile. It wants to be a gas, evaporating at low temperatures. It migrates through the porous ice, traveling from the core toward the surface or toward warmer regions. When it decomposes from heat or from the impact of ultraviolet photons, it deposits pure nickel in an ultrafine, highly reactive form and releases the carbon monoxide back into the gas phase. This cycling of carbon monoxide on and off metal surfaces might enhance the efficiency of gas production, acting like a pump, moving mass through the comet's interior. Iron does not form a stable carbonyl under the same conditions. It requires higher temperatures or much higher pressures, like these found deep within a planet's mantle. This explains the initial absence of iron emission in the spectra of 3I Atlas. Only nickel could be mobilized, at first, by the low-temperature carbonyl chemistry. As the comet warmed further, approaching perihelion, its closest point to the sun, iron vapor began to appear, not from carbonyls, but from the direct sublimation or from the thermal decomposition of iron-bearing minerals like troilite, heated to their breakdown temperatures. The coma chemistry therefore evolves as a temperature profile moves inward through the nucleus, revealing successive layers of composition, a chemical stratigraphy read in the lines of a spectrograph. The sulfides, another important component, include troilite, iron sulfide, Vs. When troilite oxidizes, in the presence of water or oxygen, it produces iron oxides and hydrogen sulfide gas, H2S. This gas has a distinct smell to humans, like rotten eggs, though in space there is no medium, no air to carry scent. The hydrogen sulfide might further react with other compounds or photolyze in sunlight, breaking into sulfur and hydrogen. The sulfur could aggregate into long chains of S8 molecules, contributing to the yellowish or brownish colours, the interstellar soot observed in some cometary dust. The hydrogen, lightest of all elements, escapes easily into space, forming a massive invisible cloud of neutral hydrogen that can be detected in the ultraviolet. These chemical details may seem intricate, complex, but allow them to wash over you, not as problems to solve, but as rhythms, as a natural law to sink into. Nickel, iron, sulfur, oxygen, carbon, each element playing its part in a slow, ancient dance. The metal ice symphony in slow motion plays on, notes separated by vast spaces, yet harmonious within the framework of the laws of physics. Your breath slows further, notes separated by pauses, yet rhythmic. The catalytic quiet pulse of your heartbeat steady, dependable, requires no thought. It is a biological automation, as reliable as the orbital mechanics of a comet. We return now to the journey itself, the trajectory through our solar system. 3I Atlas entered from the direction of the constellation Perseus. It arrived with a velocity relative to the Sun that was far too high, over 40 kilometers per second, for it to be a local resident. This hyperbolic speed, with an eccentricity 1, proved its interstellar origin. It is a visitor from another star system, perhaps ejected by a giant planet in its own home system billions of years ago. It approached from above the ecliptic plane, the plane of the planets, descending at a steep angle toward perihelion. The perihelion closest approach to the Sun occurred in January 2025, at a distance of about 0.77 astronomical units, placing it between the orbits of Earth and Venus. At that distance, solar heating intensified. The flux of sunlight, the energy per square meter, increased as the square of the distance decreased. Surface temperatures rose. Sublimation accelerated, creating the massive coma, a glowing envelope of gas and dust, millions of kilometers in diameter. For a few weeks, the comet was easily visible, even in modest telescopes, a faint, green-tinged ghost drifting across the background of the distant stars. Now, months later, it recedes, moving outward, back toward the cold. Its brightness fades, activity wanes, the jets weaken as the internal volatile reservoirs become depleted or refreeze as the solar heating diminishes. Eventually, 3I Atlas will leave the solar system, escaping back into interstellar space on a different trajectory than it entered. Its encounter with the Sun bent its path gravitationally, while the non-gravitational forces, the rocket effect, from the asymmetrical outgassing nudged it slightly. It will carry away less mass than it arrived with, having shed gas and dust into the coma, some of which escaped entirely, some of which might, in eons, spiral inward as zodiacal dust, contributing to the faintest cone of light seen at sunrise or sunset. But most of the nucleus remains, now colder, quieter, returning to its long dormancy between the stars, heading back into the dark. The trajectory, the arrival and departure remind us of transience. Things come, things go, even comets from other stars visit briefly, then vanish. Your thoughts, too, arise, linger, then pass. The day's events, vivid once, now fade into the past. The gentle, volatile release of a memory surfacing, then escaping awareness is natural, expected. The comet does not mourn the gas it loses. It does not regret the dust it leaves behind. It simply continues on its path. You need not mourn the day as it passes. You need not cling to its worries. Simply continue into the regeneration of sleep. The eruption's embrace of solar warmth was temporary, but real. For a few months, the frozen traveller felt heat, light, stirring its interior, awakening dormant processes, revealing its composition to our instruments. Now, warmth fades, cold returns, but the comet is not diminished. It experienced, it transformed, it released, and it continues. Richer for the encounter, even if now less massive. You too embrace the day's warmth, its demands, its stimulations. Now you release into the cool, quiet of night, not diminished, but ready for renewal. As you drift, imagine the comet, now far beyond the orbit of Neptune, its surface, once boiling with gas, now silent and dark, its internal fires. The chemical reaction between nickel and ice have slowed to a crawl, but they are not gone. They remain, a tiny, glowing ember in the deep dark, just as your life continues its vital, quiet work throughout the night. The universe is vast, cold, and seemingly empty, but it is filled with these hidden glows, these pockets of life and heat and awareness. You are one of them, and now it is time to rest. Let us turn now to the human wonder, the subjective experience of encountering such a phenomenon. Imagine being an astronomer, receiving the alert of a new interstellar object, the excitement, the rush to observe before it fades, writing proposals, competing for telescope time, the preparation, the anticipation, checking equipment, calibrating instruments, coordinating with colleagues across time zones, across continents, the night finally arriving when you point your instrument at the coordinates, the first light captured, photons that have travelled from beyond our solar system, carrying information encoded in wavelengths, in intensities, in polarization states, the data flowing in, images, spectra, each one a gift, revealing secrets held for eons, raw numbers transforming into understanding, the analysis, late nights, coffee, equations, comparing models to observations, checking, rechecking, ruling out alternatives, the moment when the pattern clicks, when you realize cryovolcanism explains it all, the satisfaction of understanding, of adding one small piece to humanity's knowledge of the cosmos, this human side of discovery, the passion, the patience, the collaboration across countries and institutions, mirrors the collaborative processor within you, billions of neurons working together, creating thought, forming memories, generating consciousness itself, trillions of cells cooperating, maintaining your body, each one performing countless chemical reactions every second, exchanging signals, sharing resources, working toward homeostasis, toward balance. You are not a single entity, but a community, a symphony of living processes, an ecosystem contained within skin. The comet, too, is not monolithic, but a mixture of ice types, mineral grains, organic compounds, metal particles, all interacting, creating emergent behavior that no single component could produce alone, the whole exceeding the sum of parts, water ice providing structure, carbon dioxide driving activity, metals absorbing energy, transferring heat, organics darkening surfaces, affecting albedo. Together, they create something greater, a dynamic system responsive to its environment. The comparison to trans-Neptunian objects, those distant icy worlds orbiting far from the Sun, strengthens our interpretation. Objects like Pluto, Eris, Makemake, Haumea show varied surfaces, varied compositions, some very bright, covered in fresh methane frost, reflecting 90% of incident sunlight. Others darker, with older, more processed surfaces, irradiated by cosmic rays over billions of years. Some show signs of past or present geological activity, features that shouldn't exist on bodies so small, so cold, so far from the Sun's warmth. Pluto's vast plains, Sputnik Planitia, appear young, perhaps only millions of years old, requiring recent resurfacing, possibly from cryovolcanism or from ice convection, where nitrogen ice behaves like glacial ice on Earth, flowing, churning, erasing craters, creating smooth surfaces. The discovery that such small worlds remain active changed our understanding of planetary science, showed us that activity doesn't require massive size or internal heat from radioactive decay. Other mechanisms can drive geological processes in the cold, outer reaches of planetary systems. 3i Atlas resembles these distant worlds in composition, in behavior, suggesting it formed in the outer regions of its home system, where temperatures allowed volatile ice to condense, where the solar nebula was rich in carbon, in nitrogen, in oxygen, bound in icy forms, where metal grains mixed with ice, forming planetesimals in the cold during the chaotic early epochs of system formation. These outer regions of protoplanetary disks are storage zones for the system's inventory of volatiles, repositories of the lightest elements that couldn't condense. Closer to the star, most remain as small bodies, comets, scattered disk objects, Kuiper belt analogues, never accreting into planets, remaining as primordial remnants, time capsules preserving conditions from the system's birth. Some are ejected by gravitational interactions with giant planets during orbital migrations, during close encounters, becoming interstellar wanderers like 3i Atlas, cast out from their home, travelling for millions or billions of years through the dark between stars. The statistics of such ejections suggest that every star system ejects billions, perhaps trillions, of comets into interstellar space during its formation and early evolution, when giant planets settle into stable orbits, clearing out the remaining planetesimals. The galaxy, therefore, is filled with these wanderers outnumbering by far the stars themselves, perhaps 10 or even 100 of these objects. For every star, most travel unseen, undetected, between the stars, dark, frozen, inert. Only when one happens to pass close enough to our sun do we notice, do we observe, do we learn. Each detection samples the diversity of planetary systems throughout our galactic neighborhood, giving us glimpses of worlds we could never visit directly. Your own mind contains multitudes of thoughts, memories, possibilities, most unseen, unexamined, drifting in the background of consciousness, neural patterns waiting to activate, connections forming and dissolving constantly. Only occasionally does one surface into awareness, into the light of attention, before fading back into the unconscious, into the vast darkness where most mental content resides. The comet drifting through the galaxy, mostly invisible, occasionally illuminated by a star's warmth, parallels the flow of consciousness. Most content remains dark, unactivated, potential rather than actual. Only a small fraction at any moment is active, expressing itself, being observed, being experienced. As we continue this meditation on ice and metal, on chemistry and light, on distance and time, we feel the gentle pull toward deeper rest. The cryovolcanic calm spreads through awareness like a mist, settling over everything. The ancient pressure surrender has already begun within you. Muscle tension releasing in waves, starting from your core, spreading outward. Thoughts slowing, their urgent pace diminishing. Breath deepening, becoming rhythmic, effortless. The silent jet harmony plays on, a background music you barely hear, fading further with each moment. The chemical depth piece invites you downward, inward, away from surfaces, towards center. The mantleless openness leaves you receptive, vulnerable in the best sense to sleep's approach. Now we turn our thoughts to the deeper structures, the internal architecture that enables these quiet eruptions. The nucleus, perhaps a few kilometers across, maybe 5, maybe 10, is not uniform, but heterogeneous, complex in structure. Patches rich in carbon dioxide ice, alternate with regions dominated by water ice or by darker, less volatile materials, refractory organics, silicate minerals. Metal grains are not evenly distributed, but concentrated in certain zones, perhaps where they condensed in the original protoplanetary disk, settling through the nebula, accumulating in layers, or where they migrated during aqueous alteration, when liquid water briefly existed, dissolving, transporting, redepositing minerals and metals. These compositional variations create differential responses to solar heating. A region rich in metal and carbon dioxide heats quickly, the metal grains acting as heat sinks absorbing photons, conducting warmth into surrounding ice, reacts vigorously, produces abundant gas, carbon dioxide, expanding from solid directly to gas, bypassing liquid phase, becoming an active source, a jet visible from Earth through our telescopes. A region poor in volatiles remains quiet, passively reflecting or absorbing sunlight, contributing nothing to the coma, to the observable activity, just sitting dormant until conditions change. The rotation brings different regions into sunlight, creating the temporal variations. We observe the brightening and dimming, the waxing and waning of activity as active patches rotate into view, then into shadow. The rotation period, perhaps 8 hours, perhaps 12, determines the timescale of these variations. The axis of rotation, its orientation, determines which regions receive the most heating over a full rotation. The interior temperature increases with depth at first as sunlight penetrates and warms the outer layers, then may plateau or even decrease if the deep interior remains cold, insulated by overlying layers by the low conductivity of porous ice. This creates a temperature profile that determines which ice is sublime, at which depths, near the surface, within millimeters or centimeters. Carbon monoxide, the most volatile, with the highest vapor pressure, sublimates first, even at large distances from the Sun, beyond Jupiter's orbit, creating a tenuous envelope. Deeper, centimeters to meters below, carbon dioxide dominates, requiring more warmth, more solar flux, becoming active as the comet approaches closer to the Sun. Then water ice in the warmest regions closest to the surface, in direct sunlight near perihelion. Each ice has a characteristic sublimation temperature, a specific vapor pressure curve described by the Clausius-Clapeyron equation that governs its behavior predictably, mathematically, inevitably. The gases produced in the subsurface, carbon dioxide molecules, water molecules, carbon monoxide, percolate upward through porous ice, through interconnected voids, through cracks, through channels carved by previous eruptions. The flow is not uniform, but channelized, focused into vents, where permeability is highest, where the ice is most fractured, or where cracks penetrate deepest, reaching the warmest layers, where sublimation is most vigorous. This channelized flow explains the discrete jets rather than a uniform glow enveloping the nucleus. The pressure buildup behind a vent can be substantial, pascals becoming kilopascals, driving gas outward at speeds of hundreds of meters per second. Supersonic flow, expanding, cooling, freezing. The gas expands rapidly into the near vacuum of space, cooling adiabatically, temperature dropping, freezing into tiny ice crystals, nanometers to micrometers across, that scatter sunlight, creating the visible jets we observe, filaments of brightness, extending from the nucleus. The dust, mixed with this gas flow, silicate particles, organic grains, metal flakes, is lifted, accelerated, ejected by gas drag. Some particles, too large, too heavy, return to the surface in ballistic arcs, falling back, redepositing. Others escape the weak gravity, joining the coma, the vast cloud surrounding the nucleus, or even leaving the system entirely, achieving escape velocity, becoming their own tiny interstellar objects. The mass balance of the comet is a story of loss and retention, transformation and preservation. Gas, once sublimated, escapes to space, irreversibly, so it's lost forever from the nucleus. Dust partially escapes, partially returns, enriching the surface in non-volatile materials, in the heavier particles that couldn't escape over many perihelion passages. If they occurred, if this comet had returned repeatedly to some star, it would build up a dust mantle, centimeters, then meters thick, choking off activity, insulating the ice, preventing further sublimation. But through the Atlas, on its first passage through our system, has no such mantle. Its surface remains responsive, pristine, fresh. Each photon of sunlight contributes directly to sublimation, to outgassing, to the sustained, gentle eruptions we witness from our distant vantage point. The thermal inertia of the material affects the response time to heating and cooling. Low thermal inertia means rapid heating and cooling, temperature tracking, the sun's position closely, immediately. High thermal inertia means slow changes, thermal mass, buffering against temperature extremes, smoothing diurnal variations. The porous ice with voids, with vacuum pockets, likely has low thermal inertia, heating quickly in sunlight, cooling quickly in shadow within minutes or hours. This creates strong temperature gradients, steep curves of temperature versus depth, driving vigorous sublimation in the upper few centimeters or meters where the action occurs. Deeper than this, below the diurnal skin depth, the ice remains cold, unaffected by diurnal or even seasonal variations, preserving primordial cold from formation. These technical details, the physics of heat transfer, gas dynamics, sublimation kinetics, molecular diffusion, may seem distant from the experience of rest, from the purpose of this meditation. Yet they describe processes that occur without conscious effort, automatically, inevitably, given the right conditions, cause and effect unfolding according to natural law. Your own body operates on similar principles. Heat flows from core to skin, following temperature gradients. Gases diffuse, oxygen inward to tissues, to cells, carbon dioxide outward to lungs, to atmosphere. Fluids percolate through tissues, through vessels, carrying nutrients, removing waste, all without your direction, without your awareness, all following natural law physical law, chemical law, biological law. The comet teaches us that complex behavior emerges from simple rules repeated across vast numbers of molecules, of interactions. As we integrate these layers of understanding, scientific, experiential, meditative, we feel the weight of the day continuing to lift moment by moment. The primordial eruption flow within the comet, within you, follows its course inevitably, naturally, without resistance. The corrosion's soft energy transforms without violence, without force, gentle oxidation, gradual change. The catalytic quiet pulse maintains rhythm without effort, without intention, heartbeat, breath, sublimation, all automatic, all given. The global surface sigh happens now, a collective release of the day into the past, letting go of what was, accepting what is. The volatile memory drift carries away what you no longer need to hold, evaporating like carbon dioxide into space. The interior cosmic exhale empties the lungs of consciousness, releasing the breath you've been holding all day. The ice-vent stillness between exhales lengthens, stretches, becomes the dominant experience, not the breathing, but the pauses, not the activity, but the silence between activities. The sustained hidden glow of awareness dims further, retreating inward, contracting. You are becoming like the comet in its receding phase, moving away from perihelion, from peak brightness, activity waning, light diminishing, yet structure maintained, essence preserved, identity intact, just quieter, just darker, just more peaceful. The decline is graceful, natural, inevitable. There is no struggle, no resistance, only the gradual transition from expression to silence, from wakefulness to sleep, from day to night. The reaction's eternal hush begins to envelop all processes, covering everything, like snow, like ice, falling, settling. Chemical activity slows, reaction rates decreasing with temperature. Neural activity quiets, firing rates diminishing, synchronizing into sleep rhythms. The deep void integration approaches the merger with darkness, with silence, with rest. Let us drift now more fully into the abstract, into sensation, beyond specific facts, beyond measurements, beyond language almost. The eruptions on that distant surface has become a feeling of gentle release, pressure, then relief. The metal chemistry becomes the taste of peace, metallic, cool, clean. The spiral jets become visual patterns behind closed eyes, swirling, fading, phosphines, imagined or real. The coma expansion becomes the expansions of your awareness, diffuse, unbounded, no edges, no center. The subsurface pressure becomes the urge to let go, to surrender to what comes naturally, to sleep, to dreams, to nothing, everything dissolving into quiet, into darkness, into rest. The journey of three-eye atlas through our system was brief. A few months of visibility, of activity, of scientific observation. Now, as it fades, we are left with data, with images, with knowledge, but also with a feeling, a sense of having touched, however briefly, another world from another place. The comet carries forward most of what it brought. The gas is released a tiny fraction of its total mass. Most remains frozen, intact, ready for the next encounter. You carry forward most of what you are. The day's experiences integrated, but your core, your structure, your essence remains. Sleep is not loss, but integration. Not ending, but transition. The comet does not cease to exist, and when it leaves our view, it continues in darkness, in cold, in silence, patient, enduring. You do not cease in sleep. You continue in darkness, in rest, in silence, renewing, restoring. The cryovolcanic processes taught us that even in extreme cold, even in apparent stillness, activity can occur, transformation can happen. So too, in sleep, though you appear still, inactive, within, processes continue, memories consolidate, tissues repair, balance restores. The comparison to Enceladus, to Europa, to Triton reminds us that ice volcanism is common in our solar system and likely throughout the galaxy. Water worlds, ocean worlds, hidden beneath ice shells, erupting occasionally through cracks, releasing plumes that speak of hidden depths. The universe is not cold and dead, as it might appear, but alive, with quiet activity, with hidden warmth, with pockets of complexity scattered throughout. You too are not merely a surface, but depths, hidden warmth, complexity that continues even when outward expression ceases. The sustained glow from hidden activity dims, dims, dims. The comet, fading now, millions of kilometers away, receding toward the outer darkness. The distance grows, the signal weakens. Soon, it will be too faint for even the largest telescopes to detect. It will slip back into invisibility, back into the vast population of interstellar wanderers, unseen but present, traveling silently through the galaxy. Your own consciousness fades, fades, fades. The distance from waking grows. The signal of awareness weakens. Soon you will slip into invisibility, into the population of sleeping minds, unseen but present, traveling silently through dreams. The jets have slowed, nearly stopped. The coma contracts toward the nucleus. The brightness drops below detection thresholds. The comet is gone from our view, but not gone from existence. Your thoughts have slowed, nearly stopped. Your awareness contracts toward stillness. Your attention drops below detection thresholds. You're gone from waking. but not gone from being. And now we enter the final phase of our journey, the fade to silence, the return to the cosmic quiet, from which all things emerge and to which all return. The words become fewer, the pauses longer, the science gives way to sensation, the facts dissolve into feeling, pure, abstract, restful, quiet, subsurface, awakening, reverses, becomes, settling, hidden, ice, whispers, fade, below hearing, gentle, volatile, release, becomes, retention, holding, metal-driven, serenity, simply, serenity, pristine, buried, breath, buries deeper, unreachable, cryovolcanic, calm, everywhere, everything, ancient, pressure, surrendered, silent, jet, harmony, becomes, silence, chemical, depth, peace, depth, and peace, mantleless, openness, open, completely, primordial, eruption, flow, slows, stops, corrosion, soft, energy, softens, to nothing, catalytic, quiet, pulse, quiets, absolutely, global, surface, sigh, one last, sigh, volatile, memory, drift, drifts, beyond retrieval, interior, cosmic, exhale, completely, exhaled, ice, vent, stillness, perfect, stillness, sustained, hidden, glow, extinguished, reaction, eternal, hush, eternal, only hush, deep, void, integration, integrates, all boundaries, dissolved. The comet is space, space is the comet, you are rest, rest is you. No difference, no separation, only the field of being without edges, without center, the darkness so complete, so welcoming, the silence so deep, so full, the stillness so absolute, so peaceful. Nothing moves, nothing needs to move. Everything is as it should be, perfect, complete, at rest, ice, metal, space, time, all words, losing meaning, becoming sounds, vibrations, then not even that, awareness, so dim, so faint, barely a flicker, then not even a flicker, just the potential of awareness held in suspension, in the vast, in the dark, in the quiet, drift, deeper, further, darker, quieter, stiller, until there is no until, no before, no after, only this eternal moment of rest. The comet somewhere travels silently through the infinite dark. You somewhere rest silently in the infinite peace, both suspended, both complete, both free. And as you sink beyond the reach of words, beyond the touch of thought, into the deepest quiet, we remember that all journeys are circular, all endings are beginnings, and we prepare to meet you again when the cycle turns, when the awakening returns, when you drift once more into the quiet embrace of the cosmos, knowing that we are always here, waiting in the stillness, ready to guide you back to this deep rest. This is your weekly dose of 3i Atlas, featuring the rotational heartbeat of an interstellar traveler, brought to you by the Sleepy Science 100 channel. Tonight, we drift into the quiet cosmos, following a visitor from beyond our solar system, listening closely to a rhythm written in light and shadow. Now, let us settle in. We will glide through the precise 16.16-hour rotational period, driving gentle pulses of brightness, the comet's nucleus revealing its heartbeat through periodic light curve variations, a slow spin, phased outgassing, a cosmic rhythm breathing through the coma. And so we begin, floating outward through the darkness, toward a body that may have travelled for millions of years, carrying with it a rhythm, an ancient heartbeat, measured now in the patient turning of its nucleus. 16.16 hours, one complete rotation, one full revealing of hidden faces, one cycle of light and shadow and whispered sublimation. Imagine, if you will, the photometric observations cascading in from telescopes scattered across our world, each one catching fragments of brightness, fragments of dimming, as this distant nucleus turns, ever so slowly, in the vast emptiness between stars. The data points gather like soft snow, accumulating into patterns, into curves, into the unmistakable signature of periodic variation, a clear rhythm emerging from the noise, a pulse rising and falling with the patience of geological time compressed into hours. As we drift together through this gentle cosmic cadence, if you find these quiet journeys through sleep and space calming or meaningful, you're warmly invited to subscribe. Liking the video helps us know these explorations are reaching you. And if you're still awake, before you fully drift off, feel free to leave a single word in the comments describing how you hope to feel in the morning. Rested, calm, clear. Thank you for joining us tonight as we drift far, far out, listening to the soft, steady pulse of 3 Atlas. The dominant period reveals itself. 16.16 hours, not a random number, but the echo of the nucleus itself, spinning, turning its faces toward us, then away, then toward us again. This rotation, this slow cosmic waltz, drives everything we see, every brightening, every dimming, every subtle shift in the light that reaches us across millions upon millions of kilometers. It is, in essence, the heartbeat of an ancient body, a pulse that has beat steadily, unchanging, through the darkness between the stars. When we examine the light curve, the graph of brightness over time, we find an amplitude, a measure of how much the brightness changes, reaching approximately 0.3 to 0.5 magnitudes. This may seem like a small variation, a gentle fluctuation, but it tells us something profound. The nucleus is not spherical, not a perfect ball of ice and rock, but elongated, perhaps stretched, like a cosmic egg, or possibly bilobate. 2 lobes joined together, turning end over end in the void. Each time the long axis points toward us, We see more reflective surface, more brightness, and as it rotates away, presenting its narrower profile, the light dims, a gentle exhalation. Before the next inhalation of illumination, some datasets reveal a double-peaked structure, 2 maxima, 2 minima, within each 16.16-hour cycle, suggesting we are seeing both ends of an elongated shape, while other observations show single-peaked components, perhaps when viewing angles change, or when outgassing from active regions overwhelms the geometric signal. The pulse adapts, shifts, reveals different facets of its nature, while maintaining its underlying 16-hour cadence, its patient, unwavering rhythm. The astronomers who discovered this period, who teased it from the scattered observations, used elegant mathematical techniques, phase dispersion minimization, a method that tests countless possible periods, seeking the one that brings order to apparent chaos, that aligns all the brightness measurements, folding them into a coherent pattern. The Lomskargel periodogram, another tool, confirmed what the first method suggested. 16.16 hours, a signal strong and clear, rising above the noise like a beacon, a cosmic metronome, counting out the seconds, the minutes, the hours of this interstellar visitor's patient rotation. These observations span months, from July through December 2025, as 3 Atlas swept through the inner solar system, approaching, brightening, then receding, fading back into the cosmic depths. Multiple telescopes contributed, each adding pieces to the puzzle, creating dense phase coverage, ensuring that no part of the rotation remained hidden. Gemini north and south, powerful instruments perched on volcanic mountains, provided high-precision photometry, measurements of exquisite accuracy, while amateur networks, Comets, the British Astronomical Association, supplied long-term monitoring, patient vigils, night after night, capturing the steady pulse, the unwavering rhythm of this distant nucleus. And here is where the story deepens, where rotation becomes more than just spin. The brightness pulses. These regular fluctuations correlate with changes in the coma morphology, the shape and structure of the dust and gas clouds surrounding the nucleus. As the nucleus turns, as specific regions rotate into sunlight, outgassing jets modulate in intensity, brightening when active regions face Earth, dimming when they turn away. The rotational whisper shapes visible jets, creates patterns, structures that appear, strengthen, and fade, all in synchrony with that 16.16-hour heartbeat. We can see this phased awakening, these jets appearing brighter when their source regions face us directly, their brightness tied intimately to the rotational phase, to the exact orientation of the spinning nucleus. The entire coma brightness, the overall glow of gas and dust, shows rotational modulation, pulsing gently in time with the nucleus, a cosmic breathing, an exhalation of volatiles, timed to the ancient spin, the primordial cadence that has persisted across unimaginable distances. From these observations, from the asymmetry of the light curve. Scientists infer the orientation of the nucleus spin axis, the invisible pole around which everything rotates. The obliquity, the tilt of this axis, is likely high, creating seasonal outgassing patterns, ensuring that different latitudes receive varying amounts of sunlight over the course of each rotation, driving complex patterns of sublimation, of jets, of dust release, all governed by that slow, patient, 16.16-hour rhythm. Now, consider this. 16.16 hours is unusual, surprisingly slow, for a small cometary nucleus. Typical solar system comets, bodies born in our own stellar neighborhood, spin faster, much faster, with periods of 5 to 10 hours, quick rotations, rapid cycles. But for Atlas, this interstellar traveler, takes its time. 16.16 hours places it among the slower rotators, bodies that turn with deliberate patience, preserving something from their formation, some quality of their birth. This slow spin may preserve primordial angular momentum, the original rotation rate from when this body first coalesced, perhaps in a circumstellar disk orbiting a young star light years from here. Billions of years ago, interstellar travel, the long journey through the void, may dampen rotational excitation. There are no collisions in the interstellar medium to spin it up, no gravitational encounters to transfer energy, just the slow, steady, unchanging rotation, conserved across the parsecs, across the eons, a heartbeat echoing billions of years. And remarkably, no significant period change has been detected over the months of observation. The upper limit on period variation is less than 0.01 hours, essentially unmeasurable. This rules out rapid spin-up from outgassing torques, the forces that jets might exert on the nucleus, trying to change its rotation. Yet 3i Atlas resists, maintains its rhythm, suggesting the nucleus is likely monolithic, a single coherent body, or at most loosely bound, but structurally stable. Not a contact binary tumbling chaotically, not a rubble pile threatening to fly apart. The light curve shape remains stable, month after month, rotation after rotation, suggesting structural integrity, a body that holds together, that maintains its form, despite the stresses of outgassing, despite the thermal cycling, despite everything the solar environment throws at it. The amplitude stays consistent across different filters. Red light. Visual wavelengths showing similar modulation, and near-infrared observations confirm that this is a nucleus-dominated signal, that we are truly seeing the body itself, not just coma brightness variations. Careful analysis subtracts the coma contribution, using profile-fitting, mathematical models that separate the diffuse cloud from the solid nucleus, revealing the pure rotational signal beneath. And when we align this signal with jet visibility cycles, we find perfect correlation. Specific jets brighten at predictable phases, appearing like clockwork as their source regions rotate into view. Phase-folded images, where many rotations are stacked together, reveal repeating structures, patterns that emerge, sharpen, then fade, only to emerge again 16 by 16 hours later, a cosmic rhythm, a dance of illumination. The Nordic Optical Telescope captured time series observations, watching full cycles unfold, documenting the complete rotation from peak brightness through dimming to minimum, then back to peak, a complete circuit, a full revelation of this ancient body's shape and activity. And at closest approach, when 3C Atlas swept nearest to Earth, Keck Observatory's adaptive optics, technology that corrects for atmospheric turbulence, resolved the nucleus, actually separated it visually from the surrounding coma, providing direct constraint on its size. From absolute magnitude measurements, from the total amount of light reflected, astronomers estimate the nucleus diameter at 4 to 8 kilometers, assuming a low albedo, a dark surface, around 0.04 to 0.06, similar to charcoal, to coal. These rotational light curves, these brightness variations, feed into shape models, mathematical reconstructions of the three-dimensional form. Ellipsoid models fit the data well, with axis ratios of 1.5 to 2.1, one dimension half again or twice as long as another, an elongated form, turning slowly, showing us first its broadside, then its narrow edge, then broadside again, in endless patient cycles. Such a shape, at such a slow rotation, would not maintain hydrostatic equilibrium, would not be held in a relaxed spherical form by its own gravity. Instead, strength must come from primordial ices, or perhaps even metals, internal cohesion, material bonds that resist deformation, that keep this ancient structure intact. The outgassing torque, the push of jets trying to change the rotation, proves insufficient to alter the period significantly. The body resists, maintains its ancient rhythm, its primordial pulse, the non-gravitational acceleration, the tiny push that outgassing exerts on the comet's orbit shows no rotational signature, no 16.16 hour variation, suggesting the net force averages out over each rotation, that active regions are distributed, balanced, not concentrated on one hemisphere. This pulse rhythm, this 16-hour heartbeat, becomes visible in the overall brightness evolution, in how the comet brightened as it approached the sun and dimmed as it receded, pre-perihelion, before closest approach to the sun. The light curve was weaker but still present, a subtle pulse, a gentle variation. Then post-perihelion, after that closest passage, the amplitude increased with activity, as outgassing strengthened, as more volatiles sublimated away. This seasonal enhancement, active areas becoming illuminated, drove stronger modulation, deeper brightness variations, while maintaining that same 16.16 hour cycle, that unchanging heartbeat. The diurnal cycle, the day-night rhythm on the nucleus surface, drives volatile sublimation patterns. CO2 and CO, carbon dioxide and carbon monoxide, sublime, turn from ice directly to gas, modulated by insolation, by how much sunlight strikes each region. Water ice activation occurs deeper, less directly influenced by the rotation, requiring more sustained heating. But the supervolatiles, the ices that evaporate easily, respond immediately to the rotational cycle, to the 16-hour dance of illumination, jet collimation. The remarkable narrowness of these outgassing streams is maintained across rotations. The slow spin, 16 point on 16 hours of patient turning, prevents smearing of narrow jets, allows persistent jet structures, features that last for hours, that remain coherent, that don't blur into a general haze. This slow rotation permits the jets to maintain their identity, their directionality, their focused streams of gas and dust, all phased to the nucleus heartbeat, stacking multiple rotation cycles, combining observations from any 16.16-hour periods, enhances faint jet visibility, brings out structures too subtle to see in single rotations. November 2025 campaigns, when professional astronomers and citizen scientists coordinated observations, covered multiple complete cycles, each rotation adding data, adding confidence, refining the period measurement. This professional amateur collaboration, this union of large telescopes and backyard instruments, refined the period to exquisite precision, ruled out period aliasing, eliminated false signals that might arise from incomplete sampling. A harmonic at 8.08 hours, exactly half the true period, was rejected as the primary signal. The full 16 or 16-hour cycle, with its double peak structure, better explained all the observations, accounted for all the brightness variations. The distinction between sidereal and synodic periods, between rotation relative to the stars versus relative to the sun, was carefully considered, and corrections for Earth's motion, our own planet's orbital movement, were applied to the analysis, ensuring the measured period truly reflected the nucleus rotation, not artifacts of our changing viewpoint. This nucleus pulse influences even the coma density waves, enhancements in gas and dust density that propagate outward, spreading rhythmically into space, carried by the solar wind and radiation pressure. Each pulse of outgassing, each rotation bringing active regions into sunlight, sends another wave, another enhancement, rippling through the coma, moving outward at hundreds of meters per second, creating subtle structure, patterns that extend far beyond the nucleus, echoes of that central 16-16-hour heartbeat, rhythmic pulses moving outward forever into the cosmic night. Even the anti-tail and tail features, those delicate structures of dust and gas, show slight modulation with the rotation, subtle variations in brightness and morphology, tied to which hemisphere faces sunward, which active regions pour their contents into space at any given moment. The color variations are subtle, requiring careful measurement, but they exist. Green emission from diatomic carbon, from C2 molecules excited by sunlight, appears stronger from the more active hemispheres, from regions where outgassing is most vigorous, where fresh material sublimates into the vacuum. Dust release becomes episodic, tied to rotational facing. When an active region rotates into direct sunlight, into the most intense heating, dust production surges. Particles are lifted from the surface, carried away by expanding gases. Then, as that region rotates into shadow, into the long night of the nucleus, production wanes, drops, until the next rotation brings dawn once more. This slow rotation, this 16.16-hour patient cadence, preserves jet coherence over days. A jet born when a region faces the sun can remain visible, relatively unchanged, for hours, even as the nucleus continues its slow turn, its eternal waltz. We might compare 3i Atlas to 67p Churyumov-Gerasimenko, that celebrated Comet visited by the Rosetta spacecraft, which has a rotation period of 12.4 hours, faster than our interstellar visitor, yet similar in many ways. 67p showed strong rotational modulation, clear brightness variations, phased outgassing that created predictable patterns, jets that appeared and disappeared with clockwork regularity. And here we find 3i Atlas, born light years away, in some distant stellar system, showing remarkably similar behavior, phased outgassing, rotational control of activity. The interstellar origin doesn't prevent familiar rotational behavior, doesn't create something entirely alien. Instead, we see, perhaps, universal principles, physics that operates the same way, whether a comet formed around our sun or around some other star, now lost to identification. This spin state, this 16-16-hour rotation, likely reflects the formation environment in that distant system, perhaps a gentle accretion process, particles slowly gathering, building up, without violent collisions that would spin the growing body faster, or perhaps formation in a region of the protoplanetary disk where material moved slowly, where angular momentum was low excitation from gentle ejection, from being lifted out of its birth system not by violent encounter, but by some subtler process, gravitational perturbation perhaps, or slow migration to the edge of planetary influence, then release into the galaxy, and once in interstellar space, there are no collisions to spin it up. The interstellar medium is almost perfectly empty, a few atoms per cubic centimeter, nothing that could impact with enough mass, enough energy, to change the rotation of even a small nucleus. So the primordial rotation, the original spin from formation, is conserved, preserved, across millions or billions of years, across parsecs of empty space. This pulse rhythm truly becomes the heartbeat of an ancient body, beating steadily, unchanged, since before our solar system might have even existed. All this data, these thousands of photometric measurements, flow into light curve databases, digital archives that preserve the phase data, making it available for future analysis, for comparison with other objects, for refinement as new techniques emerge, and there will be future observations, as long as 3i Atlas remains bright enough, tracking its long-term stability, watching for any changes, any evolution in the rotational period. Any period change would indicate mass loss asymmetry, that outgassing is removing material unevenly, creating torques, forces that alter the spin. But so far, the upper limit on such changes constrains outgassing distribution, suggests remarkable balance, symmetry in how this nucleus releases its volatiles. Through rotational synthesis, combining observations from many different viewing angles, many different rotation phases, astronomers can attempt nucleus mapping, creating maps of the surface, identifying where active regions lie, where inert terrain dominates. Estimates suggest active area fractions of 10 to 30%, meaning only a modest portion of the surface actually produces jets, actually sublimates significantly. The rest remains dormant, covered perhaps in non-volatile lag deposits, dust and organics left behind as ices sublimate, building up over time, insulating the ice beneath. From the light curve, from the way brightness changes with rotation, from the amplitude and shape, scientists can infer the inertia tensor, a mathematical description of how mass is distributed, how the body resists changes to its rotation. This connects to structural questions, to whether the nucleus is homogeneous, uniform throughout, or differentiated, with denser material in some regions. But the stable rotation, the unchanging period, the coherent light curve, all suggest internal homogeneity, a body mixed relatively uniformly, without large-scale internal structure that would complicate the spin dynamics. Slow rotators like 3I Atlas are indeed more common among larger nuclei, among bodies with diameters of several kilometers or more. There's a size-rotation relation. Smaller bodies tend to spin faster, perhaps because they're more easily spun up by outgassing torques, or because they're fragments from collisions that imparted high angular momentum. The fact that 3I Atlas, with its estimated 4 to 8 kilometer diameter, fits this trend, extends the size-rotation relation to interstellar objects, suggests that the same physical principles, the same evolutionary pathways operate across stellar systems. For low-density bodies, porous structures with bulk densities below 500 kilograms per cubic meter, slow rotation makes sense. Less dense than water, more like a sponge than a solid rock. Such bodies have weak internal strength, can't withstand the centrifugal forces of rapid rotation. They would fly apart, disintegrate, if spun too quickly. So, slow rotation, 16.16 hours of patient turning, allows structural stability, permits a porous structure from pristine accretion, from gentle accumulation of icy particles that never compressed fully, never sintered into solid ice, retaining voids, spaces, weakness. This rotational pulse, this heartbeat, reveals that internal homogeneity through its regularity, through its stability. If there were subnuclei, smaller bodies orbiting within the coma, or satellites, companions to the main nucleus, they would complicate the light curve, add additional periodicities, create irregularities, but none are detected. The pulse is clean, pure, a single dominant frequency, 16.16 hours, nothing more. This stable spin excludes recent disruption, rules out a recent breakup, a splitting event that would leave the fragments tumbling chaotically, spinning irregularly. Instead, we see ancient stability, primordial calm. The pulse itself becomes a diagnostic of structural strength. How well does this body hold together? How strong are the internal bonds? The fact that it maintains coherent rotation, that it doesn't wobble, doesn't precess rapidly, suggests adequate strength, sufficient cohesion to maintain its form. This data informs models of extrasolar nucleus evolution, helps us understand how cometary bodies form, evolve, survive in planetary systems beyond our own. Each measurement, each rotation cycle captured, adds to our understanding not just of 3i Atlas, but of comets in general, of icy bodies throughout the universe. As the comet recedes, as it moves farther from the sun, farther from Earth, the rhythmic signal grows fainter, dimmer, harder to detect. The final cycles are captured in late 2025, pushing telescopes to their limits, extracting signal from noise, before the comet becomes too faint for photometry, too dim to measure accurately. But those last rotations, those final pulses, are preserved, archived, added to the complete record of this interstellar visitor's passage through our realm. Let us drift deeper now, into the subtleties, into the quiet nuances of what this 16-hour heartbeat reveals. Consider how light itself becomes our messenger, photons reflected from the nucleus surface, traveling millions of kilometers, carrying information about brightness, about color, about the orientation and activity of a body too small, too distant to resolve clearly even with our finest telescopes. We reconstruct, we infer, we deduce from these scattered messengers the nature of their source. The phase dispersion minimization technique, this mathematical tool, essentially asks a simple question over and over. If I assume the period is X hours, and I fold all my observations according to that period, arranging them as if they came from repeated cycles of X hours, do they line up coherently, or do they scatter randomly? The true period, 16.16 hours, creates order, creates a clear pattern, while wrong periods leave only chaos, only scattered points with no relationship. It's elegant, beautiful. How mathematics can extract signal from what appears to be noise, finding the hidden rhythm, the concealed heartbeat, and the Lomskargel periodogram. This complementary approach builds a power spectrum, showing which frequencies, which periods are present in the data. Strong signals, true periodicities, appear as peaks, as spikes in the spectrum, rising above the baseline, and at 16 hours, there it stands, clear and unmistakable, a peak that dominates, that announces itself as the fundamental frequency, the primary rhythm driving all the brightness variations we observe. Through July, August, September, observers around the world, on different continents, under different skies, contributed their measurements, some from high mountain observatories, where thin air creates steadier seeing, sharper images, others from amateur setups in backyard gardens, modest telescopes guided with passion and patience. Together they wove a nearly continuous monitoring campaign, patching the comet at different rotation phases, ensuring complete coverage, filling gaps, creating redundancy, each observer adding threads to the tapestry, building toward complete understanding. The Gemini telescopes, twins separated by hemisphere, one on Mauna Kea in Hawaii, one on Cerro Pachon in Chile, provided complementary coverage. When the comet set below the horizon for one, it rose for the other. This global perspective, this planetary coordination, allowed tracking the rotational heartbeat continuously, catching every pulse, missing no beat. The precision of these instruments, their sophisticated detectors, their adaptive optics and careful calibration pushed uncertainties down, refined measurements, revealed subtle details that smaller instruments might miss. Yet the amateur networks proved equally vital. Comets, the Comet Observation Network, coordinated by dedicated amateur scientists, provided long-term baseline, night-after-night observations that professionals conducting targeted campaigns might not achieve. The British Astronomical Association, with its Comet section and disciplined observers, added their careful photometry, their patient measurements. This marriage of professional precision and amateur dedication created something neither could achieve alone: a complete picture, a full understanding of 3-eye Atlas's rotational behavior. Now observe how brightness pulses correlate with coma morphology changes. It's not just that the nucleus itself brightens and dims, but the entire cloud of dust and gas, the coma that surrounds and obscures the nucleus, responds to the rotational cycle. As active regions rotate into sunlight, they erupt more vigorously, pouring more gas and dust into the coma, creating localized brightenings, enhancements that move outward, expand, evolve. All phased to that 16.16-hour heartbeat, all synchronized to the slow turn of the ancient nucleus. Outgassing jets, these collimated streams, modulate in intensity with rotation phase. We can measure this, photograph it. See jets brighten as their source regions face Earth, as our line of sight looks directly down into the active area, seeing maximum brightness, maximum contrast. Then as rotation carries that region to the limb, to the edge of the visible disk, and eventually around to the far side, the jet dims, fades, disappears from view, only to reappear 16.16 hours later, when rotation brings it back, brings it around for another showing, another display of activity. These phased jets appear brighter when active regions face Earth, but they exist always, constantly. They continue to emit on the far side, invisible to us but real, genuine. It's only our perspective that changes, only our ability to see that varies with phase. This reminds us of the limitations of observation, that we see only one face at a time, only one hemisphere, and must infer the whole from the parts, must reconstruct the complete reality from fragmentary glimpses. The entire coma brightness shows rotational modulation, a gentle pulsing, expanding and contracting in luminosity, breathing with the nucleus heartbeat. This isn't just the nucleus light varying, but the total system, nucleus plus coma, responding as one to the rotational cycle. The slow rotation allows us to separate these effects, to distinguish nucleus contribution from coma contribution. If the rotation were much faster, several hours or less, these effects might blur, might become indistinguishable. But at 1616 hours, there's time, patience, space to observe and analyze each component distinctly. From light curve asymmetry, from the fact that the two peaks in each cycle aren't quite identical, that one maximum is slightly brighter than the other. Astronomers infer the spin axis orientation. They build models, computer simulations, that predict what we should see for different axis tilts, different obliquities, and compare these predictions to observations. The best match, the model that most closely reproduces what we actually see, likely reflects reality, gives us the true orientation, invisible but deduced, unknown but knowable through patient analysis. High obliquity means the spin axis points far from perpendicular to the orbital plane, creates seasons, long periods where one polar region receives sustained illumination while the other languishes in darkness, then reversal, switching, as the comet moves along its trajectory. This drives seasonal outgassing patterns, variations that play out over weeks or months, distinct from but complementary to the rapid 16.16-hour rotational variations, multiple timescales, multiple rhythms, all interacting, all contributing to the complex behavior we observe. That 3-eye atlas spins slowly, taking 16.16 hours per rotation, places it in rare company among small comets. Most nuclei we've studied thoroughly, through spacecraft visits or detailed Earth-based campaigns, rotate faster. 5 to 10 hours is typical. Some spin even faster still, just a few hours per rotation, rotating rapidly enough that material near the equator feels significant centrifugal force, reducing the effective gravity, making it easier for dust and chunks to lift off, to escape into space. But 3-eye Atlas resists this trend, maintains its slow pace, its patient rhythm. Why this difference? Several possibilities emerge. Perhaps interstellar comets form differently, accrete more gently, without the violent impacts that might spin up solar system comets during the chaotic planet formation era. Or perhaps slow rotators exist in both populations, but we've simply not observed enough interstellar objects yet to know their true distribution. With only a handful of confirmed interstellar visitors, 2 comets, 1 asteroid-like object, statistics remain uncertain. Each new measurement, each new interstellar object discovered and characterized, refines our understanding, narrows the possibilities. This slow spin might genuinely preserve primordial angular momentum, the rotation rate from birth, from initial formation. Imagine the earliest moments, dust and ice grains in a protoplanetary disk, colliding, sticking, gradually building larger aggregates. Each collision transfers momentum, angular momentum, spin. But if those collisions are gentle, low velocity, the net spin accumulates slowly. The final rotation period depends on countless small impacts, their speeds, their angles, their randomness, for a body forming in a quiet disk region, where turbulence is low, where collisions are soft. Slow rotation emerges naturally, inevitably. Then ejection into interstellar space. However it occurred, whether gravitational scattering by a giant planet, or slow migration through disk resonances, or passage near the forming star itself, the process releases this body into the galaxy, and in interstellar space, conditions preserve that primordial rotation. There's nothing to change it. The interstellar medium contains approximately 1 atom per cubic centimeter in dense regions, far less in typical regions. Such low density means effectively no collisions, no impacts, nothing to transfer angular momentum. The radiation pressure from starlight is too weak, too diffuse, to significantly affect rotation. So the nucleus spins on, unchanged, unaltered, conserving its angular momentum across light years, across eons, billions of years perhaps. This body might have formed when the universe was younger, when the galaxy had different structure, when our own solar system didn't yet exist. And all that time, all those billions of rotations, perhaps 500 billion complete turns if it's truly several billion years old, the period remained constant, 16.16 hours, 16.16 hours, 16.16 hours, an ancient metronome, a cosmic clock, keeping time through the darkness, through the lonely voyage between stars, that no significant period change appears over months of observation, that the upper limit is less than 0.01 hours, less than 36 seconds of variation, tells us the outgassing torques are remarkably balanced. Any asymmetry in volatile distribution, any concentration of active areas on one hemisphere, would create net torque, would try to spin the nucleus up or down, alter its rotation. But we see none of this, suggesting either that active areas are symmetrically distributed, balanced across the surface, or that torques from different regions cancel, oppose each other, some to nearly zero. This rapid spin-up, acceleration of rotation, occurs on some active comets. We've observed it, measured it, seen rotation periods decrease by minutes or even hours over a single apparition as outgassing torques act cumulatively, spinning the nucleus faster. But 3i Atlas shows no such behavior, remains stable, constant. This suggests either low activity levels, modest outgassing that creates weak torques, or again, that balanced distribution, geometric arrangement that prevents net acceleration. For the nucleus to resist these torques, to maintain period stability, it must be coherent, a rubble pile, a collection of loosely bound fragments, might change rotation more easily, might respond to even weak torques. But a monolithic nucleus, or one that's loosely bound but still structurally integrated, resists, maintains its spin state despite the forces acting upon it. The light curve stability supports this. No tumbling, no complex rotation, no nutational wobbles, just clean, regular, periodic variation. A double-peaked curve that repeats precisely, rotation after rotation. No evidence of contact binary tumbling. Two bodies in contact, touching but distinct, often show complex light curves, multiple periods, irregular variations as they wobble, as gravitational and structural interactions create complicated dynamics. But 3i Atlas shows none of this complexity, suggesting either a single monolithic body, or if bilobate, two lobes so firmly connected that they rotate as one, move as one, present as one coherent object. The light curve shape holds stable across filters, red wavelengths, visible wavelengths, even extending into the near-infrared. All show the same modulation, the same amplitude, the same period. This wavelength independence confirms the geometric origin, that we're seeing shape, rotation of an elongated body, rather than compositional variations, surface patches of different color or reflectivity rotating into view. If the latter dominated, we might see different periods in different wavelengths, but we don't. We see consistency, uniformity, geometric control. Near-infrared observations prove especially valuable. At these longer wavelengths, dust scattering is less efficient. Coma contribution decreases, allowing the nuclear signal to dominate, to emerge more clearly, confirming that the observed modulation truly comes from the nucleus, from the solid body, not from brightness variations in the surrounding cloud. This nucleus-dominated signal gives confidence, ensures that the 16.16-hour period truly reflects nuclear rotation, the physical spin of the solid object at the heart of the coma. Careful analysis must subtract coma contribution, profile fitting, examining how brightness varies with distance from the nucleus, allows separation. The nucleus light is concentrated, central, while coma light is distributed, extended, falling off with distance according to predictable patterns. By modeling this distribution, by fitting functions to the observed profiles, astronomers can remove the coma contribution, isolate the nucleus, see its true brightness, its pure rotational modulation. And when this clean signal is aligned with jet visibility cycles, the correspondence is striking. Specific jets brighten at predictable phases. Observers learn to anticipate. In 2 hours we should see the northern jet strengthen. At phase 0.6, the spiral feature emerges. This predictability, this clockwork behavior, demonstrates the intimate connection between nucleus rotation and observed activity. They are not independent, not separate, but linked, bound together by geometry and physics into one coherent system. Face-folded images reveal repeating structures with beautiful clarity. Individual images, single frames, show jets, features, details, but with noise, with uncertainty. But when many rotations are combined, aligned by rotational phase and stacked, those real features strengthen, sharpen, while random noise averages away, fades to insignificance. What emerges are the true persistent structures, jets that repeat rotation after rotation, boundaries between active and inactive regions, patterns that are genuine, reliable, reproducible. The Nordic Optical Telescope time series captured complete cycles. This observatory, on La Palma in the Canary Islands, pointed at 3i Atlas for hours at a stretch, taking image after image, creating sequences, movies essentially, of the brightness evolution, watching the curve rise, peak, fall, trough, rise again. One complete 16.16-hour cycle documented in detail, then another, building the data set that would confirm the period, constrain the amplitude, reveal the shape of this ancient heartbeat. At closest approach, when 3i Atlas passed nearest Earth, Keck Observatory activated its adaptive optics system. This remarkable technology, using deformable mirrors that change shape hundreds of times per second, corrects for atmospheric turbulence, sharpens images to near theoretical perfection. And through this system, the nucleus was resolved, separated visually from the coma, appearing as a distinct point source, a stellar image amid the surrounding glow. This resolution allowed direct size estimation, direct measurement uncomplicated by coma contamination, yielding that 4 to 8 kilometer diameter estimate. These numbers assume a low albedo, dark surface reflectivity, around 0.04 to 0.06, meaning only 4 to 6% of incident sunlight reflects back, the rest absorbed. The assumption comes from measurements of other cometary nuclei, from spacecraft visits showing surfaces dark as asphalt, as charcoal, covered in complex organic molecules, radiation-processed materials that absorb light efficiently, convert it to heat. These dark surfaces are the norm for comets, for bodies that have travelled through space for billions of years, exposed to cosmic rays, to ultraviolet radiation, to the slow chemical transformations that darken and redden primitive materials. From the rotational light curves, from their precise shape and amplitude, scientists construct mathematical models of the three-dimensional form. These ellipsoid models, simple geometric shapes, prolate spheroids stretched along one axis, fit the observations remarkably well. Axis ratios of 1.5 to 2.1 emerge from the fitting, meaning if one dimension measures 8 kilometers, another measures perhaps 4 or 5 kilometers. This elongation, this departure from spherical symmetry, creates the brightness variations we observe. More surface area presented when the long axis points toward us. less when we see the narrow profile. But such a shape, rotating at 16.16 hours, would not naturally form from hydrostatic equilibrium. A fluid body, or one soft enough to flow over time, would relax into a sphere or oblate spheroid, flattened at the poles by centrifugal force. The fact that 3i Atlas maintains elongation, maintains shape that deviates from equilibrium, tells us about strength, about internal structure. The nucleus must possess cohesive strength, must be held together by forces beyond mere gravity, perhaps primordial ices, water ice strong enough to resist deformation at the cold temperatures of interstellar space, or perhaps organic cements, complex molecules binding grains together, or even metals, though less likely in a comet, iron or silicate frameworks providing structural rigidity. The outgassing torque, the mechanical push that jets exert as they erupt from the surface, proves insufficient to alter the period significantly. We can calculate expected torques, estimate the forces based on observed outgassing rates, and compare them to the moment of inertia, the rotational resistance of the nucleus. And we find that expected changes over months of observation should be detectable, should show up as period variations. Yet they don't appear. This tells us either that torques are weaker than estimated, that our understanding of the outgassing is incomplete, or more likely that they're balanced, that jets on opposite hemispheres or at different locations create opposing torques that cancel. Maintaining rotational equilibrium, the non-gravitational acceleration. This is the orbital perturbation caused by outgassing. When gas erupts from the nucleus surface, it carries momentum and, by Newton's third law, pushes back on the nucleus, changing its velocity slightly, altering its orbit minutely. For most comets, this is measurable, affects the predicted position, must be accounted for in trajectory calculations. And for 3i Atlas, this acceleration exists, has been measured, but critically, it shows no rotational signature, no 16-16-hour variation, no modulation in phase with the nucleus spin. This absence of rotational signature in the non-gravitational force suggests that the net thrust averages to approximately the same value over each rotation, even though individual jets strengthen and weaken with phase, even though outgassing varies dramatically across the surface. The total momentum transfer, the vector sum of all jets, remains relatively constant. This implies distributed activity, multiple source regions spread across the nucleus, not concentrated on a single active hemisphere that would create strong rotational modulation in the thrust. Yet we do see the pulse rhythm in overall brightness evolution. We can watch the comet as a whole brighten, approaching the sun, increasing in total luminosity, and within that general trend, that smooth curve, we can detect the 16.16-hour variations, the heartbeat persisting, continuing, never ceasing, from the outer solar system, when the comet was still faint, still distant, through perihelion passage, the closest approach when activity peaked, and then outward again, receding, cooling. The pulse continued, a faithful companion, a steady rhythm underlying all the changes. Pre-perihelion observations, those conducted before closest solar approach, showed weaker light curve amplitude. The comet was less active then, cooler, fewer volatiles sublimating, jets weaker, more subtle. Yet even then, careful photometry revealed the 16.16-hour period, detected the modulation, saw the pulse. This demonstrated the robustness of the signal, proved it wasn't merely an artifact of high activity, but a fundamental property of the nucleus, visible at all activity levels, from distant quiescence to perihelion vigor. Post-perihelion, after that close passage, after the sun's intense radiation had heated the nucleus, driven off layers of material, enhanced sublimation rates, the light curve amplitude increased, the same 16.16-hour period, but larger variations, stronger pulses, deeper troughs and higher peaks. This amplitude increase reflected higher activity, more vigorous outgassing, creating stronger contrast between active and inactive regions, between areas facing the sun and those in shadow. The seasonal enhancement, this strengthening of rotational modulation, came as active areas became more productively illuminated, as thermal waves penetrated deeper, as subsurface ices began participating in sublimation. Now consider the diurnal cycle on the nucleus surface, day and night, not measured in 24 hours like Earth, but in 16.16 hours, that being the local day on 3 Atlas. Imagine standing on that surface, watching the sun rise, slowly, taking hours to climb from horizon to zenith. The temperature rises. The ice beneath your feet begins to sublime. Gas erupts, dust lifts, jets form, peak brightness, peak activity, then sunset, gradual cooling. The gas production wanes, jets fade, darkness falls, temperatures plummet, and all grows quiet until 16 hours later, dawn returns and the cycle begins anew. This diurnal cycle drives volatile sublimation patterns in wave-like fashion. The supervolatiles, CO2 and CO, carbon dioxide and carbon monoxide, respond quickly to temperature changes. They sublime at low temperatures, react immediately to sunrise, create the early morning jets, the dawn activity, water ice. The dominant volatile in most comets requires higher temperatures, needs more sustained heating. It activates later in the local day, perhaps hours after sunrise, when the surface has absorbed enough solar energy to heat the subsurface, to reach the depths where water ice resides. So the sublimation pattern evolves through each 16.16-hour rotation. First come the CO2 and CO jets, sharp, responsive, tied closely to the rotation phase. Then water sublimation builds, more gradual, less sharply phased, creating a more sustained background, and dust release, depending on gas production to drag it aloft, follows the volatile pattern, episodic with the supervolatiles, more sustained with water. All of this choreographed by rotation, by the 16.16-hour heartbeat, by the ancient rhythm that governs every process on this interstellar visitor. The jet collimation, the remarkable narrowness of these streams, depends critically on slow rotation. If the nucleus spun rapidly, say every 2 or 3 hours, jets would sweep across the sky quickly, would smear, would blur into broader fans, losing their sharp definition. But at 16 hours, each jet remains nearly stationary relative to the stars, maintains its orientation for hours, allows the gas and dust to stream outward in a coherent beam, a focused thread, a structure that persists, that remains identifiable rotation after rotation. This slow rotation preserves jet coherence, allows persistent structures that we can track, study, analyze over extended periods. Phased stacking enhances faint jet visibility through a beautiful statistical process. Imagine you have 20 images, each showing a jet barely above the noise. Difficult to see, uncertain. But if all 20 images are taken at the same rotational phase, when the jet points in the same direction, you can align them, stack them, add their signals together. The real jet, present in the same location in all images, reinforces, strengthens, grows to 20 times its single image brightness, while random noise, different in each image, averages toward zero, fades to insignificance. What emerges is structure, features too subtle for single observations, revealed through the power of repetition, through the gift of multiple rotation cycles. The November 2025 observation campaigns exemplified coordinated effort. Professional observatories allocated time specifically for 3i Atlas, Keck, Gemini, the Nordic Optical Telescope, others, all pointing at this visitor, capturing rotation after rotation, and simultaneously, amateur astronomers worldwide, in backyards, on suburban streets, in rural dark sky sites, contributed their observations, their light curves, their carefully calibrated photometry. Together they covered multiple complete 16-16-hour cycles, ensuring no phase went unobserved, no part of the rotation remained hidden. This professional amateur collaboration refined the period to exquisite precision. Early estimates, based on limited data, suggested periods ranging from 15.5 to 17 hours. But as more data accumulated, as phase coverage improved, the estimate converged, narrowed, settled on 16 hours, with uncertainty of perhaps 0.01 hours or less. This precision arose from combining quantity and quality. Many observations spanning months, each individually perhaps uncertain, but collectively definitive, overwhelming, indisputable. Period aliasing, this potential pitfall, had to be carefully eliminated. Aliasing occurs when sampling is irregular, when gaps exist in observations, potentially creating false periods. Harmonics or subharmonics of the true period that might masquerade as the fundamental. To rule this out requires dense sampling, observations that catch the comet at many different rotation phases, that leave no large gaps, no opportunities for false signals to hide. The November campaigns achieved this, and combined with earlier data, confirmed that 16.16 hours was genuine, real, the actual rotational period. A harmonic at 8.08 hours, exactly half the true period, emerged in some early analyses. This would correspond to a single peaked light curve, one maximum and one minimum per rotation, which might occur if the nucleus was spheroidal with a single bright spot, or had some other simple asymmetry. But closer examination, looking at the detailed light curve shape, revealed the double-peaked structure, 2 maxima per 16.16-hour cycle, definitively establishing that 16.16 hours, not 8.8 hours, represented the complete rotation, the full cycle. The distinction between sidereal and synodic periods matters for precision work. Sidereal period is rotation relative to the fixed stars, the true spin rate of the body itself. Synodic period is rotation relative to the sun. What an observer on the nucleus surface would measure as the day length, including both the rotation and the orbital motion, for objects far from the sun, moving slowly in their orbits. These differ negligibly, but for comets passing through the inner solar system, moving rapidly, the distinction becomes measurable. Astronomers must carefully specify which they're measuring, apply corrections to derive the true sidereal rotation from synodic observations. Similarly, Earth's orbital motion affects observations. Our planet moves, changes position, alters viewing geometry continuously. These effects must be accounted for, light travel time corrections applied, geometric factors considered, all to ensure that the measured 16.16-hour period truly reflects the nucleus rotation, not artifacts of our changing perspective, of our motion through space as we observe. The nucleus pulse influences coma density waves in subtle but detectable ways. When outgassing strengthens during a particular rotation phase, it injects more material into the coma, creates a local density enhancement, a small increase in the number of gas molecules and dust particles per cubic meter. This enhancement doesn't stay put. It propagates outward, carried by the expanding gas. Moving at typical velocities of hundreds of meters per second, perhaps 500 to 1,000 meters per second for the gas, slightly slower for dust dragged along. These density waves ripple through the coma like waves on water, spreading, expanding, moving radially outward from the nucleus. Each subsequent rotation, each 16.16-hour cycle, injects another pulse, another enhancement, creating a rhythmic pattern, a series of shells, density maxima separated by 16.16 hours times the expansion velocity, thousands of kilometers of separation in the inner coma. These structures are subtle, hard to detect, requiring careful image processing, but they're real, genuine manifestations of the rotational heartbeat propagating through the entire comet system. Even the tail structures respond, the anti-tail, that peculiar feature appearing to point toward the sun, caused by dust grains in the orbital plane catching light at specific angles, shows slight modulation with rotation, as does the main tail. The dust and gas streams swept back by radiation pressure and solar wind, brightness variations, subtle shifts in structure, tied to when and where material is released, which depends on rotation, on which active areas face sunward at any moment. So the tails preserve a memory, an echo of the rotational state hours or days earlier, when the material composing them was ejected. Color variations prove subtle, requiring precise photometry and multiple filters, simultaneously if possible, to eliminate brightness changes and isolate true color shifts, but they exist. Green emission from C2, from diatomic carbon, appears stronger from the more active hemispheres. This green emission, a characteristic cometary feature visible even in small telescopes, comes from carbon-bearing molecules photo-dissociated by sunlight, broken apart, with the fragments emitting green light before dissociating further. More active regions, outgassing more vigorously, produce more parent molecules, leading to more C2 and thus stronger green emission. This creates subtle color modulation, the comet appearing slightly greener when active regions face Earth, slightly less green when they rotate away. Dust release becomes episodic with rotational facing in a beautiful example of cause and effect. When an active region rotates into direct sunlight, into the afternoon of its local day when surface temperatures peak, gas production surges. The increased gas flux can entrain larger particles, drag more dust aloft, overcome gravitational binding more effectively, so dust production peaks, creates bright jets, creates enhancements in the coma brightness. Then as that region rotates into evening, into sunset, into the long cold night, gas production wanes, dust entrainment decreases, the jets fade, weaken, nearly disappear. This episodic behavior, pulsing with the 16.16 hour rhythm, creates the observed brightness variations, the heartbeat we detect across millions of kilometers. The slow rotation, this 16 times 16 hour patient cadence, preserves jet coherence over not just hours but days. A jet formed when a particular active region faces the sun might remain visible, identifiable, traceable in images for several rotations, for days of Earth time. This persistence allows detailed study, allows tracking of jet evolution, allows scientists to see how individual structures change, evolve, weaken or strengthen over timescales long compared to the rotation period. These would be impossible with rapid rotation, where jets would appear, sweep across the sky, and vanish within hours, and showed how rotation controlled every aspect of activity, just as we infer for 3 Atlas. The similarity in phased outgassing between solar system comets and this interstellar visitor proves fascinating. Here we have a body formed light years away, under potentially very different conditions, around a different star, perhaps in a protoplanetary disk with different composition, different temperature profile, different dynamics, yet its behavior, its rotational control of activity, its phased jets and brightness variations mirror what we see in solar system comets. This suggests universal principles, physics that operates identically regardless of stellar system, composition that converges to similar outcomes, or perhaps just that comets, wherever they form, represent a common end state, a typical outcome of icy planetesimal formation. The interstellar origin doesn't create something alien, doesn't produce exotic behavior incompatible with our understanding. Instead, we find the familiar, the expected, rotational modulation, phased outgassing, double-peaked light curves, all the features we've learned to recognize from studying solar system comets appear here too, in this visitor from beyond. This familiarity allows confident interpretation, lets us apply decades of cometary science knowledge, transfer understanding from one population to another, bridge the gap between the local and the galactic. This spin state, this 16.16-hour rotation, likely reflects formation conditions in that distant protoplanetary disk. Perhaps the region where 3I Atlas formed was particularly quiescent, low turbulence, gentle collisions, allowing accretion to proceed slowly, building up mass without imparting high spin. Or perhaps the body formed in the outer disk, where material moved more slowly, where orbital velocities were low, where angular momentum per unit mass was reduced compared to the inner disk. These formation scenarios, these possibilities, can be tested, refined. As we discover more interstellar objects, as we build statistical understanding of their properties, their rotation rates, their compositions, their orbital characteristics, low excitation from gentle ejection makes physical sense. If a body is gravitationally scattered violently, passing very close to a giant planet, experiencing intense tidal forces, it might gain rotational energy, might be spun up by tidal torques, emerge into interstellar space rotating rapidly, chaotically. But if ejection is gentler, occurring over longer timescales, through gradual migration, through resonant interactions that slowly raise the orbit, then rotational state remains nearly unchanged, primordial spin preserved. This scenario fits 3I Atlas, fits the slow rotation, the stable period, the lack of tumbling or complex dynamics. And once in interstellar space, once liberated from planetary influence, once drifting between the stars, there's truly nothing to change the rotation. The interstellar medium, even in relatively dense molecular clouds, contains only hundreds or thousands of atoms per cubic centimeter. For a kilometer-sized nucleus, the collision rate with interstellar atoms is negligible, might add or remove 1 or 2 atoms per second from the surface, utterly insufficient to affect rotation. Cosmic rays, high-energy particles, penetrate the surface, cause chemical changes, but they carry negligible momentum, can't torque the nucleus, can't alter its spin. Starlight from the galaxy, diffuse radiation from all the stars combined, exerts radiation pressure, but again, too weak, too distributed, to create significant torques on a tumbling irregular body. Only if the nucleus had enormous reflective sails, had extreme shape asymmetry, like galactic starlight matter, and the interstellar magnetic field, though it permeates the galaxy, couples only weakly to neutral matter, can't grip an uncharged icy nucleus and torque it, so the rotation from formation is preserved across the parsecs, across the ages. Billions of years of travel might be the reality. If 3I Atlas formed in a stellar system several hundred light-years distant, a plausible distance given galactic stellar densities, and if it travelled at typical ejection velocities of a few kilometres per second, then the journey might span hundreds of millions or even billions of years. During all that time, during all those billions of rotations, the period remained unchanged. 16.16 hours, 16.16 hours, 16.16 hours, a cosmic clock unwinding, but never varying its rate, never deviating from its ancient rhythm. This pulse rhythm truly becomes the heartbeat of an ancient body in the most literal sense, beating steadily, unchanging, since before Earth's continents formed their current shapes, since before the dinosaurs, since before complex life, perhaps since before the sun itself ignited. If 3I Atlas is truly that old, each rotation a heartbeat, each pulse a reminder of unimaginable age, of journeys beyond comprehension, of loneliness and isolation measured in light years and eons. All this data flows into databases, digital archives maintained by astronomical organizations, the Minor Planet Center, the Planetary Data System. Others, light curve databases, preserve not just the final period, not just summary statistics, but the actual photometric measurements, thousands of them, each time stamped, each calibrated, each representing a single brightness measurement at a specific moment. Future researchers, perhaps decades from now, can retrieve this data, reanalyze it, apply new techniques, test new theories, extract information we haven't yet imagined seeking. Future observations will continue tracking long-term stability as long as the comet remains bright enough. As it recedes, moving outward from the sun, back toward the depths from which it came, it will fade, dimming month by month, eventually reaching a point where even the largest telescopes struggle to detect it, where photometry becomes impossible. But until then, observers will continue monitoring, watching for any period change, any evolution, any hint that the rotational state is not perfectly stable. Any period change, even a tiny one, would indicate mass loss asymmetry, would tell us that material is being removed preferentially from one region, creating unbalanced torques. This would reveal details of outgassing distribution, of which areas are most active, of how sublimation varies across the surface. The upper limit on period change, the stringent constraint that no variation exceeds 0.01 hours, therefore constrains outgassing distribution, tells us that activity must be relatively balanced, symmetric, distributed such that net torques remain small. Through rotational synthesis, the combination of observations from many viewing geometries, from many rotation phases, astronomers attempt nucleus mapping, creating maps of surface features, identifying active and inactive regions. This technique, developed for asteroids and refined for comets, uses brightness variations, changes in how the object looks from different angles, to infer surface properties. Where are the bright spots, the dark regions, the active areas? For 3i Atlas, estimates suggest active area fractions of 10 to 30%, meaning that only 1/10 to 1/3 of the surface actually produces significant outgassing. The rest remains dormant, covered in lag deposits perhaps, layers of non-volatile dust and organics left behind as ice's sublime. These lag deposits build up over time, insulating the ice beneath, preventing further sublimation until they crack, until jets break through, until fresh ice becomes exposed. This creates the patchy activity, the discrete jets, the focused structures we observe rather than uniform outgassing from the entire surface. The light curve, in its shape and amplitude, encodes information about the inertia tensor, a mathematical object describing how mass is distributed, how the body resists rotational acceleration about different axes. A perfectly spherical uniform body has a simple inertia tensor, equal values along all axes, but an elongated body, one with mass concentrated along the long axis, has a different inertia tensor, one that reflects that asymmetry. By fitting models to the light curve, by matching predicted brightness variations to observed ones, scientists constrain the inertia tensor, learn about internal mass distribution. This connects to fundamental questions of structure. Is the nucleus homogeneous, uniform throughout, or differentiated, with denser material perhaps concentrated toward the center, or layered, with composition varying from surface to core? The stable rotation, the unchanging period, the clean single-peaked or double-peaked light curves suggest relative homogeneity. No evidence for large-scale internal structure that would create complex rotational dynamics, precession, wobbles. Instead, we see simplicity, regularity, suggesting internal uniformity, or at least smooth gradients rather than sharp discontinuities. Slow rotators prove more common among larger nuclei. This is an observed trend in solar system comets. Smaller bodies, those just hundreds of meters or a few kilometers across, often spin rapidly, periods of a few hours, while larger bodies, those exceeding 5 or 10 kilometers, tend to rotate more slowly. The reason might be structural. Larger bodies have more mass, more self-gravity, can hold themselves together better. Smaller bodies, especially if loosely bound, can't survive rapid rotation. Centrifugal forces would overcome weak gravity, tear them apart, disperse them into rubble. So small bodies that rotate rapidly must be strong, coherent, while large bodies can afford slow rotation even if weakly bound. The size-rotation relation, this trend of larger bodies rotating more slowly, now extends to interstellar objects through 3 Atlas, with its estimated 4 to 8 kilometer diameter and 16.16 hour period. It fits the expected trend, falls where solar system comets of similar size would fall on a size rotation diagram. This suggests universality, suggests that the physics governing cometary rotation operates the same way, regardless of where a body formed, regardless of stellar system. The same forces, the same constraints, the same evolutionary pathways lead to similar outcomes. This is deeply reassuring. Tells us that our understanding, developed from solar system objects, can extend outward, can apply to the broader galaxy. For low-density bodies, those with bulk densities below 500 kilograms per cubic meter, less dense than water, porosity becomes essential. These are not solid blocks of ice, but sponge-like structures, networks of voids and passages, empty spaces accounting for perhaps half the volume or more. Such porous structures have weak tensile strength, can't withstand high centrifugal stress. Rapid rotation would pull them apart, disperse them into fragments. So slow rotation becomes necessary. 1616 hours provides gentle enough conditions that even a weak porous structure can survive, can maintain integrity, can hold together despite internal voids and fractures. This porous structure might arise from pristine accretion, from the original formation process. Imagine icy particles, each perhaps millimeters to centimeters across, drifting in the protoplanetary disk, colliding gently, sticking together through sintering, through ice welding where surfaces bond on contact, building up slowly, layer by layer, without ever compressing fully, without forcing out the voids. This creates a body that's mostly structural ice, with void spaces preserved, primordial porosity locked in since formation, never eliminated by subsequent processing. The rotational pulse reveals internal homogeneity through its purity, its simplicity. If there were large internal voids, if the interior were highly irregular, asymmetric, we might see complex rotational behavior, precession, nutation, wobbles superimposed on the main rotation, but we see none of this, just clean periodic variation, suggesting that while the body may be porous, it's uniformly porous, homogeneously structured, without large-scale asymmetries that would complicate the dynamics. No subnuclei have been detected, no smaller bodies orbiting within the coma, no companions to the main nucleus. Careful searches, examining images for point sources moving with the comet, looking for brightness variations that might indicate mutual events, occultations or eclipses between components, have found nothing. Just one nucleus, solitary, alone, spinning in isolation. This rules out certain formation scenarios, rules out recent tidal disruption that might split a body into multiple fragments, suggests instead that 3I Atlas has remained intact, single, coherent throughout its journey. No satellites either, no moons orbiting the nucleus, which makes sense given the small size. The Hill sphere, the region where a body's gravity dominates over the sun's, is tiny for kilometer-sized objects. Any satellite would need to orbit very close, within just a few kilometers, where tidal forces are strong, where stability is questionable. And the formation of such satellites seems unlikely, would require specific capture scenarios or formation mechanisms that probably didn't occur. This stable spin excludes recent disruption quite definitively. If the nucleus had suffered a collision, a splitting event, a catastrophic disruption within the last few orbital periods, we'd see evidence, complex rotation, tumbling, perhaps multiple components, but instead we see ancient stability, primordial calm, rotation that looks undisturbed, unchanged since formation. This tells us the interstellar journey was uneventful. No collisions, no close encounters with stars or planets that might have disrupted the structure. The pulse itself becomes a diagnostic of structural strength in elegant fashion. How much brightness variation can a body show before it must be solid? Before it must have significant tensile strength? The amplitude, the 0.3 to 0.5 magnitude variation, implies an axis ratio of 1.5 to 2.1, which requires some strength to maintain. A completely fluid body or a loose rubble pile might not maintain such elongation, might relax towards spherical symmetry. So the pulse tells us about material properties, about cohesion, about whether this is a coherent object or a loosely bound collection. This data informs models of extrasolar nucleus evolution in important ways. How do cometary bodies form in other stellar systems? Do they follow the same pathways as solar system comets? Do protoplanetary disks around other stars produce similar outcomes? Each interstellar object we study, each measurement we make, constrains these models, tests predictions, reveals whether planet formation is universal, or whether each system is unique, each rotation period measured, each composition determined, each trajectory calculated, adds to our understanding not just of comets, but of planetary systems in general. As Throat Atlas recedes from the Sun, as it moves back toward the interstellar depths, the rhythmic signal fades, not in period, not in regularity, but in detectability. The comet grows fainter, dimmer, more distant, requiring longer exposures, larger telescopes, more careful analysis to extract the signal from the noise. The brightness pulse continues. We know it continues. The nucleus still rotates, still turns its faces toward the distant sun. But our ability to measure it diminishes, fades, approaches the limit of feasibility. The final cycles were captured in late 2025, in November and December, pushing photometric capabilities to their limits. Observers used the largest available telescopes, integrated for hours, combined multiple nights of data, extracted every possible photon from the fading signal, and they succeeded. Measured rotation cycles even as the comet dropped below 20th magnitude, became fainter than all but the most patient observations could reach. These final measurements, these last rotations captured, complete the data set, provide the long baseline needed to constrain period stability over the entire apparition, before the comet becomes too faint for photometry, before it drops below the detection threshold even for the largest telescopes. These final observations are archived, preserved, added to the permanent record, future apparitions. If the comet's orbit ever brings it back, decades or centuries from now, will allow comparison, will reveal whether the period remained stable over the long gap, whether anything changed during the decades in the outer solar system or the centuries in interstellar space. Now let us drift deeper still into the implications, into what this heartbeat means, this ancient rhythm, this 16-16-hour pulse connects us to the deep past, to epochs before our world existed, to the era of stellar formation, of planetary birth, of cosmic dawn in some distant region of the galaxy. Every rotation we measure, every pulse we detect, echoes across those eons, brings news from unimaginable distances and times. The patience of this rotation, the slowness, invites our own slowing, our own patience. Feel your breath naturally sinking to the cosmic rhythm, not literally, not requiring 16 hours per breath, but symbolically, spiritually, letting go of urgency, releasing the need for speed, accepting the ancient cadence of the turning nucleus, the slow waltz through space, the measured revelation of hidden faces, ancient nucleus heartbeat. These words become a rhythm, a mantra, ancient nucleus heartbeat, pulsing steadily through the void, through the darkness, through the cold, never rushing, never hurrying, just being, existing, rotating with the patience of geological time, of astronomical time, of deep time measured in the turning of galaxies. Slow rotational whisper, another phrase to hold, to contemplate. The nucleus whispers through its rotation, tells its story through brightness variations, through the patient revealing of its shape, its activity, its nature. This is not a shout, not a dramatic announcement, but a whisper, quiet, subtle, requiring attention, requiring patience, requiring stillness to hear. 16-hour quiet cadence, the specific rhythm, the measured beat, 4 of our heartbeats per second, perhaps, compared to 1 rotation every 16 hours for the nucleus. Vastly different timescales, yet both rhythms, both pulses, both patterns of existence. We are fast, the comet is slow, yet both are valid, both are real. Both mark time in their own way. Feel yourself settling now, deeper into rest. The scientific details begin to fade, not forgotten, but receding, becoming less important than the sensation, the feeling, the pure experience of cosmic vastness, of ancient rhythms, of patient rotation continuing, unchanging, through space and time. Phased light serenity, the peace that comes from periodic variation, from knowing that the next pulse will come, will arrive, will happen as surely as the last one did. This reliability, this predictability, this cosmic clockwork brings serenity, brings calm, removes uncertainty, establishes rhythm, creates the foundation for rest, primordial spin piece, rotation that has continued since formation, since birth, unchanged by all the subsequent events, all the distance travelled, all the time elapsed. This is peace, this is stability, this is the calm of conservation laws, of physics proceeding inevitably, of ancient momentum preserved. Your breathing slows further now, deepens. Each exhalation releases more, lets go of more, surrenders more to the darkness, to the quiet, to the vast empty spaces between stars where Three-Eye Atlas drifted, alone, patient, turning slowly, waiting the eons until it would enter another stellar system, encounter warmth, brightness, activity, gentle pulse harmony, the harmony between rotation and outgassing, between spin and structure, between ancient formation and current observation, all in harmony, all aligned, all consistent. This harmony extends outward, touches you, invites you into its rhythm, into its peace, into its ancient cadence, turning rhythm calm, the calm that comes from measured rotation, from patient cycles, from rhythms that do not hurry, do not rush, simply turning, revealing, concealing, revealing again, the same faces, the same features, rotation after rotation, pulse after pulse, heartbeat after heartbeat. Feel the weight of your body, settling, sinking, supported completely. No need to hold tension, no need to maintain alertness, just rest, deep rest, cosmic rest, the rest of an ancient nucleus, rotating peacefully through the void, undisturbed, untroubled, simply being. Heartbeat revelation drift. Each pulse reveals something, then drifts, then reveals again. This is the nature of rotation, of periodic phenomena, revelation and concealment, brightness and dimness, ebb and flow, all drifting, all flowing, all part of the endless cycle, rotational cycle stillness. Even as the nucleus rotates, there is stillness, deep stillness. The rotation is steady, unchanging, predictable. This creates a deeper stillness, a calm within the motion, peace within the cycle, like your breath, which continues, yet within which you find stillness. Nucleus waltz surrender. The nucleus dances its slow waltz through space, 16 16 hours per turn, and you surrender to its rhythm. Let go into its patient cadence. Release into its ancient choreography. Surrender, release, let go. The darkness deepens. Silence grows. Words become less frequent, more sparse. Space opening between them. Vast empty space. Cosmic space. The space through which Three-Eye Atlas travelled for millions of years. Meeting nothing. Encountering only void. Darkness. Cold. Silence. Absolute silence. Broken only by its own slow turning, its patient rotation, its quiet heartbeat. Phased awakening hush, activity that awakens, then hushes, then awakens again. Cycles of activity and quiet, of outgassing and stillness, following the rotation, following the patient rhythm, now hushing, growing quiet, fading toward silence. Spin's patient embrace, rotation that does not force, does not rush, but embraces, holds, maintains, patiently, endlessly. The spin embraces the nucleus, holds it together, provides structure, gives form, patient embrace, loving embrace, eternal embrace. 16 to what 16-hour breath. Imagine breathing that slowly. One inhale taking 8 hours, one exhale taking 8 hours. Impossibly slow. Yet this is the nucleus rhythm, its day and night, its cycle of illumination and shadow, ancient, patient, slow, breath. Longer pauses now, between phrases, between thoughts, space expanding, time stretching, silence becoming the primary texture, words just occasional markers, guideposts in the vast emptiness. Illumination dance integration, light and shadow dancing, integrating into wholeness, the bright hemisphere and the dark, the active face and the dormant, all parts of one whole, integrated, complete, dancing slowly together through space. Active face memory, the memory held in the light curve, the record of which faces are active, when jets appear, where outgassing emerges, memory encoded in data, preserved, eternal, fading now, receding, becoming one with the void, coherent jet persistence, jets that persist, that maintain coherence, that continue, then fade, then return, persistence through cycles, through rotations, through time, now fading, weakening, as distance increases, as the comet recedes. Rotational balance void, balance maintained through rotation, equilibrium preserved, now releasing into void, into emptiness, into the vast spaces, balance becoming stillness, equilibrium becoming peace, rotation becoming rest, primordial inertia flow, the original momentum, the ancient spin, flowing forward through time, unchanging, eternal, now flowing into silence, into darkness, into the deep rest that awaits, heartbeat cosmic solitude, the pulse, the rhythm, in absolute solitude, alone in the cosmos and between stars, no companion, no witness, just the patient beating, the steady rhythm continuing forever, fading now into silence, vast emptiness, endless darkness, infinite patience, ancient turning, quiet pulse, deep peace, eternal turn release. The turning continues, eternal, endless, but you release, let go, surrender into sleep, into rest, into the void. The nucleus turns, you rest, release, drift, interstellar wanderer serenity. 3i Atlas, the third visitor from beyond our solar system, drifting from distant stars, carrying secrets of other worlds, its serenity unbroken, even as jets pulse forth, vaporous tails trailing, one of dust, one of gas, twin veils in the cosmic wind, serenity in motion, serenity in the pulse, inviting you deeper into calm, jet symphony whisper, the outgassing jets, synchronized to the spin, whispering their symphony every 16 hours, ice sublimating, gases escaping, brightness surging, then waning, a whisper from the nucleus, core of ancient ice and rock, formed in the cradle of another sun, now whispering across the void to our telescopes, to our wandering minds. Hear the whisper, feel the symphony, let it lull you, discovery echo fade, echoes of its finding, July's gaze upon the sky, Atlas telescope capturing the faint glow. Now those echoes fade as the comet recedes, hyperbolic path carrying it away, never to return. 1.8 AU from Earth, a safe passage, no collision, just a fleeting visit, echoes softening, memories dissolving into the fade of night. Alien speculation hush, whispers of artificial origins, pulses too regular, too precise, yet nature's hand, rotation's gift. Hush the speculation, embrace the natural wonder, the interstellar messenger, not crafted, but born of cosmic forges. Hush now, let the mystery dissolve into acceptance, into peace. Tail duality balance, two tails, ion and dust, balancing the form, one blue, glowing with solar wind, one white, scattering light. Duality and harmony, push and pull, visibility and shadow, balance extending to your own duality. Wake and sleep, tension and release. Find balance in the tail's silent dance, velocity veil calm, jets escaping at hundreds of meters per second, yet the whole remains calm, unhurried. Velocity veiled in slowness, the 16.16-hour cycle overriding haste, calm prevailing, drawing you into its veil, where speed surrenders to rhythm. NASA gaze integration, eyes of Hubble, of Webb, capturing the pulses, the mysterious signals, integration of data, light curves plotted, rotations mapped. Now integrate into your being, the gaze of science, merging with intuition, with rest, all one, all harmonious. Hyperbolic path release, unbound trajectory, no orbit, just passage, release from gravity's hold, free in the galaxy. You too release from earthly binds, from daily spins, into hyperbolic freedom, drifting outward, unbound, pulsing light eternal, the light that pulses, eternal in its cycle, even as it dims, as perihelion passes, eternal reminder of cosmic constants, of rhythms beyond time, now eternal in your subconscious, pulsing softly as you sleep. Deep space invitation, invitation to join in the deep space journey, millions of years alone, now shared in this moment. Invitation accepted as eyelids grow heavy, as thoughts disperse into the invitation of slumber. Silent witness drift, 3 Atlas, silent witness to galaxies, to nebulae, now drifting past our sun. Witness no more, just drift. You drift with it, into silence, into the cosmic current. Final hush expansion, hush expanding, filling all, their words ceasing, yet only the hush, the expansion, into infinity. Hush, expand, sleep, silence, deep silence, cosmic silence, and in that silence, in that vast emptiness, in that ancient patient darkness, we find ourselves returning, drifting back as if on a cosmic current, as rotation brings us around once more. 16.16 hours completing, a cycle ending, a cycle beginning, seamlessly, endlessly,